And here we go. Sound check. Hello, everyone, our brothers and sisters in tech. Hello, all over the world. I see lots of people are waiting for start of this awesome conference. First of all, greetings from Adina from Nice, from France. I hope you can hear me and see me well. Let me know if you are not. I mean, write something in chat that you are here, that you're. What do you feel about this event? And especially, I really love to know where are you from? I mean, where you now? You can write the name of your city, your country, and maybe even the room you are watching us from. That's what we usually do. I am so excited. Let me see the chat. I feel like no problems with any sound and video. And yeah, Global Summit for Node.js Developers 2023 by Geekle has started just now. And I invite here our beautiful community manager, Anna. Hello, Anna. How are you?
Hello everybody. I really love to see all of you here. It's our Global Summit for Node.js 2023, and we spent a lot of time collecting and gathering the best information, the best topics for you today and tomorrow.
Yeah, cool. Nice to see you again. How do you feel? Where are you now? Tell us more about yourself and what you did during this preparation of the event.
Yes, of course. So I'm in India now. So hello from sunny and not that hot yet India. I'm in Hyderabad. We spent really long 4 months preparing, mostly 4.5 months preparing Global Summit for Node.js. I'm really grateful to everybody who helped me, because of course it's speakers, it's program committee members, it's just our attendees who shared their ideas and said, we saw that and now we want that. So yeah, we really appreciate your comments. We really love your feedback. So don't worry and don't be shy to text me anytime and let you know we want to have that. We want to see that. And I would love to find that for you.
Thank you, everyone who took participation in preparing this event. Yeah, and usually people. Well, this is our third Node.js event, and I'm excited that we still work in this project and still deliver this. You guys really used to see here at the screen at the beginning of the event our Nick. He's technical moderator and he's my partner at this project, but unfortunately he has no power. He has weak network because of this Russian bombings. So unfortunately he doesn't have any nice place with a good background for you. So he is here, he helps us, but unfortunately, he is not in stream today. Maybe he will greet you in the chat. But I'm lucky to invite Paul here. He's our partnership person, and he will tell us something about guys who help us, who sponsor us, right?
Yeah, we wanted to say thank you to everyone who joined us today, and thank you for every speaker, everyone who actually contributed into preparing this event, to the program committee, and to every person who helped us with topics, because we've gathered some feedbacks from the community, and we're really happy and we're lucky that we have your input into this preparation. And we wanted to say thank you to our longtime partners and our sponsors from InfluxDB. And I just wanted to kind of tease the presentation from Jay Clifford. It's going to be, I believe it's going to be fourth presentation, either the first one of the next block or the, I guess like in a couple of hours, I would say. Yeah, and probably if you work with Node, you know the InfluxDB, their database. And if you have not tried it yet, we will have a link for the free registration for their trial in the chat. So if you need time stamped and time sensitive data, if you work with IoT devices and maybe some kind of big infrastructures, definitely check it out, and it will actually help you to concentrate on the features that you need to deliver and not messing with infrastructures and setting it up. Yeah. So thank you, Influx Data. Yeah, and I guess that's it from my side.
Yeah. Thank you, Paul. And as always, I read this chat and it really touched me a lot. Italy, Ukraine, Romania, Greece, Estonia, Romania again, Latvia, and Crete, Greece, Brazil, Israel, Estonia, man, Poland, India, Afghanistan, Australia, even Australia. Oh, man, God. So many people from all around the world. I'm so happy we can do it all together. Anna, tell us more about what's gonna be at this event. We have a few minutes more to share about how this event is designed, what the idea of this event.
Of course. So we have 2 days. Today we have a day for junior developers, and not only. So you can just find basic information, but with really interesting inputs, with really interesting use cases, and something that was updated, and you have to know about that. Also, we will have 4 blocks today. You will meet so many amazing speakers, just trust me, and I really hope to get your feedback after we'll share forum with you after day 1. Also, tomorrow we have day for senior developers, and be sure you'll get a lot of deep content with use cases, how really you have to take this code, put it there, and which result you will get. And checking and preparing that information, it was very stressful and important, because every time we are trying to upgrade level of the event, and I really hope that you will like it, because we will have with us members of Node.js Foundation, from Node.js technical team. So I really hope that they can satisfy your willing to know more and to practice more.
Yeah, thank you. And more people come in Sri Lanka, Nairobi, Kenya. Israel is here saying hi, and like more and more people from Canada too. I gotta mention, so once we have today is more like basic, information or basic level knowledge, and tomorrow it's quite deep or like, I don't know, senior level. I know it's quite expensive today to buy tickets for tomorrow, but that's why we decided to share 5 tickets to anyone who grabs first, gets it, like on very starting price at as low as $99. You can use the promo code. We'll share 99. Yeah, you use this promo code and grab on the very low price and join tomorrow. And we also will.
And the most active one, who will comment and who will ask question, who will be really active today, will get 5% will get free tickets for tomorrow. So just comment, just ask your question and get the ticket for tomorrow for free.
That's probably personal gift or reward from Anna. Yeah, just be active. Yeah.
Don't forget to like, comment, and share. It also matters.
As always, people have to say it. Yeah. Anyway, I want to thank to our speakers. We have 20, I believe, 8 speakers, right?
Yes.
28 speakers. Thanks to everyone who joins this project. By the way, I think you know that, but I'll always mention this. You helped us gather the funds to evacuate people from Ukraine. Well, actually, we're a Ukrainian team. I think you know this, but yeah, and by now we're happy to equate more than 3,000 Ukrainian kids with their families from regions that are at active warfare or occupied. And I'm so happy you took part in that, and offered your help us with that. And program committee, tell us more about the program committee, please, Anna.
I would like to. They helped us a lot, but we're running out of time, and I don't want to take time from speakers' speeches because they have to do it faster and squeezing them. So let's introduce to this stage our first moderator and first speaker. They're really great. I would like to add to the stage Matteo Collina. Hi, Matteo.
Hello.
How are you doing?
Hi, folks. How are you doing today?
And we also have Marianne, who will moderate first block, first 3 speeches that we have. Marianne is from NodeSource also, so I really think that it will be great block, and it will be really useful for others.
So, thank you very much. Sorry. Yeah. Hi. It's an honor for us. Thank you for joining us. Thank you for contributing to community. I know you guys are really busy. You have lots of events. You have lots of that tech stuff, and you are really actually people who move this technology and take us to the future. But thank you very much for joining us and contributing. Appreciate that. Thank you.
No, thank you for the invitation, and it's a pleasure to be connected here with Matteo, well-known personality in the Node.js ecosystem. And thank you for having the opportunity to be again with you, with all the team of Geekle. It's an honor to be part of the Node.js Summit.
Thank you. I'm wishing you a good luck, and stage is yours, guys. Fire it up with your tech and your magic.
Enjoy.
Enjoy.
Hey.
Yeah.
See you.
Thank you. So, hi, Matteo. How is everything?
Hi, Marianne. Oh, really good. Really good. It's been a little bit of a while that we chat. So yeah, no, I think it's been busy, I would say, with the new startup and company and stuff. It's a lot of open source stuff being released. So yeah, no, it's great.
Where are you now in this moment?
Oh, I am in Italy, so I just dropped my kid at school. So yeah.
Wow. So Matteo is a well-known personality and also a responsible father and a co-founder and CTO at Platformatic. So we really admire your work and the open source ecosystem. And as I said, it's an honor to have you here. So the title of your presentation is I Will Never Use an ORM. So what's an ORM?
Oh, you will just have to watch the talk, maybe?
Yeah, I know that, but I'm going to read. So an object relation mapping tool, ORM, is a library to map a SQL table. And most of the cases, ORMs ask for the user to structure their code to have a model object that includes both access and business logic. That was the description you shared with us. So once upon a time, you did several projects using ORM as common belief that they will simplify the development and maintenance of projects, and you were wrong. So you are going to share with us a funny story, as always, I hope. So
hopefully, I don't know. You to decide. Okay, you will tell me if it's funny after the talk.
So well, as always, I'm really excited to have the opportunity to be as a spectator for one of your great presentations. So I wish you good luck with this introduction. And I will be here behind the scene if you need something. So stay secure, Matteo.
Of course. Amazing, Marianne. So yeah, see you on the other side, maybe? Yay. Okay. Oh, hi, everybody. Seems I have the stage. So yay, I even have my slides. I'm very happy. Okay, so hi folks. As I said, there's Matteo here. You can follow me on Twitter at Matteo Collina. If you want other places to follow me, you could get them from my from my newsletter called nodeland.dev. You could grab it there. I am one of those people that with a lot of downloads on npm. So you're probably using my software one way or another. Probably another, but it's deep down in yet that dependency chain of yours in the black hole of node modules. There is some of my software in there, and yay! So I'm part of the Node.js technical steering committee, maintaining HTTP streams, working a lot of diagnostics, also triaging Node.js vulnerabilities. So yeah, not a super simple job. I've been worked as a consultant for 8 years and a half or something, and now I'm founded my own startup. It's called Performatic, and I am the CTO. So okay, let's get started. Object relational mapping. What is object relational mapping, and why it matters? And you're probably used some of these days, or if not, be aware of what I'm going to say, and of course, do your testing, do your verification. Okay, so ORM tools have promised a really, really nice word. Okay, they say, oh, you need to structure the code in this way, and everything will be well, tidy, and organized, and everything will work perfectly. And I really like spaghetti, and I'm Italian, and I like spaghetti. And and this is why there is a spaghetti slide. Of course, this talk a little bit of fun. It's the first talk of the day, so it's got to be a little bit of fun, right? And a model in an ORM, okay, is used in ORM systems. A model is used to represent a row in a database, okay, and then that is and then you use those models to relate to other models. So you build this kind of relations between various models that become very quickly all interconnected, right? And okay, how many of you have used Java? I hope a lot, because I'm going to do a quick joke. And if you have not used Java, I'm so sorry. So what happens to your application when it uses an ORM? It hibernates. And if you have not used Java, you will not get it. I'm sorry. Then it's why ORMs are an anti-pattern. The fundamental problem of models, okay, is that they have three key responsibilities. First, they manage the persistency of your data. Then they hold the data in memory, yeah, right? And finally, you typically use them to implement some business logic. These make them very fat, okay? And you can see it on the right. You define your class. You can, here is your nice class, and it's you have your class, and then you put you have your save, your delete method, but you also have maybe a like method to add a like to something anyway. This is why is this a problem, and why it does not really scale well with the complexity of modern applications. It all comes from the model view controller architecture. You are probably being very much familiar with the model view controller architecture. This has been popularized at the end of the early 20s or something, like 2008, 2009, 2010. And frameworks that implement these are typically Ruby on Rails or Django or those sorts of things, and Laravel maybe. And of course, you implement these in Node too. And typically, these applications are built with Express, with some tool to do models. The problem with this architecture is that when you're building your application, you have literally 3 boxes into which we structure our code. So you have your you have controllers, okay, which can be your routes more or less, and then you have the views, the HTML you're going to render, And then you have your models, which talk to the database. Now, what is the problem? First of all, well, do we do views anymore these days? Most of the application are really like SPAs, or we build APIs for storing the data, and then those are rendered on React, or Vue or Svelte or whatever. So anyway, maybe not. Okay, there's not much on the view side. On the controller side, yeah, we can have some interaction on the controller, yes. But reality is that we have more or less two boxes in which we structure our features, our work. And the problem is when we do that, it's the complexity. You don't have more categories in which you put more complexity, right? So as your application becomes more complex, you soon to have 2,000 models. And this is actually a real-world system. Real-world production system has 2,000 models in their application. Just loading that up to start, okay, took more or less 1 minute. Like if you do Node and the app, Node server, it will take 1 minute to start. What? Makes no sense. So what have ORMs done for us in the last few months, in the last few years? Well, since the 90s, really, when they've been invented, they have delivered a nice bowl of spaghetti code just for you. Okay, I love my carbonara, by the way. So you can have my carbonara. I will have my carbonara, but I'm eating spaghetti. I'm not coding spaghetti. Okay. So back in a few years back in 2016, I built this framework called Fastify, which helps a little bit with that. So instead of structuring our code in using models, I recommend it structured along the lines of the features of your applications. Okay, let's say that you have or domains if you follow domain-driven design. So let's consider this way: you have a cart, and all the routes and models to manage the cart are as part of a module that then manage the cart, right? And in this way, this can scale along the way. Okay, like you can have it scale because you are not limited by like 2 categories or something, but you are structuring your code for success. And Fastify makes it very simple because it has a very strong and nice plugin architecture. And this also serves as the basis for maybe going into the more microservice world, possibly, where you have multiple systems interacting with each other, multiple processes and stuff. And note that there is always some intercommunication between those things, and Fastify offers the ways to do this kind of communication between the various modules, and then you could migrate those communications to microservice later on. So, okay, we have talked a little bit about ORMs and what the problem with ORMs. I'm not done. I have more. So let's talk about Pareto. This is a mathematician at the beginning, which was alive at the beginning of the last century. Okay, so what does Pareto tell us? Well, the infamous 80-20 rule. So the 80-20 rule tells us that 80% of the outcome on the outcome result for only 20% of the causes. Like, so a lot of the work, it's only 20% they create a lot of work to do, right? Which means in practice in software development that in reality 80% of the features only create 20% of the effort, and vice versa. 20% of the features we actually allocate for 80%. Like, it's a lot. 20% of work, 20% of the features are actually all the work that you're going to do. Typically, you could, in fact, everybody has experienced this in their career. Or you can get some stuff very quickly. Bang, bang, bang. We do ship and release every week about some new stuff. Then you hit a hard wall, and things are not good anymore. Okay, you start the velocity of the project greatly slow down. So yeah, what's the problem? What to do with it? Okay, it is the frame of mind that you need to use to talk about this kind of problems, and especially ORMs, by the way. But that's a different. We are abstracting things a little bit. So you have we have the start of the project, which it takes all the features, all the simple features takes only 20% of the effort, and then you have the complex features that takes 80% of the effort. So what would you optimize for? Would you optimize for the start of the project, or would you optimize for all the complex features? And reality is that we are lazy as developers. Mostly we are very lazy, and because we are lazy developers, we typically want to avoid all the repetitive and boring tasks. And this is part of the problem, because a lot of those tasks are very simple to do. Okay, and we typically choose technologies that remove those boring tasks and repetitive tasks. But on the other end, a lot of them really cripple our ability to do our flexibility and what to do when building when creating something new. So they limit our options, they limit what we can do. So this is the problem with ORMs. Okay, the ORMs typically have they typically waste a lot of time. Okay, and the reality is that they remove a little bit of the easy part. They help in writing the models. Okay, they help in creating the routes a little bit at the beginning. But then after some time, you have to unravel all of it and write some custom query, because it's not going to work. Okay, you will hit the wall that the ORMs cannot deal with the type of query that you need to do, and then you need to write something custom and completely bypass the ORM. Everybody will tell you that they've done that multiple times in their career. Okay, so what do? Well, reality is that there is even something better than ORMs, and in fact, the best line of code is the one that I don't have to type. And by the way, that's a great keyboard. So if you want, this is the new model of that, and you can. It's a kicker. I love it, and I'm not sponsored by them. So anyway, so what I want is, I went so far. So what I want is a backend. Okay, I am a backend engineer, and I don't want to spend any time preparing a backend for my project. Why? Well, because it's a lot of things are boring, right? So I don't want to spend time doing boring stuff. I want to spend time doing complex problems. So I want a backend, but I don't want to code it. I want to run everything locally, but I don't want to build it myself. I want it to be both REST and GraphQL without having to choose. I want to have some basic authorization support built in, but maybe just a little bit. Okay. I want something that I can deploy and manage, and I want to just use Postgres and MySQL and MariaDB. They're great. Okay. So in practice, I want to have the cake and eat the cake. And, as they say, and the British says, have the cake and eat it too. So anyway, so the tool that I'm going to demonstrate today is a tool that can remove all repetitive tasks and go out of the way for the most complex features. So this is what this tool does, and it's platformatic. So you can check it out at platformatic.dev. And that's kind of it. And I'm going to do a little bit. Oh, no, wait a second. Sorry. Yay. And, it didn't. Wait a second. I need to. Sorry about this, folks. I made a mistake on the sharing. So, and not the Chrome tab. Yeah. Sorry about this. Can you put it on back again? Hey, thank you very much. Okay, so let's pick our latest Node version, NVM use 18. Okay, so always use the latest Node version. And let's start. We can do create platformatic. This will start our tool. You can install it with npm I create platformatic -g. Or just npm create platformatic would actually do the trick. So we are going to use platformatic-db. This is the tool that enable. This does not seem. We have a message that doesn't seem to work very well. And then Yeah, we were migrations, plugins, yes. TypeScript, no. And I'm not going to run npm install just because I don't have. Oh yeah, it did. It's running it. So here we go. And yeah, let's do it again. And yeah, migrations, plugin, TypeScript, nope, and no. Okay, so we're not going to use Performatic Cloud today. Okay, but there is a cloud that you can use to test this. So what has this created for us? So we have created a table called in the meanwhile npmi. Let's install this, and in the meanwhile, so we have created a table with as a movie table, and then we have a configuration file, and it's great, right? And then it has a few configurations. It supports environment variables replacements. So you can go in env and you can see that this is being repopulated. We support SQLite, MySQL, Postgres, and so on and so forth. And then we can start it with npl before we need to run the migration. So npl db migration apply, and then npm a. So it's and then we can do plt db migration, plt db start to start our server, and then we can go here. Sorry about this. Here we go, and we can go to localhost 3042, and as you can see, this has been started, and we can open graphical. Ooh, it's loading. Seems some package.js is getting some trouble. Interesting fun. In the moment it's starting this, we can go to in the meanwhile you can go to Swagger, and you can see that it has a full Swagger support. We have movies. We can get the movies. We can store the movies, delete the movies, and so on and so forth. This has been creating automatically for us. And then we have graphical support. Okay, and in fact, as you can see here, we have all our queries, and you have the movies, and so on and so forth. So let's start creating a movie here and save movies. So what we can do is save movie, and it's input, and say we want the title of the movie, Harry Potter. And then we want the ID and the title. And running this. Here you go. You can have it. Here it is. We have saved this. And now, for example, we could even get our movies from using REST and OpenAPI. So this is a simple call request. As you can see, this is very simple, and this will return our response body. So as you can see, it has our Harry Potter film here defined. It has a lot of other features. I don't have much. I don't have much time. I think I need to start wrapping up this talk. Okay, and let me check, because I think I have like 5 more minutes or something. I need to start wrapping up this talk, but there is a lot that this has out of the box. One more thing I can demo very quickly. For example, if you use GraphQL, what we can do is, for example, create a subscription for a movie. So, for example, a movie saved, and we want the ID and the title. So if we run this subscription, this is just the WebSocket based, and you see this is now loading on the right. We can go here and store another movie. For example, we can store Star Wars. And running Star Wars, you will get automatically the event over WebSockets. So all of this you can use it to implement any system you want and get live updates. It's pretty great, right? I love live updates. It also supports relations and so on and so forth. So it works really well. So let's go back to our presentation, okay? And so the Platformatic DB allows us to actually skip a step and just apply our migration, like apply our migrations, define the schema, and then just expose the routes. But how do we implement and write custom code, right? I have just show you, and how can we do that? Well, let's go back into our code, and there is this file called plugin.js that we showed you, and you can see here that we have, for example, we can add. This is just a Fastify app, so you can just add a Geekle route, and here it is, hello Geekle. And we have added our route here, and I'm saving this. And now I can just curl localhost 3042 Geekle. And as you can see, it has automatically reloaded our server, and it has exposed our route. But how about our movies? Well, what we could do, for example, is we could add a movies route. Let's say a titles route. And what we can do is const titles, await, app, platformatic, entities, because this is what they are. And then you can see that there is a movie entity here. Oh, and then we can have a find method, and I would just want them all. And then I can just want, for example, the fields. I want the title only. And then I can just here just return our titles. And yeah, titles map, title. Okay, so we have added this, and as you can see now, I can just go in titles, and I have an array of all my titles just by calling them and so on. And here we could even, if we don't want to do that, if we could just do something very easy, and just say that const titles, and then await. Oh, we need const db and SQL, app platformatic, and then here we can do db.query and db and SQL, and select title from movies. By the way, I love Copilot. I am a fan. Okay, and then here, oh, sorry, here it is. It's a little bit behind my camera. So, and here we need to await this, and then here return titles. And now I can it just works the same. Okay, so it's exactly the same as before. I can just do my queries and so on. So these would be rows, and then and I just use near the internal mapper, or I can just use row SQL. So yay, it's amazing, right? So going back to the talk, you could just add custom route very quickly, and you don't even have to expose or do any work. You just go jump in, write your plugin, and move away. So how is this possible? Well, Platformatic can be easily extended, as we see. Platformatic DB is based on the concept of Fastify plugins. So you can just use all of Fastify, really, to be honest. It's just packaged nicely in a nice developer-friendly way. And it's the interesting part here is it's composed by individual modules. So you can see that it has a SQL mapper module that is then used to GraphQL and OpenAPI. And then you can actually use your routes and resolvers. But these are individual modules, individual Fastify plugins. So you could even just use them inside your app. So you can just get the individual modules and build your Fastify app on top of them. So you're in charge, and you could decide if you want to have, what kind of experience you want to have. You want a framework that enables maximum flexibility. You want to avoid all the repetitive tasks. Your choice. So this is a question for you. Did I code a NoRM? Like, can you tell me? I don't know. Anyway, you could check us out. We are Platformatic, and we have a Discord community. So test out what we've done and let us know. Thank you. Hello. Hi, Marianne.
Hi, Matteo. So welcome back. Thank you for this awesome presentation, as always. Those were really interesting parts of your presentation. And are you ready to share with me like the secret recipe of the carbonara sauce?
The secret recipe of the carbonara sauce. Okay, so first of all, you need to procure yourself some guanciale. What is guanciale? It's this part of the cow. Okay, it's something that's created that way. Now you get guanciale. Okay, once you have guanciale, you need to get some very fresh eggs. Okay, and you need some cheese. Okay, specific cheese. Not all cheese are going to do. Okay, then you mix those things. You cook your pasta, and then you put. So you need to fry a little bit in a pan the guanciale, and then you put your pasta in the pan. Then you turn it and so on and so forth. And after you have cooked it, you prepare the eggs with some. You use. I don't know the term for that. You prepare I'm not really a cook, to be honest, but I won't teach you how to do it. This might go into the history of the worst explanation of carbonara in the world. I've cooked it a few times anyway, so it's good. People like my carbonara. And anyway, yeah, that's Sorry.
We love your carbonara and your code because you are an amazing developer and Italian. So that's why you say you really enjoy carbonara, and Italians really know about pasta. So thank you for sharing carbonara recipe. Matteo, so we're ready for the question to our audience. So all your questions you can share with us on the chat. Don't forget to do it, and we'll be answering at least as much as we can. So Matteo, are you ready for the easy part before carbonara? So, okay, so I have my Keychron, and right now with my Keychron, we have like our first.
Completely not. We are not sponsored by Keychron. Okay, we are just fans.
And also not bad Copilot, but I love Copilot too. So here our first question. So what about the development speed between an ORM build and execute queries manually? What are your thoughts?
The fundamental problem is it's going to slow you down when doing repetitive things like an insert, an update, a select. You need to learn how to do that. Okay. Now, where it's going to speed you up is going to speed you up when you do a custom query that's a join of 4 different tables to get the data that you want. And doing that with an ORM is going to wreck the performance of your application, and it might even be impossible. And in order to do that, typically those kind of things happens at the end of the project, and then you're screwed because you don't know how to do that. It will take 2 weeks or more to unravel that problem, while you have traded a little bit of discomfort for boring work at the beginning. So it's a bargain that I will make all the time.
Okay, so we are ready for the second question. So when not using an ORM and using raw SQL, so should a model still be responsible for communicating with the data layer, or should there be a provider like abstraction?
So what you will need to do really is to, I typically tend to think more about areas of responsibilities and features. Stay away from the concept of models. Models are wrong, okay? They don't work well in the sense of fat model where you create a new person, then you have a save function. Okay, don't do that. What you do, you have you can create some utility that you call a save person function, and then you pass in up JavaScript object, that's something that you can serialize back and forth JSON very easily. And you do that, and then you can read up and down from the database using that generic function, similar to what I've done with Platformatic. I have this find and save, and I have this kind of little utility that you can use to interact with the database. This is actually very handy. You don't want to attach business logics to those objects, though. So you want to keep them a plain object, just data, something that can go into JSON, get back to JSON very easily, no problem. And this will save you so much trouble later on.
Okay. We have plenty of questions here because they are really extracting all your expertise. So
look, I very happy to, hopefully not my expert as a cook, but my expert as a developer. Okay, sorry, I am not.
Okay. So I will jump fast on them because we have a lot. So does PlatformDB have support for JS and PS migration? How do you handle complex data migrations with?
The width, I'm lost. I don't. It seems that sentence is broken a little bit.
Yeah, I think it's JavaScript and TypeScript migration.
Yes,
so
it's supported. Okay, internally, Platformatic just uses PostGrator. It's a library. So because we just use PostGrator, you can write JavaScript migrations with that, and you'll need probably do a little bit of transpilation to do TypeScript migrations too. So it's doable. However, I typically recommend to run the migrations to write your migrations in SQL, because if you don't do that, there is always the problem of you enter a world where it gets a little bit tricky. Typically, if you want to write them in JavaScript or TypeScript, because you need to call an external service and stuff like that, and that's tricky business. Okay, I doing that more or less in an automatic. I don't know. I'm not. It's tough stuff. So be careful and be very careful what you do. Yeah.
That's wise. So jump to the other. So what about the security part of Platformatic? And does it cover some parts of it? Maybe put some headers automatically.
Yeah. Sorry. Yes, we have we have built-in support for authorization, and it does support the JWT tokens. So you could just issue your JWT tokens in any single way, any way you want, to be honest, and then give us the token and instruct it to recognize that token issued in that way by that provider, and then it can operate in a role-based way. We are doing something new, additional stuff here that we're going to release in a few weeks. So stay tuned.
Okay, this question is in two parts, so it's a very big one. So the first part is, if we use the Platformatic, does it mean we build business logic around DB instead of putting domain logic at the center of the architecture circle?
No.
Okay. Business logic.
No, it means that you can. Sorry, let me finish on the previous one. It means that you can actually that it can speed you up all the way while you start building your application at the beginning. Okay, so you waste absolutely zero time in developing and maintaining those CRUD functionality. And if your system is not doing some CRUD, all the system I work with have a lot of CRUD, like create, read, update, behavior in it. So all of them have. So yes, and then what you do, you can take all your business logic and implement custom routes on top of it. Other systems, similar system don't allow that. You cannot extend the graphical schema easily. You cannot put that there in an easy way. It also supports Apollo Federation. So if you are doing, if you are into that, you could even federate this with other systems.
Okay, so I think this person will be trying to figure out with the actual response you did in the first part. So he said, like, probably we could describe some models and connections between them using a library and then generate migrations with basic truth for different database using a script. So that's the second part of it.
I don't understand the second part.
So he said, basically, so between them, he will use a library and then generate migrations with basic truth for different database using a script. So see, when you describe some models.
I don't know. Like I at this point, I don't know. I don't know. I don't know about the question. Okay, I have. It's not about what I talked about. So it's in my point of view, I don't do the models. I'm telling you, don't describe models. Okay, don't do that. Okay, this is where it's going to hunt you big time later on. Don't use that to describe a library. What you want to do is want to define your schema. From your schema, generate some migration. If you want to do in 2 steps, you can do 2 steps. If you want to write your migrations, it's also okay. It doesn't matter too much. And then you don't need to generate. Like if you go generate CRUD, if you just go through I'm just running a generator, generating a CRUD, then you need to maintain that. Okay, you need to maintain that CRUD logic. And this is code that you didn't write and you have to maintain, which is pretty bad from it's not a good bargain from my point of view. So hopefully this answered, but I truly didn't understand completely the question.
If we don't understand the question, we invite this person to reach out in social media, and perhaps we can do more in this question. So jump to the other one. So may have missed it, but what DB does your tool support out of box?
It supports SQLite, MySQL, MariaDB, and PostgreSQL.
Okay, jump to the other. So we have a couple minutes more because we are trying to get all of the expertise of Matteo. So you mentioned that you will have plenty models, 2,000 for a big project. Why you don't minimize the models by creating views in the DB where they join the tables you need? But Matteo,
the problem it doesn't. This will not solve the problem. You create model, like if you create a view where you do the join and then you create another, it's another model, right? The problem here comes from the complexity of having 2,000 models or anything in the single code base. When you have 2 developers, when you have 2 teams, okay, or 3 teams that needs to touch this, you are a little bit. It's a really big problem when you start putting them together, because you have 2. If nobody understands how all the pieces fit, okay, it's very complex. Nobody understands everything, and because nobody understands it, how can you deal with it? Okay, and nobody gets the full picture. So you need to start dividing it into multiple microservices, into multiple independent pieces, or even use the fancy term, the modular architecture now. And you can take that modular architecture, create a module separate, which then is a responsibility zone for one team, and it share nothing with the other module that is another team, and therefore your software development can scale.
Okay, I will show this in the other question. So what about transaction management in platform?
It's probably what about transaction manager in Platformatic, and it's supported. Like there are transactions you could, if you want, in your custom code, you can create a transaction and do the things, all the things that you need.
Okay, the last one we didn't. So Platformatic can replace every ORM available out there.
Replaced? Probably not. I don't think that like technologies never replace one another, to be honest. Like you keep building stuff and mixing them and meshing them. We are not set to remove anybody from the market or anything. So you could. This is a tool that you can use to reduce your maintenance work and make sure that your application, you can develop things faster, more safely, with less code to write, and do less with more. So, and if this helps you, use it. If you don't, keep using your ORM. And but I told you what will happen, so you go to get a nice bowl of spaghetti. So hopefully.
And because we have the recipe through Matteo. So thank you, Matteo. You're the best, and thank you,
Marianne. It's been amazing here, and I know this was very early morning for you. So thank you for emceeing this lot. You are amazing too.
No, thank you, Matteo. And the best energy for your projects, we will behind our handle on Twitter, admiring the magic you do. Thank you again, and the best for you.
Thank you. Bye, Marianne. Bye.
So, okay, we're ready for our next speaker. Thank you for being here with us. For some of you, like me, it's very early in the morning, and for others, we are in different times and trying to handle it of these different times and weathers and places. So let's welcome Luciano. Hi, Luciano. How are you?
Hi, hello everyone. I'm good. How are you, Marianne?
Good. How's the weather? And where are you based?
So I'm based in Dublin. Today is a little bit grayish, but I mean, it's not too bad. It's not raining, it's not snowing, it's not too cold, so I can't complain.
Okay, I can't complain either. I mean, right now I'm here is like almost 5 a.m., like for 4 minutes, and I'm in Florida. Iguanas was falling from the tree, so we're falling from the tree. So it was sad because of the weather, but I don't have snow, so I'm still in the tropical side of the world. So thank you, Luciano, for being here with us. And okay, so we're ready, breaking the ice a little bit, and prepare our audience for your amazing content. So Luciano is senior architect at Theorem, and he is going to talk about building an invite-only microsite with Next.js and Airtable. So I'm really happy to see you. Before we move on, so remember to share with us all your questions on the chat. Don't forget to do it. And all of your questions will be answered at least as much as we can. So please share them directly while Luciano masterful keynote is being developed. And I will be behind the scenes enjoying the content and willing to support you in whenever you need. So Luciano, the stage is yours.
Thank you. Hello everyone, and welcome to this talk. So before getting started, I want to share with you the slides. They are already available online. You can either scan this QR code or you can go to the link that you see there. The reason why I like to share the slides early is because we are going to be seeing a lot of code examples, so it's just convenient for you to be able to get the slides and review all the code and the examples later on. Now, let's see what we are going to build today in this talk. I'm going to give you literally a 15 seconds demo. So we're basically going to be building a web application that takes the data from something like a spreadsheet. In this case, I'm using Airtable, and you can see that basically on the left-hand side, we have Airtable. Our data, it's a bunch of records. You can imagine that every record is an invite. Somebody is invited to an event that we are organizing, and they get a unique invite code. Now you can see that we are copy-pasting this invite code in the URL, and we can see the invite for different people that are invited. So we are going to be building something similar, and we are going to be adding some interactivity, and we are going to learn how to do all these different things safely. For instance, we are not going to allow people that don't have an invite code to be able to visualize our website. So effectively, we are building an invite-only website for an event that can be, in this case, a pizza party, can be a wedding, can be any other private event you might want to organize. So because this is probably something you're going to be doing as a side project, or at least this was my case, I was building something on my own. I just wanted to have a fancy way to invite people, but at the same time, it was not something that I was doing for work. So these were the requirements that I put onto myself. I wanted to iterate quickly. I wanted the solution to be simple to host, maintain, and update. I also wanted a very lightweight backend. And also I wanted to be able to collaborate with people that wanted to help me to organize the event, but they were not necessarily technical people. So I wanted to provide them a UI that would allow them to manage the data in the easiest possible way without having to be software engineers to be able to deal with that. And ultimately, but not the least important, I wanted this whole solution to be as cheap as possible and even free if that's an option. Okay, so let me introduce myself before we continue. My name is Luciano. I am a Microsoft MVP, certified AWS solution architect, and recently I became an AWS serverless hero. I work as a senior architect for a company called Fortheorem, and I'm based in Dublin, Ireland. You might know me because I am one of the authors of this book called Node.js Design Patterns. If you haven't checked out this book already, it goes very deep into what are the best practices and the most well-used design patterns in Node.js. So if it's something that interests you, check it out and give me some feedback. Feel free to connect with me. I'm quite active online, especially on Twitter and LinkedIn, but you can find me in a bunch of other channels. So don't hesitate to reach out and connect. I said that I work for this company called Fortheorem. So if you never heard about Fortheorem, we are a company that is effectively helping other companies to go to the cloud. We are partners with AWS, so heavily specialized in AWS, specifically on serverless. So if you're interested in working with us or joining our team, let us know. We'd be very happy to talk with you. Okay, what's the agenda for this talk? So first of all, we want to choose a tech stack. Then we want to understand what is the data flow to enable this kind of private-only solution for this particular kind of website. Then we're going to see how we can use Airtable effectively as a backend, as a database for a web application. And then we're going to discuss briefly how can you build APIs with Next.js and Vercel. And we are going to also spend a little bit of time looking into how to build custom React hooks specifically to implement the authentication flow. And finally, we're going to see how we can actually even receive data from the user and allow the user to input data into our system. And we are going to be using that idea to collect participation responses from our users. And finally, we're going to spend a little bit of time looking into some security considerations because after all, we are trying to build a private website. So what do we have to be concerned with? What do we need to make sure that happens so that we don't leak any data and making our website not private anymore? So what is the tech stack? I already gave you a few hints during the introduction. So we're going to be using Next.js, Airtable, GitHub, and Vercel. And the reason why I came up with this set of technology is mostly because I'm quite familiar with React. I am familiar with Node.js. And all these tools, they have a very generous free tier. So this kind of combination of tools was something that allowed me to satisfy the requirements that I impose on myself. So let's start with looking into the more technical topic. How do we go and make a Next.js website private? So by default, when you build a website with Next.js, you just publish it on a CDN and it's something that is totally available to everyone that knows the URL. So this is not really going to change, but we are going to build the website in such a way that if you go there and if you know the URL and you try to visualize the website, you are not going to see any sensitive information. You're just going to see a page saying, sorry, you are not authorized to see what's behind this website. So the idea is that we will have a bunch of guests. Every guest will have an invite code, and every guest should be able to see, using their own invite code, they should be able to see a customized invite that is available only for them. People that don't have an invite code, they should not be able to access any sensitive information. So how is this data flow going to look like? So we are going to, effectively, we're building a React single page application. This is what Next.js gives us by default. So basically what happens is that the browser is going to load this particular page and initialize the single page application. Now, when the single page application gets initialized, there is another phase called code validation. Basically, the application, before showing any sensitive information, is going to check the URL and try to see, is there a code that has been passed to this particular page? If there is a code, the application needs to try to validate that code, and it does that by calling a backend API built on Vercel. That API is going to fetch some data from Airtable, where we keep all our invite code and our invite data. And if all of that comes back correctly, then basically we can show the user their own invite code. But if there is an error, meaning that the code was missing or it was not valid, then we can show something like access denied. So this is more or less the data flow that we want to build. Let's see how can we do that. So first step is let's organize the data in Airtable. The idea is that every invite code is basically a UUID, and then there is an entire record that contains additional information about the guest, for instance, the name, their favorite color, and any other kind of information that is relevant for your particular website. Now, just to understand a little bit more how Airtable organizes the data, let's try to understand what is the terminology that Airtable uses and how we can compare that with a more traditional relational database. So we have a base, and a base is effectively like a project. In this case, we called it Secret Pizza Party, but that can be whatever name. And effectively, in a project, you can put a bunch of data organized in different way. Then if you want to start a new project, you're going to be creating a new base. Then we have the concept of tables. In our case, we only have one table called invites, but this is very similar to a table in a relational database. Then we have fields, and again, this is the same idea as a relational database. And then we have a bunch of records that will, for every record, we can populate all the fields that we defined for this particular table. Now let's start our Next.js project. I actually really like Next.js as a framework, also because it has a bunch of scripts that allow you to bootstrap a service very, very quickly. Here I'm using npx, I'm using this create next app. Notice that I'm not using version 13 because when I built this particular example, version 13 was still in beta and I didn't update yet, but it shouldn't be too difficult to upgrade to version 13 based on what you will see in this particular example. Also notice that I'm going to be using TypeScript, so we're going to be seeing strictly typed code. So the first thing that we want to do, especially because we're using TypeScript, is let's define an interface for our data. And we have an invite code, and this invite, we have an invite object, and in this invite, we can have a code, a name, favorite color, and a bunch of other attributes that are relevant for our particular website. And now we can install Airtable SDK. So Airtable gives us an SDK, which is just a simplified way to interact with the Airtable APIs. And what you need to do in order to use this SDK is to get your base ID, so the ID of your project, but also your API key, which is something that you can find in your account. At this point, you can export them as environment variables, and we will be using them to initialize the SDK and connect to our database. Now, one cool thing that I really like about Airtable is that if you open the documentation for your particular project, this documentation is actually already using the data structure that you define for your project. And it also gives you a bunch of code examples. Now, I don't know if you can appreciate this. Basically, they are giving us examples where they are already using the base invites. They are using the record shape for our particular records, and we can use this as a starting point. Now, this is not the most amazing code, in my opinion, because they are using var, they're using callbacks, so we can modernize that a little bit, but nonetheless, it's a very good starting point. Okay, so let's start to write some code. And the first piece of code that I want to write is a utility file where we basically use that as a way to call Airtable and do things that we want to do with the data. So in this piece of code, what you can see is that we are effectively importing Airtable, we are importing our invite type, and then we are checking that we have set up the environment variables correctly. And at that point, we are initializing the Airtable client and telling the Airtable client to use our particular base. Now, at this point, we can start to create our first utility function, which is basically if we have an invite code, can we fetch from the database, from Airtable, all the details about that particular record? So literally, can we read all the fields of that particular record if there is one? So how do we do that? We create a function, we call it getInvite. It receives an invite code as argument. It returns a promise because this is going to be an asynchronous operation. And then basically we use the SDK with this particular select function to be able to read some data and filter it. Now, there is this particular filter formula expression, which is something we're going to be talking about later on in the security part. But the main idea is that this is basically getting the one invite with the invite code that we provided to the function, if there is one. Then by default, this API gives us a paginated set of results. So we only read the first page. We're interested in checking if there is at least one record. And if there is no record, we say error invite not found. Otherwise, we initialize an object using our invite type and resolve the promise with that particular object, which contains all the data extrapolated from our record. Now, the next step, now that we have this utility function, is how do we build an API in Next.js that uses this utility function to expose this functionality to our frontend? And in Next.js, this is just a very simple primer. How do you build an API? This is just an hello world. Basically, the idea is that inside the folder pages API, you can create files. And depending on the name of the file, that's going to be the name, the endpoint for your API. So for instance, here we created a file called hello.ts, which basically means that we are exposing an API in the endpoint /API/hello. Then the other things that you need to know is that you can import Next API request and Next API response from Next. And then in your file, you basically need to export a default function, which is just the function handler for that particular endpoint, which receives a request and a response. And this looks very similar to the Node.js HTTP standard module to create web servers. So here we can use the response object, for instance, to set the status code and to set the body. So let's use this idea to create our first API. We want to, again, get an invite code from the URL and then use our utility function to get the data from the database. And if everything goes well, we return the data through the API. Otherwise, we return an error. So what do we need to do? We import our invite response, which is just another data model that defines the kind of response that we can return from this API. Effectively, it's just a wrapper for our invite type. And then we import our getInvite utility function. At this point, we define our handler, request and response. We do some checking to see, is this a GET request? Because if it's not, we're going to return an error. Do we have the code in the URL? Because if we don't have that, we're going to be returning an error. Also, we need to do some lightweight normalization because in Next.js, a query string parameter can be repeated multiple times. And Next.js is going to give you an array of values for that particular name in the query string parameter. So here what we want to do, if it is an array, we need to normalize and take only the first instance of that particular value for the name code. At this point, we can try to get an invite using our helper function. If everything goes well, we can return 200 and we can JSON stringify the data. If there is an error, we can also report the error to the user, and the error can either be that the invite was not found. In that case, we can return a 401, or can be any other error, and in that case, we are going to assume that it's an internal server error, so we return a 500. And that's all that we need to do to implement our first API in Next.js. So at this point, we can test it, and basically we can use curl, we can do a GET request, run it in localhost, and basically pass a specific code. And if everything goes well, we should see something like this. Nice. Now we can start to work on our frontend. So the next thing that we want to do is start to build a little bit of frontend, and when the application starts, we need to be able to call this API with the invite code we have right now to be able to see, is this an invite code? Can I render the page, or should I just return an error? What's the strategy here? So again, when the SPA loads, we grab the invite code from the URL, we call the invite API. If it's valid, we can render the invite. Otherwise, we render an error. But this is a little bit of a complicated data fetching lifecycle. So how do we manage it? There are multiple strategies that you can use if you are used to build applications in React. So one idea could be we do all of that inline in the top level component, for instance, the app component. We can use the context API to store all this data, or we can create a specialized React hook to do all of that. Another option could be to use something like Redux, but I prefer the option of creating a custom React hook. So how do we do that? Like if it's something that you've never done, it's actually interesting to see how to do that. So a custom hook is basically just a JavaScript function, and the name generally starts with the word use. A custom hook can also call other hooks. For instance, we're going to be using useState and useEffect. You could be calling also other hooks like useRef or useCallback or anything else that makes sense for you. Now, the interesting thing is that a custom hook doesn't have to be any specific signature. So we will see that we'll come up with 2 different versions of this hook in this talk, and it's totally up to you to decide what the signature looks like. And inside this function, all the common rules of hooks apply. So in React, when you use hooks, there are some rules that you need to follow. For instance, you can only call hooks at the top level of your component, and you need to call them in a deterministic way. So they cannot be inside loops or inside conditions or inside nested function, meaning that every time your render function is being invoked, the hooks needs to be initialized in the same order as they were initially initialized the first time the component rendered. Okay, so let's start to build our custom hook. So we can basically use other hooks. We want to use useState and useEffect. We're also going to import our invite response type. And here we have a function that I omitted for brevity, but the idea of this function is just if you give it a code, it's going to use the fetch API to call our API and return the result from it. Now, this is the code for our hook. We are going to call it useInvite, and it doesn't require any parameter, and it's going to return an invite response or null and a string or null. Let's see what that looks like. So the idea is that we initialize some state, one for the invite response and one for possible errors. Initially, these 2 values are going to be null, but over time we can load the data and they will become either an invite response or either we will have an error. Now at this point we have a use effect, which basically means the first time you use a component that uses this useInvite hook, we want to load some data, and we can do that through useEffect. Now, what this is going to do is basically going to try to read from the current URL if there is a code as query string parameter. If there is no code, we are going to assume there is an error, no code was provided, so we are going to display an error page. Otherwise, we are going to call that helper function fetchInvite to try to load the invite. And if everything goes well, we are going to set the invite response. If there is an error, we are going to set the error. And at the end, we just return an array with invite response and the error itself. Now, how do we use this hook? This is an example. Basically, what we can do in a generic component is just use invite, and then use invite is going to return an array with 2 items, which is either the invite response or an error. So we can destructure this array and assign these 2 variables. And at this point, we just have to do a bunch of conditions. If there was an error, we need to render an error message. If there is no invite response, it probably means that we are still loading the data, so the hook is still fetching the data, so we can display some loading spinner or some other loading message. And finally, if that's not the case, we probably have the data, so we can render a page that uses this particular data. Okay, now we have everything we need. So we have seen how to build a helper function that talks to Airtable, how to build an API, and how to build a frontend, and how to build a custom hook that allows us to interact with this data lifecycle. Now, the next step is that we also want to improve our application to be able to collect user data. So an invite page can show a form to the user where we can basically ask to the user, are you coming to this party or not? And based on the answer of the user, we want to receive that information and store it in our database. So how do we do all of that? We need to do a few changes. The first change is to be able to, we need to add the coming field in our Airtable database. So we have an extra field, and the value for that particular field will be populated when the user submits the form from the frontend. Then we also want to create a new backend utility, which we are going to be using to update this coming field, will be true or false. And we want to add a new endpoint to our APIs. And finally, we want to update our React hook, the custom React hook we just created, the useInvite, to also be able to expose not just the functionality to read the data, but also the functionality to update the coming field for the current user. How do we do that? So updating Airtable is very easy. You just go to the UI, you add a new field, And notice that in this particular case, I'm not using a simple Boolean field because there is a case where the user didn't submit any preference yet. So I'm using a generic option field where the options are either empty or yes or no. Now let's build our RSVP utility. This is going to be very similar to the one we just built initially. So we are going to be using the Airtable API. The first thing that we need to do is get the invite record. So basically the signature is we have an invite code and a value for RSVP, which is either true or false. That particular user is coming, yes or no. So what we need to do is we fetch the current record, and then we can call the update for that particular record. And we are going to be setting RSVP to yes or no, based if on the Boolean value RSVP for this particular function. If all goes well, we resolve, otherwise we reject with an error. Now at this point, we want to expose this particular utility through an API using Next.js APIs. And this is very similar again to the API we built before. What we want to do in this case is, this is another handler, is going to be /API/RSVP. What we do again, some lightweight validation. In this case, we want the data to be, the method to be put. And again, there needs to be a code in the query string parameter. If those things are missing, we return errors. Then we also want to read data from the request body. So we need to make sure the data is read correctly. It's processed in JSON. If all of that fails, then we will need to return an error again. And at this point, we can basically use our helper function to update the RSVP for that particular code with the current value. If everything goes well, we return a 200. Otherwise, we return an error. At this point, we have everything we need. We have our helper function, we have our API. We just need to update the front-end hook to be able to expose some functionality that allows us to not just read the invite data, but also to update that particular invite record. So at this point, we can change the signature of our hook a little bit, and we want to create an helper function called update RSVP request. Now, our useinvite can return, rather than just returning an array with 2 items, can return a more structured object called hook result. This is the name of the type. And this hook results is basically a collection of 4 different things, the invite response and the error as before. But now we are going to introduce 2 new pieces of state. Actually, 1 new piece of state, which is updating, which is basically a Boolean value that tells us if we are currently sending a request to the backend to update the data. And then we also have a function called update RSVP, which our frontend can use to call the backend and trigger an update for the current record. So everything there is the same as before. Here we have the new use state. Then we have a use effect that is going to load the data, and all of that is going to be the same as before. And finally, we have this new functionality called update RSVP. So this is just a function. It doesn't get invoked by default. It's something that the user, when inside our React components, we can call whenever we want to trigger an update of the user participation. So this is something we are going to be calling, for instance, when the user is going to submit the participation form. So here what we do, if the data was properly loaded, we can call set updating to true, which basically sets the flag updating to true. So we can show a spinner, for instance, in the front end. And then at this point, we can call our helper function to start the update of the RSVP for this particular invite code. At the end of that, if everything was okay, we can update the invite response, and we can set the updating flag to false, so we can remove the spinner. And at the end of it, we just return all the 4 different items that we want to expose with this particular hook. Now, how do we use all of this? This is a very simple example. Imagine that this is just the home component. We can initialize this hook with useinvite, and you can see that we destructured the return object into invite response, error, updating, and update RSVP. So the first 3 are states. The last one is the update RSVP function that we can call whenever the form is submitted. Now, again, we need to manage the cases where if there is an error, we display the error. If there is an invite response yet, we are probably still loading the application, so we need to display a loading screen. And now we have some piece of reactivity in React. So we have an event handler that we can use whenever the user clicks on a radio button to select if they are participating, yes or no. And whenever that happens, we want to basically get the current value, are they coming, yes or no, and then use that value to call the update or SVP function from the hook. And this is our form, and you can notice that basically we have this onChange handler, and they will be used to call the or SVP change with the value of true or false, depending on which button they click. Okay, now I'm going to show you how all of that looks like. And you can see on the right side that the user loaded the application. And when they click on yes, we immediately see in Airtable that yes is updated. If they click no, we can see again that Airtable is updated in real time. So what is happening behind the scene is that we are receiving the data in our API. The API is calling Airtable, and all the data gets updated this way. And every time the data is updated, Airtable shows the updates in real time. So this is basically satisfying our requirements because we built an application that can be used by the user. They are accessing the application, but at the same time, we have a nice front end that we can use even if we are not software engineers. So we can give it to somebody else that can help us to organize the event, and they will always see the data updated in real time. Now, I want to close this talk by spending another 5 minutes on some interesting security considerations. The main point here is we built all these websites to be private, but is it really private? Are there things that we need to be careful about because they might leak some sensitive information that we wanted to keep private? So the first thing is that if you are a really clever user of the web, you are going to be versed in using the developer tools. And if you open this particular website and you start to look at the source code, the JavaScript source code of the single page application, you might see things that are actually quite interesting. For instance, you can see the title of this website. You can see some information like the date and the place where this particular event takes place. And all of that, even when you don't have an invite code. You can see here that we have invalid code, but if you open the source code, we are still able to read a lot of information that we shouldn't be supposed to read. Now, why is this happening? And how do we fix this? The reason why this is happening is because React is basically a front-end framework. So all the information that you put in your own components is going to be eventually compiled into JavaScript and be available in the browser. So one way to fix this particular problem is to try not to put any sensitive information in the client-side code. So every single piece of sensitive information should only live in the backend, and we should be able to load that data after the application is started only if the user has a valid invite code. So one idea to fix this, again, don't hard code anything sensitive in JSX, and then we can use our invite API to also return not just the invite information, but a list of all the sensitive pieces of data that we might want to interpolate in the UI. If we do that, this data is not going to be available in the final JavaScript bundle. So we are keeping our bundle as lean as possible, and it's not going to leak any sensitive information. Now, there is another interesting one. I mentioned that we will look at the Airtable filter formula again. Now, the reason why we want to look at this one is because actually this one could be a little bit vulnerable. And you might have noticed here that I have used a function called escape, and we'll see what that means. But if I didn't use that function called escape, what would happen? We would have some code that looks like this. And this code doesn't seem harmful at first, but if you have done something related to SQL injections in the past, you probably are going to see a pattern here. And the pattern is that we have a formula where we are interpolating user input, and therefore the user is in control of changing this formula depending on which value they provide for that particular invite code value. And let's see a few examples here to try to understand what the user can actually do to try to exploit this particular expression here. And even if they don't have an invite code, be able to go through the entire flow and pretend that they are an actual user with an actual valid invite code and still see some data that they were not supposed to see in the first place. So let's see this example. This is actually a regular use case. We provide a query string parameter with a given code. The code is a UUID. What happens if we use our formula? We are going to be seeing something like this. We are saying invite needs to be equal to this particular UUID. Nothing harmful here. This is the good case. Users are responsibly using the application. But what happens if we find a malicious user that wants to try to hack our application? They could realize that there is some user input there in the code query string parameter, and they can try to start to play with it to see if they can break and inject some code into our query. So how can they do that? For instance, let's assume that they send us something like this. And by the way, if you try to decode it, this is just URL encoded. If you try to decode it, it looks like this. So it's interesting just to see that they are sending us a quote and then some kind of expression after the quote. Now, if we interpolate this particular string in a very naive way without doing any escape, the resulting expression is going to look like this. So an invite is equal to an empty string, which needs to be measured in 0 and an empty string. It looks a little bit convoluted, but the bottom line of it is that this expression is always evaluated to true for every single record. So basically, when you run this in your query string parameter, you can see that even if the user doesn't have a valid invite code, they can get into the application and see an arbitrary invite. And probably this is going to be whatever is the first invite in the Airtable when Airtable runs the query. So this is definitely not good, so we need to fix it. And one way to fix this is by creating this escape function that sanitizes the user input before interpolating it into our expression. Now, I created here a simple escape function based on what I could guess were all the dangerous cases, but I would encourage you to don't trust my own implementation. If you're building something like this, try to do some more testing and even ask Airtable to provide a default escape function, because unfortunately, as of today, Airtable doesn't provide an escape function. So it would be nice for them to do that, because definitely they are in a better position to create a more comprehensive and more battle-tested escape function. I try to reach out to them, but unfortunately they haven't been very responsive. So I really encourage you to do something similar. Reach out to them and try to make clear that this is a dangerous use case, and Airtable could do better to try to help the community to build more secure application when they are using Airtable as a backend. Now, let's try to wrap things up. What we learned today is that we could build a website using Airtable and make it private with all the things we described. But is this the best approach? Like, should we be using Airtable or should we be using something else, leaving aside security considerations? So I think Airtable is actually quite nice and works quite well for most use cases. But there is an important limitation. The API is rate limited to 5 requests per second. And we are actually using 2 requests every time somebody is updating their RSVP status. So if you have a lot of people invited to your party, this might not scale. In my case, it was sufficient. I didn't see any particular problem. So if you're looking for some alternatives, there are actually tons of them. You can use Google Spreadsheet, you can use DynamoDB, you can use Firebase, you can use any headless CMS, you can use Supabase or Strapi. Literally, you can use whatever you want as an alternative. And here I'm just trying to suggest kind of serverless ideas, but you could also go with more traditional SQL databases if you want to. What are the takeaways for this talk? This particular solution is one solution to this problem. Certainly, there are many other ways you could solve something similar to this. What I try to optimize for is to be able to build something really, really quick, to keep it simple and easy to build, and as cheap as possible to host. We also use this particular example if you want to consider it as an opportunity to learn more about Next.js, how to build APIs and frontend with Next.js. We learn how to build custom React hooks, and we learn how to use Airtable and its own SDK. And we also took the opportunity to explore some security considerations that maybe could be useful to you in other projects. So my final remark is, don't try to use this solution blindly. Every time you're going to be having slightly different requirements. So always remember to evaluate your own requirements and try to pick the best solution for your requirements and also for your own knowledge, because you probably know some kind of stack already, and it's probably going to be easier if you use the stack that you know best. Finally, I want to mention that everything I discussed today is also available as an article. There are lots more details in that article. I didn't have the time to cover everything. So if you really want to deep dive in this particular use case, go and check out the article. And with that being said, that's everything I have. I hope you enjoyed this talk. I really look forward to receive your feedback and your question. But for now, thank you very much. Bye.
Thank you, Luciano. We're back, and thank you so much for watching us. First of all, thank you for your time and your amazing content, sharing your knowledge, time, and invested in this event. So, Luciano, how is everything?
All good, yeah. Thank you again for the lovely introduction and for giving me the opportunity to present at this conference.
No, thank you so much for being here. So, I will show the questions and then you can answer them. So I'm going to start. Okay, are you ready, Luciano?
Yeah, let's do it.
Okay, so can this application be displayed to the edge?
That's a good one. I will say yes, in principle. I haven't tried it, but I think you can use Next.js and deploy to the edge. What we are doing there, because we are only using an API that lives on the Next.js on the Vercel platform, it should be relatively doable, easy enough from the front end to be able to reach on that API, and everything should work as expected. Then the definition of edge is always a little bit vague, because at the end of the day, Vercel also gives you a CDN, so you might already consider that the edge. So probably we need to consider exactly where the Lambda code or the function as a service code runs, which again, maybe could be defined better, and we can try to answer that question.
Okay, Luciano, thank you so much for answering that question. So I invite all the audience to leave the questions behind the scenes on the chat. Right now, we don't have more questions for you, but give it just a couple of minutes to see if they could share more questions or clarifications. Actually, as you said, but the invitation is to reach you on social media and get deeper on the subject. We know is short time to get deeper in a full book of knowledge you share with Node.js partners. So thank you so much, Luciano. Right now, they confirm we can go with the other speaker, but it was really an honor to have you here. So we're ready for our last presentation, at least for this blog. So I'd like to introduce our next speaker. Thank you, Luciano, again for sharing with us. Have a wonderful day, night. See you soon. So, okay, we're ready for our next speaker. He's not here, but in the meantime, I'd like you to invite you to leave the questions on the chat. So thank you for being here with us in Geekle community. And okay, they confirm me that is here. So just give us a couple of minutes. We are waiting while we are waiting. So leave the questions. So thank you, Luciano and Matteo, for sharing knowledge with us, for being humble and really share with us really good content, right? So what are your thoughts about this event? Please share with us like your feelings and your questions. I will show the questions and your questions on air. I'm ready. So okay, so we have Mahesh right here. So and now we're ready for our last presentation, at least for this blog. So I welcome you to Mahesh Paliwal. He is senior software engineer backend at Mama Air. I hope I don't misspell some names just in case he could correct me on social media. So We are from various parts of the world. I really don't know where Mahesh is, so I'm going to share with you. He's going to share with us like a tale of threads of Node.js. The introduction of this talk is there needs to be more clarified around Node.js and threads. These sessions will clarify how threads work in Node.js, which components operations use multi-threading, and which operations are completely single-thread. The talk will focus on various topics related to threads in Node.js, and the talk will cover hidden aspects of the lib IUB library and event loop. So I'm pretty excited with this title. So I welcome our last but not least speaker. It is an honor to have such level speakers here with us. Please, Mahesh, the stage is yours.
Hi guys, welcome to Global Summit of Node.js'23. My name is Mahesh Paliwal and I have over 2.5 years of experience in building scalable Node.js applications. So in today's session, I will try and clarify most of the confusion around Node.js and threads. I will be speaking about why Node.js is being called single-threaded and what are the concepts and components of Node.js and when Node.js is single-threaded versus when it is multi-threaded. So basically, whenever you are trying to build scalable Node.js application or you're trying to build a highly performing Node.js system, you must know how threads work in Node.js. Otherwise, you could end up writing a piece of a code which will eventually block the main thread or event loop that could result into application failure or poor performing application. So hopefully this session will be helpful in building scalable and high performing Node.js application. So prior moving to the Node.js core concepts and components, let's focus on thread and process a bit. So basically, process is your execution container. Whenever you run a program, it runs inside a process, whereas thread is basically part of a process. It's a segment of a process. So there can be multiple threads in a single process, and you can use these threads to execute multiple tasks. So your main programs runs inside a process, but you can divide that program into sub-programs and you can assign threads to execute those sub-programs. As you can see in the diagram one, there is a process and there is one thread inside it. That's why it is called single-threaded. Whereas if you spawn multiple threads, that particular system is called multi-threaded. So in case of Node.js, your V8 engine, the event loop, and the entire JavaScript code runs inside a thread. That is why it is called single-threaded. So moving on, as you can see, we have higher layer architecture of Node.js. So on the upper layer, we have Node.js standard library. Then we have C++ binding, which are basically C++ programs to hold V8, libviewd, and other libraries together. So whenever you sort of run the command node index.js, you are basically telling Node to run a JavaScript file. So basically, that JavaScript file runs into the V8 engine, which is basically used in compiling and running the JavaScript files. Then there is libviewd library, which is basically a platform abstraction library used in async IO operation. So if you have to deal with the timers or you have to run the callback, you have to execute the C++ callbacks, and you have to wait for the polling and all those sort of things, Node.js uses libviewd for that. And even event loop of Node.js is part of libviewd library. So basically, Node.js has an instance of libviewd's event loop, and basically Node.js gets its event loop from libviewd library. So moving on to the Node.js JavaScript file execution flow, we have V8 engine over here, which is basically responsible for compiling and running JavaScript files in Node.js. So there are various type of JavaScript engines. V8 is one of them. So purpose of these JavaScript engines is to compile and run the JavaScript files. So as we know, JavaScript used to be a browser-centric language, and different kind of browser has different JavaScript runtime engines. So in this case, V8 is part of Chrome, whereas Microsoft Edge uses Chakra and Safari uses JavaScript code to run its JavaScript files. So the purpose is same. You supply the JavaScript file and they sort of execute those JavaScript file in your browser. Whereas in this case, the Node.js has V8. So Node.js, whenever Node.js gets the JavaScript file, it sends that file to the V8 to retrieve the C++ objects or callbacks, and then it executes them further. So let's try and understand the flow of JavaScript execution in Node.js by this diagram. So we basically supply the JavaScript file to C++ program of Node.js. Whenever you call that node index.js or node some file.js, it basically means that you are running Node and you're supplying that particular file for Node to run. So basically, it goes to that C++ program. So that C++ program has an instance to V8. V8 is basically single-threaded, right? Everything it runs inside a single thread, since JavaScript is single-threaded. So this C++ program converts that JavaScript file into a string. Basically, V8 expects a string to be supplied, and then it sort of V8 converts that string into C++ objects for Node.js to use them further, or basically whichever operation it has to perform. So the string goes into the V8. V8 gives you the C++ object to work with, and Node.js works with those C++ objects to further execute. Moving on, here is the example of running a JavaScript file using V8. So basically, Node.js has a similar program to run JavaScript files using V8. So whenever you supply the command node index.js or node file.js, you are basically telling Node.js to run that particular JavaScript file. So Node basically looks up for that particular file and tries to read that file. So as you can see in the example, we are calling fs read file using file name. So once we have read the file, we are basically creating a string containing the JavaScript source code. So as we have seen in the previous diagram, that there is a C++ program which reads that particular file and that converts into a string. So basically, that string gets applied to the V8, and V8 sort of compiles that particular source code. So once we have compiled this script, we call this script.run function to run that particular script. And as a result, we get the C++ objects or callbacks to work with. Moving on to the libUI, which is an integral part of Node.js. So basically, even event loop is part of libUI only. So for Node.js, libUI kind of manages the threads. It talks to the OS, or it performs some CPO tasks for Node.js. So libUI is there in Node.js to kind of manage the resources for Node.js. So basically, whether it is a thread pull operation, whether it is a polling operation, everything is handled by libUI. So as you can see in the upper layer, there are network I/O, then there are file I/O. These are the set of APIs libUI kind of provides to work with. You invoke these APIs and you sort of perform these operations. So in the bottom, as you can see, there is thread pull, there is IOCP, there is event port, there is KQ, there is ePoll. So thread pull is basically bunch of threads clubbed together. So whenever basically libUI has to perform certain tasks, it can use a thread inside that thread pool. Default thread pool size in case of libUI is 4. So by default, libUI only spawns 4 threads, and that can be managed by environment variables give thread pool size if you want to spawn more. So this is where thread pool limitations comes in. So sometimes you think that this sort of operation won't use thread pool, but that ends up using thread pool, and it will consume those resources and can be a blocker in certain cases, right? So there is a limited thread pool. So you should be aware which operations are using thread pool and which operations goes for polling. So IOCP is basically used for polling in Windows. Then there is KQ, which is basically used in macOS for polling. Then there is ePoll, which is used for polling in Linux-based system. So in a gist, basically, this is how libui manages the resources for Node.js. It has a thread pool which is limited. You have to be extra careful while using this thread pool. Then it talks to the various kind of OS polling systems mechanisms, right? IOCP, KQ, ePoll, to sort of perform other operations which does not use thread pool. So basically, the file IO, then DNS lookup, and there are a few other operations which uses thread pool. So moving on, here is the separation of tasks between thread pool and the kernel. So as we know that libui uses thread pool to perform certain operation, and it uses pooling to perform other operations. So in case of libui, we have limited number of threads to work with. By default, it is only 4. So it is very essential to know which task uses thread pool and which not, right? So all the operations related to file system, FS star operation uses the thread pool. Whereas in case of DNS, only DNS.lookup uses the thread pool. Other networking operations happens inside the polling. So there is a common misconception that libui uses thread pool to perform networking, which is not the case over here, because for only for the DNS.lookup, libui uses the thread pool, and for other operation, libui uses the polling, which is done via kernel, and DNS.resolve and other DNS method uses the polling. So in case of a TCP UDP socket server, the polling happens for Unix domain socket and server. libui uses the polling, and which is basically using the kernel. So moving on to the event loop, which is basically heart of a Node.js program. So event loop is a long running loop, which basically has a set of defined phases. It goes through those phases and it executes the callback over there. If there are certain operation it has to perform, and in that phase, it performs those operation in that particular phase. As you can see in the diagram, these are the phases event loop has. It has this timer phase, which basically executes the all of the timers which has been expired. Then there is pending callbacks phase. So basically, it will execute all of the pending callbacks over there. Then it has this polling phase. So basically, any polling operation which has been completed, it will execute all of those polling operation over here in that phase. Then there is a check phase, which is basically a set immediate phase. So it will basically execute all of the set immediate calls over here. Then there is exit operation. If there are no more callbacks to execute, then the loop will exit. And there is a common misconception about Node.js that it has only one event queue, but that is not true. Each phase has its own event queue, which is basically a set of callbacks to execute, and all of that gets executed in FIFO order. In general, whenever the event loop enters a given phase, it will perform a set of operation related to that particular phase. It will execute all the callbacks which are residing inside the callback queue or the event queue, right? It will keep on executing those callbacks until the queue has been exhausted or the maximum number of callbacks has been executed, right? So when the queue has been exhausted or the callback limit is reached, the event loop will move to the next phase. So basically, each phase has its own event queue. There are set of callbacks which the event loop has to execute. Once it is done with the performing all those callbacks, it will move to the next phase. So moving on to the timers phase, which is the first phase of event loop. So whenever event loop starts, it will execute the timers phase first. Uh, so as we know that event loop in each phase will run set of callbacks which are there in the event queue, right? So whatever callbacks are present in that particular phase event queue, it will execute those particular callbacks. So in case of timers, the event loop will execute the callback set up by set timeout or set interval. So if in your code you are using set timeout or set interval, then that those callbacks will be executed in timer space. So basically, there is one more thing, which is basically whenever those timers are expired, they will be executed in timer space. What do I mean by that? Suppose you have put a timer, you have put set timeout of 200 ms, and now event loop is running. T equal to 0, there will be no expired timer, right? So at t equal to 0, the timer phase will move on to the next phase because there are no callbacks to execute and there are no expired callback, right? So it will go on to the polling, check, and all those phases, and it will come back again timers phase. And if the time is more than 200 ms or equal to 200 ms, that means that particular callback is expired. At that point of time, event loop will execute that particular callback. So what does this means is basically so there could be chances if your other phases takes more time. Suppose you have put timer of 200 ms and t equal to 0. Since the timer was not expired, it was not executed at that particular time. Now event loop went through all of these phases, right? And it took around 300 ms to complete all of these phases. And now the timers phase came back in, right? Once all of the phases has been passed, the event loop goes back to the timers phase. So once event loop comes back to the timers phase, it will execute that expired callback. But interesting thing is that it was supposed to run after 200 ms, but it took 300 ms to run that particular timeout or callback. So basically, there is no guarantee that event loop will run immediately after a certain period of time has expired, but there is guarantee that event loop will run that particular timeout once that particular time has been expired. So event loop might be doing other stuff in other phases, but once it is back to that particular phase where that particular callback belongs to, it will immediately execute that callback. So after timers phase, the next phase is pending callback phase. So event loop will execute all those callbacks inside this phase which were deferred to next loop iteration. So basically, this is mostly related to the system callbacks, and one example could be TCP error or system error, right? So basically, the system-related callbacks will be inside its queue, and the Node.js event loop will execute those callbacks in FIFO order. Since these are system-related callbacks, I won't be going into much detail of it. So moving on to the next phase, which is polling phase. This is one of the most critical phase in Node.js event loop. In this polling phase, event loop does two things. It waits for the IO events if there are any, and it executes the callback which are inside the event queue. So basically, if there are any file system and IO operations, or if there are any networking IO operations, if there are any polling callback, all of those will be executed in this polling phase. So you might have got the idea that how critical and important this particular phase is. Basically, we have to try and not block this phase. And so once the polling phase queue has been empty, or all of the callbacks inside polling phase queue has been executed, there are two possible scenarios post that. Event loop will check if there are any script scheduled by set immediate or not. So in first scenario, if there are any script scheduled by set immediate, then event loop will move to the check phase and it will execute those scripts immediately. If there are no script scheduled by the set immediate then in that case, the event loop will wait for the callbacks to be added into the event queue, and once those callbacks are added into the queue, it will execute those callbacks. So to understand the event loop and its phases better, we will be taking few code examples. So to start with, I have taken this small example to understand the timer's phase in detail. So as you can see in the code snippet, we are requiring the FS module. Then we have defined the sum async operation, which basically takes a callback as an input parameter. And then we are inside this sum async operation function, we are reading a file and we are supplying a path to it. And we are assuming that this will take around 95 ms to complete. So fs.read file will be done with the execution after 95 ms, and it will give us the callback. Then moving on, we have defined a timeout, which we are hoping to run after 100 ms. Then we have invoked some async operation function with a callback, and the callback itself will take around 10 ms to complete. So let's try and visualize this through the event loop understanding and phases understanding we have. So as we know that there is a timers phase, and there is pending callback phase, then there is polling phase, and there is check phase, right? So at the t equal to 0, event loop will start with the timers phase. And at the timers phase, there will be event queue, and there will be callbacks of all of the expired timers. But since at the t equal to 0, there are no timers which are getting expired, so that particular those that queue will be empty, and we'll be moving to the pending callbacks phase. And at the pending callbacks phase, as we know that it will execute those callbacks which were deferred for the next loop iteration, and mostly it kind of handles the system related callbacks or the TCP/RS, etc. Right? Mostly it is related to system callbacks. So since there are no such operations, it will move to the polling phase. So at the polling phase, at the start of polling phase, the event queue of polling phase will be empty. So the event loop will check if there are any scripts scheduled by set immediate or not. As we know that we haven't we haven't used any set immediate, so there will be no script scheduled by the set immediate. So the event loop will wait at the polling phase and will wait for the next timer to expire, and will then it will move to the timers phase. But since we know that fs.read file will return its callback in 95 ms, and it will push its callback inside the event queue of polling phase, and the event loop is waiting at the polling phase, so it will basically one at the t equal to 95 ms, it will execute that particular callback, since the queue has the fs.read file callback, right? So execution of that particular callback will take 10 ms. So at the polling phase, event loop waited around 95 ms plus 10 ms. So it waited around 105 ms at the polling phase, and now it will move to the timers phase, and it will execute the expired timer, which is basically the set timeout we have set around 100 ms. So, so basically, we were expecting our set timeout to get completed within 100 ms, but it took more than 100 ms, which is basically it took around 105 ms, because it was stuck doing some other operation. It was working on executing callbacks inside the polling phase. So shows that there is no guarantee that set timeout will execute immediately after timer has expired. There is guarantee that it will execute after some time once the timer has been expired. So as we have seen in this example, that it took around 105 ms to execute that particular function. So moving on to the next example, which is basically a difference between fs.read file sync and fs.read file. So in the left, we are trying to read two files synchronously, whereas in the right, we are trying to read two files in a synchronous manner. So in the first case, the time to read both of the files will be sum of time to read first file and time to read second file. Whereas in the second case, the time to read both files will be equivalent to the last callback received in the polling phase. If you look at the first example, we are calling both of these read calls in synchronous manner, which basically means we are telling event loop to read those files in synchronous manner and not go ahead, right? So basically, we are blocking event loop in polling phase in case of reading file in synchronous manner. Whereas in case of fs.read file, we basically the event loop can continue running other operations if there are any other operations, right? Once it goes to the polling phase, uh, if there are no callbacks in the event queues, it will try to run all the script scheduled by the set immediate, right? So basically, once those callbacks has been received, the event loop will execute those in polling phase. So in this way, it uses the view is threadful to the file, and once the callback has been received by the threadful, it sort of executes those callbacks. So moving on to the next example, where in the left we are trying to read four files asynchronously. We are calling four fs.read file operations concurrently. Then in the right we are trying to read six files concurrently. So as we know that Node.js uses libvirt to perform file system related operations, and libvirt itself uses thread pull for file system related operations. So in first example, in left case scenario, these four fs.read file operation will happen in the thread pool. And as we know that default thread pool size is four, so first libvirt will check if there are threads free to perform these operations or not. Since in the first case we haven't performed any operations at that particular time, so there are all of the four threads available to perform these tasks. So all of these fs.read file operations will use separate thread, and these will almost complete at the same time. Whereas in the second case, we have around six fs.read file operations, and we only have four threads to work with, right? So at the initially we are not running anything, and initially all of these four threads are free. Now we have six tasks to perform. So all of these six fs.read file will go to the thread pool, and since the thread pool only has the four threads available, it will assign those four threads to first four operation, and the other two operation will wait for all of those threads to get free. So once the four task has been finished in the second case, the four threads which were occupied by these four operations will get freed, and the other two tasks will be assigned separate threads by libvirt. Hence, in the second example, first four fs.read took less time than last two fs.read, because the last two fs.read did not get the free thread, and they had to wait for first four operations to complete, and then they were executed. So moving on to the today's last example, where we are making six networking calls concurrently. So I'm using Axios to make six networking call asynchronously. I'm calling axios.get to call an API, and I'm doing that six times. But if you look at the timeline in the right side, you will find that there is no tail, right? There is no tail, as we have seen in the last example, that the four tasks were finished first, then the other two tasks waited for the threads to get freed. Then the remaining tasks used the libvirt thread pool to perform the file read, and that's why we saw a tail over there. But why we haven't seen a tail in this case? Any guesses? So yeah, you might have guessed it right. So basically, for the networking operation, libvirt does not uses the thread pool. It uses the pooling. It uses either the epool if system is Linux based. If it is a Mac OS based system, it uses KQ. So that's why all of these operations finished at the same time, because it was they were using the pooling, and there were six threads available in the system, and all of these six operations happened concurrently. So that was all from my side. Thank you all for tuning in. I hope you guys enjoyed the learning, And hopefully now you will be able to distinguish between when Node.js is single-threaded versus when Node.js is multi-threaded. And hopefully you will be able to identify when libui uses the thread pool versus when libui uses the pooling for the certain operations. And once again, thank you for joining in.
Hi, can you, sorry, you are on mute.
Oh,
Not even,
sorry.
yeah,
Thank you, Mahesh, for your presentation. Are you ready to share with me everything about here in the Q&A session?
definitely, definitely. First of all, thank you for having me over here. Sorry, I couldn't come live because I felt that there was only 30 minutes to speak, and I thought that if I come live, then the session could stretch more. So the pre-recorded session, which basically puts focus on a particular span of time on a particular topic. So I felt that I could have explained better in pre-recorded than live, because live could have taken more than 1 hour. So yeah, I tried my best to explain everything, and yeah, ready to answer if there are any questions.
No, no problem at all, Mahesh. So thank you so much for the explanation. I think one of the greatest things of the Node.js community is we are in different parts of the world. We have different accents. We have the love for this for Node.js, for this technology. So thank you for sharing your knowledge with us. And yeah, we're ready. So give it up. So right now we have our Q&A sessions. I will share the first question with you. So what do you mean by deferred IO callbacks?
Yeah. So basically, I had the same question when I was going through the Node.js docs, and I have gone through the few videos of conferences as well, and I did not understand what these deferred IO callbacks are. So basically, what I understood is basically there are multiple phases in the event loop, and there is pending callback phase where you execute these deferred IO callbacks, and most of the time in practice you use the callbacks which are executed immediately. So basically most of the time you write the code which basically goes into the polling phase, and that gets executed immediately, right? Your callbacks are immediate, but in this case you are I mean, there are certain callbacks which are deferred for a next loop iteration or for a particular amount of time, right? So these are basically system related callbacks, or the callbacks Node.js uses internally, or could be some system errors, could be some TCP errors. So basically these are not in practice, but these are related, mostly related to the system related and TCP related, which are basically internal callbacks. And once that particular the loop is over, the Node.js by default has some deferred IO callbacks, which it sort of executes over there.
Okay, thank you so much. We will jump into the second question. So when process.next tick is executing a loop.
Got it. So basically, I haven't really talked about process.nextTick in my session because I felt that I could focus more on threading, how threading works in Node.js, how Node.js is single-threaded versus how Node.js is multi-threaded. But this is one really interesting question because I mean, when you see the Node.js event loop, there are multiple phases. There is timers phase, then there is pending callbacks, then there is polling phase, then there are check phase, right? So all of these phases have basically their internal loop. So the event loop has phases, and each phase has a small internal loop, right? And then there are two separate queues, which basically you don't see in the, I mean, the diagram I have shared with you. So there is one queue for process.nextTick operations. So whenever I mean, each phase gets over, you basically execute that particular small loop which each phase has, and you basically execute the promises inside that. You basically execute process.nextTick inside that. So to sum it up, basically you are running I mean, all of the phases, and each phase will execute your process.next operation or your promises operation. So yeah, one. I mean, I'm glad that someone asked it. That's nice.
Okay, so when do you think we should use Node.js at the scale?
Yeah. So basically, the question, I mean, what I'm getting from the question is basically this depends on the use case or the kind of application you are trying to build, kind of skill that you have, and kind of the specs of your use case. But in my opinion, you can go for the IO related, IO intensive application. You can go for the Node.js. But if you're building CPU intensive application, then you can think, I mean, Node.js might not be best solution for you, because suppose you are building a ML model and you're training a lot of amount of data over it, right? So Node.js may not be the best choice in that case. You can either go for the Python based solution or any solution which fits for the requirement, right? So for the IO intensive application where you just have to perform some IO related operation, I would recommend that you can always go for the Node.js.
Okay, and the last question: if we use function that use thread pool, there is an option to accept number of libv threads. How to choose number of threads right?
Yeah, interesting question indeed. Whenever you try to use the thread pool, you basically have number of thread pools to. I mean, there are limited number of limited number of threads inside the thread pool. By default, it is 4, and there is a environment variable UV thread pool size, and you basically can. I mean, play around with the threads by using that environment variable. But I would recommend that you perform some benchmarking prior playing with the thread pool size. So basically, go for the number of requests you will be facing and kind of application you have built. Benchmark it, perform some load testing, and after that, you can define whichever number goes best with you. So whichever number you are able to serve at the scale, you should go for that number.
Okay, thank you, Mahesh, for your time, your content presentation, and answer these questions of our audience. Have a wonderful day. And okay, so we're done. Thank you. So we're finished with our blog presentation. Thank you, folks, for being here. Thank you for your fantastic presentation. It was a great space full of amazing content of the Node.js community. Finally, we're grateful for your presentation and share the knowledge. Matteo, Luciano, Mahesh, thank you for being with us today. Thank you for being here with us today. Thank you for investing your time in sharing your knowledge with the community. I hope to see you soon at the future events and invite you to be part of this big community. Being here as moderator, it was a true honor. I enjoy being here to help you to moderate this space. I'm Marian Villa. I hope to see you soon. And thank you for this opportunity. See you next time. Take care.
All right, what a great time together, and thank you all the speakers for the presentations, and thank you everyone who decided to attend the summit. And we wanted to say thank you also to our sponsors from InfluxData. So basically what they do, they have an awesome database, and definitely give it a try if you're working with some kind of time series data. If you worked with legacy databases, it's just a nightmare when developers have to spend their time managing the infrastructure instead of shipping the code. So InfluxDB, they have a leading time series platform built from ground up to work and handle with the big massive volumes of timestamp data from sensors, applications, and infrastructure. And what's really cool about them is that empowers the developers to build real-time IoT analytics and applications, and you can do it with ease. It's easy to scale, and it gives developers the time to focus on those things that are actually matter, on those features that ship they need to deliver, and not managing the infrastructure. So definitely give it a try. You can check it out today for free, and you need to visit influxdata.com/cloud. Thank you, InfluxData, for joining us. Thank you, InfluxData, for providing your tool.
Whether you're developing apps for healthcare, IoT, finance, or the cloud, the only relevant data is time series data. Any data with a timestamp is time series data. Take stock prices, for example. When you place a trade, that happens at a specific price and at a random interval. The price of the trade is an event. If instead of these trades, we check the stock price every 10 minutes, we'd have metrics like this. InfluxDB handles both, giving you all the flexibility you need for your apps. Tracking events and metrics is the best way to get accurate information. If you only collect metrics in an interval and something happens in between, you'll miss it. If you only track events, you might think major swings are happening when they're really just anomalies. You can also generate metrics by averaging at an interval between events. Today, virtually every sensor, computer, system, and application generates timestamp data. InfluxDB enables you to easily collect and act on that data, improving your time to awesome. Learn how at www.influxdata.com.
Hey, Yuri, I think you're on mute, my good sir.
That is a rookie mistake, right? Not everyone still can read the lips, so I apologize for that. So hi, thank you very much for stepping in. So hi, my name is Yuri, and I will be a moderator for this next block of the conference, and super excited to be here. I just checked out the topics, and this first one is basically amazing. When I was reading first the description, so it's learning about building your very own IoT platform with Node.js, React, and InfluxDB, and going through the concepts such as building your device registry, virtual and real devices, dynamic dashboards in React with both real-time and historic data support, and using all this with InfluxDB. When I first read it, I thought like it's gonna be like a webinar for half of a day at least, right? And you will manage to squeeze it all in half of an hour. That's something. So before we begin, right? IoT is a big thing, and I'm pretty sure that almost everyone wants to get their hands dirty with IoT and try at least something. So my first IoT project was with garden, like watering system optimization. So what was for you the first project that you ever tried?
Yeah, absolutely. So I guess it's kind of sad. My original IoT journey started in industry. So it was all manufacturing, connecting machines, etc., like that. But then I got into home projects from there. And I'm similar to you. First home project was Plant Buddy, which was a similar machine for making sure that my plants were healthy. But my crowning jewel at the moment is my own CCTV system. So I use a Jetson Nano with a small little AI model. And that's got me excited. So my entire house will be kitted out by the end of the year, I think. So
that is definitely something, and maybe someday you can also talk about that project, maybe in the advanced track, talking about how one can do that, because it's a real thing. I've got quite a bunch of neighbors with the dummy plastic cameras around because they don't have any skill of like gathering the video streams or doing something with it except for like observing from the windows. But let's not waste too much time on the intros because you have quite a lot of things to cover within your session. So the stage is all yours. And yeah, good luck, and I'll see you soon with the Q&A session.
Thank you so much, Yuri. Let me quickly share my screen and rock and roll. There we go. So hopefully my screen should be shared for everyone. So thank you guys all for joining me today for building your own IoT platform with InfluxDB, Node.js, and React. So my name is Jay Clifford, and I'm a developer advocate for Influx Data. If you heard Paul before, he could definitely take my job. My job is evangelizing for Influx Data and getting involved with the developer community. But my true passion is IoT, making it accessible to all. And as we sort of just talked about, I have a passion for autonomous and vision-based projects. The cool thing to mention here is you'd be like, so why is an IoT guy doing a Node.js and React conference? Well, I never used to work with Node.js and React. This project that I'm going to discuss with you today was actually how I got involved with React and Node.js, how I started learning it from the ground up. So I'm hoping this knowledge share that I can give to you will be the start of your journey, helping to build those best practices in Node.js and React. So it's a really cool project devised between a company called Balena, from Balena and InfluxDB. So at a glance, this is just a little bit about Influx Data. So we was founded in 2013. Our focus was building a platform that enabled people to develop real-time applications for their time series data. The reason we developed this was because we wanted a platform that had an ecosystem for developers that made it just, it's like, as Paul said, start to finish was an easy process for ingesting time series data, working with time series data, and building your applications across it. We're open source first. So we actually have over 754,000 instances in the world that we know about, because you can run it offline. So we don't know about them all, but it's been a really cool adventure to see what this open source vibrant community is doing with time series data. So we're going to try and split this into 4 parts and try and condense it all into the 30 minutes. We're going to quickly go over what InfluxDB is. We're going to take a look at the IoT Center application. We're then going to look at a new feature in InfluxDB called Edge Data Replication, which might be interesting for scaling out your project. And then we're also going to talk about how InfluxDB can actually monitor your Node.js server and your React applications as well. And then we'll actually just talk about next steps and how you can get your hands on the source code and get started. So what exactly is InfluxDB? Well, you actually just saw a video on it before I started, but I'll quickly sort of give you my take on what time series data is and what a time series database is for. So in mathematics, a time series database is a series of data points indexed in time order. So if you're familiar with a relational database, imagine if we just made a timestamp column and made that the primary key. This is the primary differentiator that we want to use to represent our data. And you can represent your timestamp data in years, days, hours, even smaller than that, milliseconds. We're even down to the nanosecond with some of our users now. And this is the full representation of time series data. So when you think about time series data, you're really abstracting a layer above. You don't really care point for point. You care about trends, the direction in which your data is going in. Is it going up and down? What's the fluctuations? What's the anomalies? You care about your data as a series of points rather than just an individual row within your database. That's the best way to describe when you have time series data. And time series data falls into two main categories, the physical and the virtual world. So physical world, which we'll actually talk about today as well, which is analog and digital sensors. So a great example here is a temperature sensor. You could imagine over the course of the day, we want to know when that's going up and when that's going down. It's way more viable to understand a trend within a temperature sensor throughout having historical knowledge rather than just having the current timestamp. Virtual, think about application monitoring, think about infrastructure monitoring, network monitoring. A great example, as we heard, is stock data. So, if you were just given the stock price without a timestamp, you'd be like, how do I know if this particular company is doing really well or not? You could see that the stock price is particularly high, but if you don't have that historic data, it could be on an absolute nosedive and you could be investing money in a stock price that's bumming out. So this is the importance of having timestamp historical data. And so as you can see, we kind of fit into a lot of industries with time series data and was the reason why we built a time series database. And so InfluxDB as a platform was built from the ground up. So it's not a relational database. It's not a NoSQL database. So the reason we did this is because other platforms just wasn't cutting the ingest requirements, the query performance, and the level of compression that needed to be stored on disk. So InfluxDB is 2 times faster at ingesting based compared to the leading NoSQL database. It's also 5 times better at query performance for time series-based workloads, and is around about 7 times better at compacting data on disk, which is really cool. The awesome thing as well is it's all open source and under MIT license. So you can pull the source code from online, build upon it, expand it for your own use case as well. And of course, InfluxDB is built to scale. That's how we include our enterprise solution and our cloud offering. We've taken that open source product and built it to scale for you. And so, as we said, the emphasis for InfluxDB is providing a suite of tools that allow you to enable you to get started and basically get you involved extremely quickly within the process. So you can focus on developing and we handle the rest with your time series data. So we have a series of client libraries, which we'll discuss today. We'll talk about the Node.js and the JavaScript-based browser client library. We have a vibrant community. So I think we're up to 6,000 plus members on our community now that are always active. And we have other components part of InfluxDB that help you along the journey here, which you'll see in the demo later. So a powerful ecosystem and the ability to deploy templates to your InfluxDB instance, which automates your setup. And so if we wanted to take a snapshot of what that looks like or what a reference architecture looks like, this is the InfluxDB platform in its entirety. So you have your series of data sources, whether that might be mobile applications, whether that might be collecting data from cloud services, other databases, message queues, networks, IoT infrastructure. You can collect this data through a series of components, whether it be for a client library, a native ecosystem plugin, or Telegraph. Now, Telegraph is another cool project that we started, which is completely open source, which is a really known project in the industry for collecting time series metrics from lots of different areas. So really great ways of ingesting and working with your data, and InfluxDB sits there in the middle to collect, transform, downsample your time series data, and you can also perform alerts and trigger events based on that way as well. And you can use these build upon this within your own application to trigger insights, application workflows, and IoT actions, which we'll see in the demo today. So last thing on InfluxDB before we get on to the actual IoT application, InfluxDB is deployable on just about anything. We have a cloud offering, which is AWS, Azure, and Google Cloud. But the OSS version, which we're using today, is the open source version, will run on most areas, run on most builds of Linux. So SUSE, Red Hat, Ubuntu. We even have just standard basic Linux binaries. We can also run on Windows, Mac OS, Docker, and we also have Helms available as well. So there will be something for everyone in terms of installing and running InfluxDB. So the IoT application, so this really excited me when I first learned about this when I joined InfluxDB, because it's a language. So Node.js has been a language that I wanted to get involved with for a long time, but it's one of those languages like I needed to have a project to start off with where I was familiar in order to start getting my hands dirty and working with different components to understand how a Node.js application and infrastructure works and how we can build on top of that and build our web server. So what exactly is IoT Center? Well, it was a simple IoT application that integrated with InfluxDB. It allows you to query the database, manage InfluxDB automatically, allows you to write data into InfluxDB, which is our IoT sensor data. It's all built on Node.js and React, and is all open source and available on GitHub in order to teach you how to learn about these concepts and build your own IoT platform, which is super cool. And you'll see it's very much a tutorial. We have a really great inbuilt UI feature, which has all of the instructions and how each page is built. So you'll see that later as well, and how you can basically click through using embedded links to see the actual source code and see what's going on to make these pages work, which is super cool. So this is kind of the snapshot of the architecture underneath. And so you can see how the IoT Center architecture works. So you can have a series of real-world IoT devices connect to your IoT sensor. So we have these written in Arduino, Python, Java, .NET. So you can basically tie these clients into your servers. Maybe you've got a Raspberry Pi or something lying around, and you can basically write your data from these directly to IoT Center. We have our React web browser application, and then we have a series of services that are built into the Node.js server, such as device registration, a real-time dashboard, a virtual device if you don't have an IoT device, just to make some real-time data, which is all working off the InfluxDB JavaScript client library for Node.js. The cool thing here as well is we actually have inbuilt MQTT support as well. So you actually have two options. You can either write data directly into InfluxDB and have a near real-time query process for bringing your data back from InfluxDB into IoT Center, or you can actually use MQTT with Telegraph to both write the data to InfluxDB, but also via MQTT and WebSockets have a live stream of your data directly in IoT Center. And then we have a really nice dynamic way of going from real-time readings to drawing that back into real-time query, into previous historic time query data from InfluxDB. So that's a really, really nice feature that we added there. So as we said, there are 3 functions that we're going to achieve using this platform that will teach you how to build this. So first is device registration. The next is the ability to create a virtual device to emulate an IoT device. And then, of course, dashboarding. So this is a great way of showing how you can build out your own application like lots of our customers do on top of InfluxDB with your own dashboarding components. The cool thing here with the dashboarding is that it's based on a library that we've created in JavaScript called Giraffe. That doesn't mean you can't use any other library out there like Plotly or D3. These are all viable and can be swapped in and out. It's just, and this Giraffe library is a really easy way of interfacing with the data when it comes from InfluxDB. So under the hood, before we talk about actually how the Node.js client library works, first you need to kind of understand how the structure of the data works throughout the project and how we actually query and write data to InfluxDB. So InfluxDB exposes everything through an API. So you can access this as a raw REST request if you really wanted to. So you could just do a curl and simply write your data to InfluxDB. Now, all data written to InfluxDB is formatted in Line Protocol. So Line Protocol was actually devised by us as an extremely convenient and efficient method for transporting large volumes of time series data, but actually retaining the ability to understand the qualities of that data. So instead of doing something like JSON, we can transfer the metadata and also the values of that data within one line, which is essentially why we called it Line Protocol. So you can divide Line Protocol into 4 main areas: the measurement, the tag set, the field set, and the timestamp. Now, the measurement, which you can see there, is, if you're familiar with relational databases, is like your table. That's your encapsulator for all your data in that center. So when devising a schema, because InfluxDB schema is on write, but when considering your schema, essentially you should try and keep your measurements separate depending on how you're going to utilize them. So suppose you have a measurement containing all of your server metrics, that should be contained within one measurement, and then you have another measurement containing all of your IoT readings. And so that's the level of separation measurements should have from one another within your data set. Tag sets, you can imagine these like a secondary index from your primary index, which is your timestamp. This is how we separate our lines of data, our series of data. So imagine if we had 4 or 5 servers, setting a host tag and defining those servers allows us to differentiate between those servers. They're also, as I said, they're also indexed, so they're highly filterable and highly queryable for efficiency when working through high volumes of time series data. Field set is essentially where you store your actual values, and that can actually be anything from float to int to boolean to string values, all can be stored within the field set. So these are non-indexed, but gives you way more versatility for storing as many fields as you want with regards to your time series data. And then of course, it wouldn't be time series data without the timestamp. So we actually have the timestamp there in Unix format. Now the client libraries do provide ways of converting to Unix format. So don't worry about that. You won't have to be working out the Unix timestamp for all of your Line Protocol data. So abstracting a layer from that, that was basically through raw API calls. We've actually devised a series of client libraries. And of course, today we're going to talk about the Node.js client library specifically. So if I jump in one here, so we actually have 2 main packages for the Node.js, for Node.js. We actually have InfluxDB client. So this is for all your querying purposes, your writing data, and we also have the InfluxDB client browser as well. So if you just want something that's inbuilt for a web browser or Dino, then we actually have that inbuilt using InfluxDB client browser as well. For InfluxDB client API, for anything to do with management or health checks on your InfluxDB server, use the InfluxDB client APIs library, which you see there. So 2 different libraries depending on your use case and how in depth and how much control you want over your InfluxDB instance from your server. We're actually going to be using both today, which is super cool. So we'll show you that as part of the demo as well. So here is a quick overview of essentially what writing data looks like with regards to the InfluxDB's Node.js client library. So the API is asynchronous and non-blocking. So data is written in the background in chunks and flushed automatically, about 1,000 points or every minute. And it automatically retries to send the data, which is great for networking or server outages, or even just networking limits as well. So this is a great feature of writing copious amounts of time series data. And just to break out the code a little for you here, you can see this is us including our client library here. We're also including from an environment variable, the URL, the token, the org, and the bucket. So these are native variables to InfluxDB. The URL is, of course, the location of your InfluxDB instance. The token is your security, so that's the API token to interface with InfluxDB. Your org, so that's an organization within InfluxDB, and your bucket is equivalent to your database. We just refer to them as buckets within InfluxDB. And as you can see, we devise a write API, which essentially takes in those parameters, and then we can start writing to InfluxDB using that write API. And essentially what we have here is, if you have a look at the write point, this is us creating our line protocol. So point here, you can consider as the measurement, the tags that we want to add, and then, of course, the fields we want to create as well. So we provide a great programmatic way of creating line protocol, and then we can flush the data with a write API.close. So as well as writing the data, it wouldn't be a database without being able to query the data. And so if you have a look at here, the query API essentially returns a table. And that table object allows you to basically also contains table meta, so you can basically work out what's within the table, as well as navigating through the rows and columns within that table structure. And that table structure returned is really great for our giraffe library, as it ingests directly that table object, so it can visualize the data automatically using the giraffe library. The cool thing is, with that API method that we can call, we can either go lower level. So if you don't want to have it called back as this table object, we can have it return as annotated CSV, and you can process the data that way. Or you can even go higher level, and we can actually look at RX observables. So there's some great examples, which I'll show you later, where you can abstract that layer above and use observables to call back on your data, which is really cool. And then, of course, it looks quite static here if you look at this Flux query, which is our querying language. But we can also use Flux templates, which allows you to dynamically add variables into your Flux queries, so you can make dynamic queries to InfluxDB based on changes within your Node.js server. So last thing to mention really quickly is database administration. This is all done through the InfluxDB client APIs package. It allows you to control organizations, buckets, users, and is a great way of automating your InfluxDB setup process. The reason we're talking about this today is we actually use this to generate new security tokens and new measurements for users as part of the IoT application, which is really cool. So you actually don't even have to touch InfluxDB. This is all done via your Node.js server. So the last things I wanted to touch on before the demo, which is really cool features of InfluxDB, is application monitoring and edge data replication. So we have actually built two small little classes, which you can include in your own Node.js applications, which monitor your Node.js server. So we can monitor the CPU usage, the memory usage, and the resource usage. So you can actually include these directly in your own application. We'll show you the code at the end for being able to do this. What it will do is it will take those readings from your Node.js server, those metrics, convert it to line protocol, and also store that within InfluxDB. And it does that on 10-second intervals. So think about that. We're actually using InfluxDB as our primary database for our IoT data, but we're also using it as a secondary database for storing our application monitoring metrics. So 2 great use cases for one database. So we're very multimedia when it comes to our data here. And as you can see, this is just an example of how we convert response time into and store it within InfluxDB. So you can see here that we've generated our points and our tags. So you can see this is Express HTTP server. We actually have our URI, our method and status as indexable tags. And then we actually have a float field here containing our response time. So what we'll see this later within the demo, you can see the response time for these methods on getting certain assets within your Node.js infrastructure. And then as you can see, what we'll show you as well, we actually have dashboarding available so you can monitor your Node.js servers from directly within InfluxDB as well, which is super cool. So we had a look at this architecture earlier. The second part I wanted to show you was this modified architecture, which we'll be doing today. So InfluxDB 2 OSS has a new feature called Edge Data Replication. This feature allows you to automatically replicate data from one instance of InfluxDB to a remote instance of InfluxDB, whether that be InfluxDB Cloud or just another OSS version that you're running on a bigger server. This is a great way of monitoring multiple edge side InfluxDB instances. So you could imagine, say if you deployed this IoT center on, say, 10 of your customer sites, each with their own InfluxDB OSS instance, but you wanted to be able to monitor each of their servers, you could use this feature to replicate the data directly from these edge instances of InfluxDB, bring them all into one InfluxDB instance, and monitor your entire fleet of deployments from there, which is really cool. So we'll demo that as well. And just as a quick shameless promo part of this, as part of InfluxDB Cloud, we've actually introduced a new storage engine based on columnar technology, which gives us unlimited cardinality on our data, which is great for these use cases that have high cardinality, such as application monitoring. It also gives us the ability to query in SQL as well, not just in our Flux language. So it allows you to use other dashboarding applications such as Tableau, Apache Superset, and others like that, Power BI. So the demo, let me navigate across to the demo and we can have a look and get started. So when you first boot up the IoT Center application, this is all Dockerized. So you can just basically spin up a Docker Compose, or you can run it natively on your machine as well. It usually runs on localhost 5000. I've just pushed it onto one because I have other servers running locally here. What we'll do is you can see we actually have an IoT guide directly involved with the application. So if we jump here, it gives you a full tutorial and overview of how each part of the infrastructure and each component works within the application. Moving on from here, let's first have a look at device registration. So we actually have one device registered right now, which is a virtual device. I'm actually going to delete this so you can see how we register a device. What we provide, which is this really cool feature, is the instructions of how this exactly works against the InfluxDB API endpoint. And also how we call it based upon our InfluxDB client API as well. We also provide direct links into the GitHub source code. So it's a really intuitive way of learning how this application works. So if I jump down into a virtual device, let's create a virtual device. So here we go. So here's our virtual device. We've registered this device with InfluxDB. You can see here that we have our InfluxDB URL, that bucket where we're writing the data to, the Mosquito broker and where the data is coming from, and of course the topic. And these are the values we're expecting to have from that virtual device sensor as well. And then we have a series of dashboards. So let me jump in here. Hope this loads. So this is our first dashboard. This is our static dashboard. You can see we can navigate based on time. So you can see we've been running this quite a bit, but we can turn this data down, bring this to 15-minute resolution, 5-minute resolution, which is really cool. And this is all built based on that Grafana library that we discussed earlier. The next one to look at is real-time. This is really cool. That's using WebSockets and MQTT to get a real-time view of our data. We can see the truck moving across the map. So these are all components that you can use directly in your own system. And we have a live view of that data. The really nice dynamic part of this is if we go from 10 seconds live to say the past 5 minutes, using InfluxDB in that same mapping library, we can actually see exactly where that truck's been and how long it's been moving for as well as looking at historic data for 5 minutes or so. So it's a really cool blend of using a near real-time time series database as well as a real-time streaming process as well. We've also got included in the source code ways of using Kafka as well, so that's in there as well. And then dynamic, this is a really nice little feature for allowing you to build out your own dynamic dashboards. We give you instructions here on how to build your own dynamic dashboard for this application. So definitely check that out when you have a look at the source code. So moving on from here, if I show you this really quickly, we actually have InfluxDB running at the edge. This is InfluxDB. You can see that we have our data here in our buckets. This is our IoT sensor data with all the measurements that we have. We're actually replicating this data to the edge, to the cloud, which if I navigate across to here, you can actually see that we're monitoring our Node.js applications. You can see CPU usage, heap usage, and those response times that we were looking at earlier, which is a really cool visualization. And we can monitor between different node hosts as well. So that's based on those tag filters that we have, which is really great. So I'm just checking time, there was a lot to fit in the 30 minutes. So I'll navigate back across. So what next? How do you get started? Well, there's plenty of community resources. We'll send these out after so you can get a hold of the link. Come join me on Slack. That's where I hang out the most. Community forums, check out the docs, but please check out the InfluxDB IoT app tutorial course. This is where you'll find the repo. And we also have a webinar, which is a 2-hour long training course on building this IoT platform yourself. So definitely check that out. If you want to learn InfluxDB, about InfluxDB, check out the university. It's a great way to learn and get started on your journey of working with time series data. And that is it. I will leave it there. So hopefully I haven't run over too much, but that should be okay. Oh, I've lost you again, Yuri.
Again, I'm on mute. Sorry, I hope that I'm back right now and you can hear me again. Sorry. So it was a great presentation, really inspiring one, and lots of useful features included together with FluxDB. So I was surprised that you can start so quickly and get those results quite effectively. So really focusing on bringing the business value rather than writing boilerplate code to do the basic operation. So I've got a couple of questions about this presentation, if you don't mind, right? So so the first one would be, is it possible, so you have this example of a truck that is going through some roads with some additional sensors. For example, there is a temperature sensor inside. How would you build something that would also include alerting if the temperature within the truck has been higher than a certain value for, let's say, 5 minutes? We want to create an alert and reach out to the driver saying, hey, it might be a problem for the cargo.
Absolutely. So this is actually probably a component we didn't cover, but we actually have alerting inbuilt into InfluxDB. So we can actually monitor that trend within InfluxDB. So we can say, okay, well, the temperature sensor has been this high for over 5 minutes. What we can then do is within Flux, you have the ability to call endpoints. So we could call an endpoint back in IoT sensor saying, hey, we need to alert that this the temperature has been over a certain limit for so long, and flag an alert via IoT sensor. So we really have a full circle of ingesting data, querying it, and creating real-time alerts as well.
And I'm pretty sure it's all covered in the university courses that you have just advertised on the previous slide, right?
Yes, absolutely. Yeah, yeah. I must admit, Emily, our director of education, has made sure that she has covered everything. So it's a really cool project that we've been working on with her to make sure like all of InfluxDB
That is really inspiring. And one more practical question. Let's say that you are an architect building a project with Influx and you don't yet have a fleet of, let's say, 5,000 trucks that will have the sensors, but yet you want to simulate different scenarios and even to check the basic load, right? Are we okay with this load to ingest that amount of data at that rate? How would you generally do that if you would have such task and InfluxDB would be in the center of that architecture?
Yeah, so there's a few ways you can do it. You can either go through the Node.js way, you could go for it through a monitoring process, but the best way to get started, and the way I got started, was using Telegraph, which is our open source metrics agent. It allows you to collect metrics, anything from server metrics all the way through to generating fake data, to collecting IoT data. It's all configuration based, and you can spin up as many of these as you want. They're all Docker containers. I actually use it to stress test InfluxDB. So I'll spin up, say, 300 instances of Telegraph and have them all write to InfluxDB. So you can, it's a great way to understand how much you need to scale InfluxDB or how you need to develop your schema based on ingesting those high workloads. So there's definitely approaches you can take, and I can always discuss that with them after as well.
Definitely. Thank you very much for this answer. And I guess the last question before we move on to the next speaker is about that UI library that you mentioned during the presentation. It's called Giraffe, if I remember correctly, right?
Yeah, that's it. So go on, sorry.
Yeah. I just was going to ask, is it like bound to InfluxDB, or it is a generic library that somebody who has another source of time series data, maybe coming from a plain JSON file, not necessarily connected to InfluxDB, they can use it in order to build like a beautiful graph somewhere on their UIs?
Love that. So yeah, so Giraffe was devised. So that's basically how we built our UI and our dashboarding. And we just thought, okay, well, we can release this code to the wild and let people use it within their own applications. It's predominantly built to function with the way that we work interface with our client libraries. So it's a lot easier just to use directly InfluxDB in our client libraries, but that's not to say it isn't possible. You can convert your data from other time series sources to that format and ingest directly. But yeah, I always recommend as well, there's so many amazing like visualization libraries such as Plotly, D3, D3 libraries. I just think there's so much out there. So pick something that works for you.
Definitely. Thank you very much for the great presentation. And yes, it is impressive how you managed to squeeze all this material and all this huge amount of new and interesting information into 30 minutes. And the links for following up are great. So I think our audience enjoyed that greatly. Thank you very much for your presentation.
No worries. Thank you very much, guys. Cheers.
All right, and we are coming to our next speaker. So Enrique I see that he is already ready to join the stream, and I will gladly add him. Hi, how are you doing today?
Hey, how you doing? Good morning. All good here. So far, so good.
All right, thank you very much for joining. So Enrique is a solution manager at SAP, and today we will be talking about the automating of unit testing and also end-to-end testing with a help of Puppeteer, right? So we will see how to use Puppeteer to run unit tests on the solution before releasing it, which makes total sense normally, right? You don't want to let your end users test your software before you do. And we will also look at some of recommendations on how to run the library to optimize the UI for end-to-end testing experience. And for those of you who tried building end-to-end tests, you know that there are several layers of complexity that are involved there. And at the end, we will look at another Node.js libraries that we will use to automatically produce a report on the findings of this test, right? So unit testing and end-to-end testing, definitely one of the most important and hot topics at all the time, starting from like 20 years ago and going to 50 years from now. There will be debates about how to best do that, but one thing that people definitely agree on, that you should do that and should do that early and frequently. So Enrique, the stage is all yours. Please share your presentation, and guys in the audience, please share any questions that you have, and I will be happy to ask them right after this presentation. Thank you.
Excellent. Thank you. So I'll start sharing. And first of all, thanks for joining me today. Let me know if you can see my screen.
So far, it should.
I think
it's all good. Yeah.
Right. Okay, perfect. Good. So then, well, thanks for the introduction. So as mentioned, yes, I'm Enrique. I'm a solution manager at SAP Signavio. And just to give you an intro, well, why I'm actually using Puppeteer. So in our product, so in this one that is called SAP Signavio Process Insights, it's a solution that we are actually selling to customers so they can test and check what are the analytics and the KPIs for a specific process on their ERP. So without talking too much about what exactly we do with that product, the point is that at every release, the nature of the data that we're collecting and then showing and some part of the product to our customers, the nature of this data required that we had to test it manually. So that initial part of the process we couldn't automate, but there was a lot of effort on, well, how can we actually speed it up and actually to test this data in a more formalized and automatic way. So there was an opportunity for automation, and there's where I will start proposing them to use Puppeteer. And well, Puppeteer is basically a framework in Node.js then to actually that was developed by Google, initially released in 2018. So by now, already almost 5 years. And the reason why I propose is because I like that the documentation is very robust. So we'll take a look on that, the documentation. And there are also multiple methods that you can easily use. So the same what your user is doing in the user interface. So the same clicks, typing, scrolling, taking a screenshot. You can do all of this with Puppeteer. And that also makes it very easy, for example, with the screenshots automation, to actually give feedback even not only to your internal stakeholders, so for example, the development team or the functional leads, but you can also give feedback to the sponsors, because usually they maybe want to know what's going on with the project. So then you can simply take a screenshot of the part that you want to look at. And you can also adjust the viewport so that they can also see what will be the view on a desktop, what will be the view on a mobile. And then you can also make it very easy. So this is some of the multiple methods you can also find on Puppeteer. The other advantage is the clean slate of the browser. So that means that when you ask a normal user to actually run the test, the results for the test very likely will depend on the cookies that they have, on the security settings that the computer has. If they already changed settings, well, that also makes it very difficult. So maybe sometimes you have, I don't know, some user claiming that there is a defect, then you test, and then the defect doesn't replicate. So then there is the problem of having multiple users with multiple security settings and cookies that then you don't get the full picture or the actual picture. So with Puppeteer, what you actually obtain a browser that is installed, it's a Chromium browser, and it's starting with a clean slate, so there are no cookies, but it's configurable. So in case you want to set a specific user policies for that browser, you can also do it yourself. And also you can, if you have, for example, access to certain systems in your environment, and that depends on security certificates, so you can also have these certificates installed there. So in my case, when I log into the SAP Signavio systems, my Puppeteer recognizes that, well, and then also can do a single sign-on login to these systems, because it supports also the certificates. And well, as mentioned also, it's very visual because it opens, if you want to, it opens a browser and you can also follow up and then track all of the steps that the browser is doing on you. So for this session, what I prepared is we're going to launch Puppeteer, so the very basic stuff. So just to get you up to speed, so you can also learn how to look at the documentation. And we're going to collect test-based data. So the similar functions and steps that we do in our environments in SAP Signavio, we're going to do it as well, but on a web page that you can access, because, well, our systems are behind a single sign-on setup. And then at the very end, you will report the results of this unit test into a very simple format, so that then you can also share it with other stakeholders involved in the process. So some useful links at the very bottom. I'm going to share this page with you. So the Puppeteer documentation, we'll also use it here. And then now we can already start going to Visual Studio Code. Right. So the first thing that we're going to do, well, I already created a package.json, but we don't have anything there. I just initialize that. So the first thing we need to do is we need to install npm Puppeteer. And in the meantime, we already can import Puppeteer from Puppeteer, right? And we are going to go to this web page. Okay. So this one. So let's take a look at the web page, because that's something that you will very often have to do when you have your testing automation. So first of all, you need to study the page that you want to test often. And the best recommendation is that you actually have a cycle with the front-end team to actually be aligned on what will be the elements that you want to often test. If they can add maybe an ID or a class name, that also lets you make it easier for you to identify the elements. But then if that's not possible, so then what you cannot always do is simply, well, first of all, what we have here is a table. And this table will showing you the price of several crypto assets and with several attributes, right? So for example, the name of the asset, the price, how much they change throughout the day, market cap, and the circulating supply. So imagine that you want to test, well, if this data is according to the one that you provided. And as I was mentioning before, the nature of the data that we use at SAP Signavio for a specific table, it's collected in a manner that we cannot simply automate with APIs. So that means that still we will need to go here, if we were actually doing this as we were doing it before, to actually cross-check it and more or less like doing spot checks. But we want to automate that. So how can you do that? So first of all, we click on the element that we want to select. We go to inspect. And then you see here on inspect, it is highlighted the element that you selected. And here we see some of the attributes. For example, we see that it's a data cell, what we selected with the class name. And basically, this is, for example, how we can identify with Puppeteer that we are speaking about this element. So this is basically what is called selector. So I use Control-C to copy. And then determine this as a const selector. Just frame it as 1. And we open as a string. And we saw that it was a data set. So that means that we use the TD. And then in brackets, we paste the attribute that we copied. So if there was an attribute with an ID or there was an attribute with a name, so you could simply replace here instead of class, ID, or the name. But in this case, I'm basically telling Puppeteer, so this is the selector that you need to look for in the DOM. And then, well, the attribute of this element TD is the attribute class. So look for this data cell with the class name this. And first of all, so where are we? So we are in this URL, yahoofinance.crypto.com. And we just paste it here like this. Const URL. Ready.
Enrique, there is a small request for the audience to make your font size in the editor a little bit bigger. For some of the smaller devices, it's a bit difficult to see the code. Sure. So if you could do that, thank you very much.
Sure,
That's hugely appreciated. Thank you.
Okay, let me know if it's still too small. Because I have a large screen here.
No, I think it's looking better right now. Yeah, but if people need bigger size, I'll come back to the screen. Thank you very much. Yeah.
You can let me know. Thank you. Right. So then what we are doing now is we're telling Puppeteer, so what is the website that we want to test and what is the selector. And now with Puppeteer, basically you always have a main async function. So you need to define an async function where you are going to make all the calls to the methods that Puppeteer already provides you. And at the very bottom, you simply call that function. Now, let's start opening our browser, because basically we replicate the same steps that we as a user have. So basically, normally, we as a user have to first open a browser. And that basically means you make a call to the method launch. And then here in launch, we pass an object, some attributes, properties. And here the first one, we call it headless, the default viewport, so the size of the screen that we want to test on. And the height. Device scale factor. We just leave for a moment like this. Just close this. And well, as usually also we first open the browser. Now we go and we open the page. And we also need to tell topic. So now that you open this page, so where are we going to? And something that is very common and well depends on the website that you're going to test on. But usually the site where you test this requires that you click somewhere, and then this clicks basically calls an API in the backend. The backend needs to search for the data. It comes back. So it takes a few milliseconds to actually update a site. So before you used to have something that was called a wait page, wait for timeout, but you see this method is already removed. So then what even Puppeteer, before it was also some people were doing like this, but now Puppeteer also recommends it. What we actually do is, we just make an empty promise where you simply set a timeout. Right? So here we're just waiting for 1,300 milliseconds so that the website actually, the DOM actually renders the new content. And what is the new content? Well, the page that we are opening, so this URL. And now we look for the constant that we just determined above. Right, so first, let's actually open like this, and then we'll see. So what are we doing here is, we open the browser, and we open a new page, an empty page. We go to the URL page that we selected here before, find as Yahoo. We wait for the content to load, and then we wait for the selector. So the constant that we were determining here before, here, this is basically a selector. So even if you do a right click here, and then you can see copy, and then you have copy selector. So that's another method that we'll see later. But basically you are selecting or determining a selector to tell Puppeteer what element it should look for in the DOM. And let's just launch it like this. Now we go and run it. Did I have a typo? No, let me see. Well, it's saying that it's type module, but this one, I didn't feel like a type module before. I don't think this is the one. Let's see. Okay, now it's that. Cool. Sorry for that. So then let's do it again together. Now, so we run node index.js. So then Puppeteer opens its file. And then my other screen, this is what it opens. And then let's see what happens. So this is very annoying because well, now with all of the GDPR stuff, so every time you open a new page for the first time, it's going to ask you, okay, a lot of these adjustments and cookies. And because we didn't tell Puppeteer what to do with this modal, with this screen, we'll just do a timeout. How much? Well, for 30 seconds. So the package is waiting for the selector that we told him to look for. The selector was selector coin 1. It didn't find this selector. You get here the error. So it's telling you, well, you told me to find this selector and it was not on the page. So I just stopped the process and this is the error. And then automatically the browser closes. So what happens here? So because Puppeteer, as I was mentioning before, it's opening a Chromium browser that has no cookies, basically a completely empty. It's the same as if you downloaded, I don't know, Chrome Canary or Chrome Blue Chrome, just installed it now. It's completely empty. So it's the same like that. And that means that if you go to whatever page that is asking you for cookies on your preferences or your preferences cookies, it will actually automatically determine, like every time you run it, it will think that it's the first time that you go to that page. So what do we have to do for that? So, well, so we just open that here, Node.js again, and we need to find the selector for this item, for this button. And right click here, inspect. You see there's a button and the type submit, and you see here there's name agree. So you have here two attributes. You could select the attribute class button primary or the name agree. I think the attribute name looks more unique because maybe this one also is a button primary or secondary. We could test it, but I like it the other one. So then what we can do here is we first need to determine a selector for this. Selector accept cookies button, and we are calling it button. So there's a button element, and in the end, just close. And now, so we are not waiting for that selector anymore. We're waiting for the selector for the cookies button. And now we have to do also a simple click. And for that, we have a wait page click. And what click? Well, on the cookies button. We do another timeout so that we can also wait for the page to load. And then let's also automatically tell that we have to go again to that page. Why? Because of these cookies, you will notice that it actually redirects you. Let's actually just show it. So here, well, hope you can see it. So automatically, Puppeteer, maybe it was too fast. You know what we can do here? And let's actually do it here. Because sometimes when you want to demo or to test and to share with your other stakeholders, you notice that it's too fast. So what you can do here is just select slow-mo. With the slow-mo, you determine, well, for example, I want the Puppeteer goes a bit slower than it is. And here you can set it from 1 all the way to, I think it's 500. But in the end, with a 3070, it's already good enough for the eye to see. So now we open it again. And now you see here, it will go a bit slower. And now it's redirected. And well, here's what I'm going to do next. For the next one, I want to tell Puppeteer to go to this to the side above that we said before. So what are we doing so far? Well, we clicked on the button for the cookies, and now we're waiting for the page to load. And now we can actually wait for that selector. So the selector that we selected before, and that was called selector coin 1 here. And well, let's just do a quick console log to confirm that we got the right element. And all right, so now we're going to actually show the other method, right? So there is this method called eval. And before I show what it does, let me actually explain something on the page. So here, I do inspect. So I selected this data cell, and then this is the class. So this is my selector. Now, when I go to the console, I can run queries that are going to be, well, just applying to this DOM on that page that I am. So for example, I can run document query selector, and where we're looking for a data cell. So we pass TD, and then the attribute of the data cell that I'm looking for. We close the bracket.
And again, please zoom it a little bit in the browser. It's really tiny. Yes, now much better. Thank you very much.
It's somewhat really small. Thank you, right? Yes, here, this one. And here, what do we have again? So we run document query selector, and then we have the data cell that we are basically we're telling look for this data cell, and this is the attribute. So this all together, the data cell with the attribute is called selector. And basically we're looking in the DOM, so what is selector we're looking for? And then you see here, so this is the element that I found. And this is basically a kind of a query or a function that you can run inside the DOM and for that specific web page. So for the method at Puppeteer that you have here, you can search for that, eval. Let's make it bigger. So what do we have here in eval? So eval, what it does is, well, it's a method where you pass one selector, so the selector that is actually identifying that element, and then one function that will be running on this environment. And that's something that at the beginning is a bit tricky with Puppeteer, but then you can use to that. So you have two runtimes environments. So one is the actual Node script that you have here above. For example, you can determine another function here on top. But then there is another runtime that is actually inside the eval function. So for example, I can determine here the context x.1, and then we call this method eval, and this is the second runtime. So for this runtime, so we are saying, okay, let's look for the selector, and on this selector, we're calling the attribute eTextContent. Where did this text content come from? Well, because this is already existing in this in the DOM. So I can simply do here dot text content, and boom. So we get here the text content of this element. If instead I was looking for example, like this, the same selector, another query, children. So you see, you can start typing. You see here a lot of attributes on the selector. So if I'm looking for all the child nodes, so well, it shows me that there's some text there. And this is what I can call on this specific selector. So with eval, what you are doing is basically you are telling telling Puppeteer, okay, on this selector, run this function. And this function that you will normally run on the environment on Chromium. And well, whatever we are finding here, so the text content on this element that we're passing, the element in the selector, is stored in this variable, this constant one. And now just to prove that we get the same answer that we got here before, Bitcoin USD. So we just do a console log to test it. And we run again. So node index.js. Now it's redirected. And let's take a look here on the right, Bitcoin USD. Okay, so it worked. So we can close it here. And why did I have to close it manually? Because we didn't have this here below. So what we can do when we finish, and let's say we want to be sure that we already finished, so we use wait page, browser, close. And when we do something like this, then Puppeteer automatically finishes, because otherwise you see here the terminal show me that it's still a process ongoing. So I just do Control-C, and then I just close the process. Okay, so this was just to obtain this Bitcoin USD. But then as you notice also, I was when I was opening the web page here, I was clicking on Ethereum. So why did we get Bitcoin when in fact I was looking for Ethereum USD? And the reason is that this class name, this data set, is not unique for this specific element. So it makes sense. So what is actually unique is the row. So at the level of the row, here, for example, this class name is unique, the name. So for example, if I do here another document query selector, we say it was a row. Define specifically it USD. And if we do text content, we'll show all the text inside that. So it's actually Ethereum. And on the other hand, if I go to the Bitcoin one, we do the same. Document query selector, row, content. So what we find is that at the level of the row, the class names are unique, but at the level of the sub elements of the child elements of this row, all of the data sets have the same class names in all of the rows. So this makes a bit more, well, we have to expand, of course, the script to actually cover also for these small changes that we need to do. And for that, first, let's start with, well, we need to do some loops. And we have two options. So let's start here, say with the option 1. So with option 1 will be if you want to determine unique selectors. And for these unique selectors, let's say that you have what we can just call it selector it name. And that will actually show you the name of it here. And well, what you will be passing is, well, finding specifically it name, specifically class name that is under this, specifically row, the class name of the row, and then finding the child behind that. But then for the option 2, which is the one that I will prefer to use, is that we select a path. And there are, as mentioned before, so you have two ways how you can identify an element, so to define a selector. Sorry, I'm looking at the time. And one is by the name of the class or the attribute, or also by the path. And by the path, what I mean is if we go to the page again, so let's clear here the console. And let's open this one. By the path, I mean, you have here, there is a data cell, and this is the second data cell inside this row, inside this body, inside this head, this table. And that's basically a path. So you can also send a list of instructions to Puppeteer to say, okay, go to the div that has the ID fins res, and then go to the second div, and then open the first div. So you don't have to determine the class, as a string, but you can just tell him the first child, the second child, the third child. And that is what we can do, for example, here as well. So we go to the it name, inspect, we here the data cell, and you can do right click, and you can do copy selector. Now we copy the selector, and let's see what we got here. Second selector, path it name, and we have something longer. So what do we have here? So first of all, we are telling, okay, go to this table with this ID, and then go to the div that has the class name like this, and then go to the table element under this div, and then go to the body, and then go to the second row, because what is here, child 2, and then go to this data set that has this class name. So if we're actually just going to, well, this makes a bit cumbersome then to also do a bit of debugging, because then, well, Puppeteer sometimes gets clunky with this, well, it cannot literally process all of these strings. So then it's also usually useful if you just simply go here to the page, and then you start replacing, for example, we saw here OVX A, OVX H, And we then can find it here as a div in a table. Here is this one. It's a table, and this is the div. Right. So then it's basically the first one, and then I open the first one, and then we continue so opening like this. So rephrasing this in the path format. I was also preparing that before, so then you simply I just put it simply here, so that it's easier to compare. And it's shorter. So it's basically the same element that we are pointing to is the second data cell, but then we are just not passing the class name. We're telling exactly so what is the child element that Puppeteer should go towards to. So start in this table and then go to the first div, then table, the body, so what we already had here, and then go to the second child, second row, and then go to the second data cell. It's the same. So Puppeteer also will find it. And then this also gives us all the advantage that we can then easily run a loop on that. So let's start then with the loop. And for this one, simple loop like this. So we start with the first element because the first row in the table has the number 1 here. Then I was counting the number of rows in this table, so you can also make this more dynamic. You simply add another function to check how many rows are in the table, but then just for the sake of the demo, let's just set it to 26. So here. And we start just determining the selector. And the selector, for, as we said before, we will need to adjust it at each iteration. So we will then go and take this same string as we have it above, and then we're just going to change the row that we are going to look for every time. And what is the div that we have to update? So it's this one, the one that is under the body, because we have, as mentioned before, let's take another look at the page. So we have here the body, right? This is the body of the table. And then we have here all of the rows. And we just want Puppeteer to go to row 1 that you see on the right. Go to row 1, go to row 2, go to row 3, and take the name like this. And basically that means that we are starting the table, then the body, and then start moving the iterations on this part, on the rows. And for the rows, we just simply need to change the number 2, that's fixed, and we enter basically an I. So it's basically changing the iteration. And well, of course, so then we need to also store this in one variable. And we pass the selector that we just determined for the specific iteration. And then at the very end, so we push this into an array. Of course, we don't have this array yet, so it's defined, but you can do it here. And typo. And like this, so you simply pass this one and just store it there. And now let's quickly run it. Right. Oops, it's interrupted because we're not seeing here. Let's actually console log this one. We console log the array that contains the data. So now it goes. Okay, that's it. So now basically what we did now, we were just pulling all of the names that are in that table, in that specific table. And well, as you can guess, we're going to extend it a bit to now also not only obtain the names, but then also we will obtain the rest of the data. And for that, it's just very simple. We simply need to, as we did here. So what we did here, we just determined a selector for the name. Well, we'll do something very similar, just put like this, for the price, for the circulating supply. And then we also store this also in the price, circulating supply variables. And well, let's just change it here. It's going to be the price. And for the price, if we look again at this one, so the price, you simply will need to count, okay, it's 10, 1, 2, 3, 4, 5. I think it's number 2. It's number 2. Right. So then, because now what we are changing is before we're asking for the child number 2, because it was in this data set. So child number 2 is the name. So it's 1, 2, 3. So now we need to the price. And then 4, 5, 6, 7, all the way to number 10, which is the circulating supply on the right. Sorry. Let's make it bigger here. It's on the right, circulating supply, number 10. So that means that we're going to change here to 3 and here to 10. So then we have the selector for the price and supply. And then we do the same here for price and supply. And we do also the same here. We're going to store this into an array that is going to help us to store it and then to put it into a report. So we need to define another short array here to store the variables. And then we just store here the name and the price. So what we did here, so when we collected these 3 items, we just put it into one array. And then because of the next package that we're going to use is also working with these arrays of arrays. So then we need to store it into another array. So instead of having here name R, so let's rephrase it to data test. And here at the very end, we are going to have data test output. And we have data point. So we collected all this data. Here, sorry, I almost missed this one. So we also need to pass the selectors so that the eval function works on each of them. And we collect all this data, and then we store it into one data point. So basically one array with 3 items. And then at the very end, we pass this array of 3 items, and then we store it also in this data test. And at the very end, we just console this as well. And now we run.
Keeping the time in mind, we've got around 2 more minutes, and I think time maybe for one question. Okay.
Okay. Then if you want, then we could then, if you want, I can then stop it here. I mean, the repo is still public, and then we can have more time for questions. Because
absolutely. Thank you very much. And a huge kudos for the live coding session. I've heard people that were saying that doing pair coding is a little bit difficult because somebody's always looking behind your shoulder, and you have like 130 people right now looking at the code that you're writing. So it's definitely huge pressure. But for the audience, it's also a great learning experience to see how the actual code is created together with small problems and the ways to fix them. So thank you very much. It was a great session indeed, right? So a quick question before we move on to the next presentation, right? On the high level, what would you say is the greatest challenge of the end-to-end testing? Maybe the greatest challenge that you saw within your teams and how you approached fixing or solving that challenge?
Yeah, thank you. So basically, I would say that is the coordination, in the sense that while you are testing, the best recommendation is actually to freeze the code, so then there's no other pipeline updating the part that you are testing. And that can make it really, really difficult in a large organization. When, for example, you have to test today, but then at the same time there's pre-sales already doing some demo on the same environment that you want to test, and then it could be many cooks on the kitchen at the same time. And then the second one, once you already manage to have the coordination to freeze the code, the second best recommendation is to determine, also that will be very specific, to determine specific IDs or classes for the item that you want to test. So for example, here I was testing based on the class names or also based on a specific position on the path. But then if you can agree with the front-end developer team to, let's determine these IDs for only these items that you want to test regularly, that will make it very easy to just iterate on that. So I think that will be the second suggestion if you can implement it.
And probably from the other side also goes when the developers want to change something and they change the structure and all of a sudden some of the IDs are gone and the tests are starting to randomly fail. Yeah. We had the same situations with some of the teams, so it does require some of the coordination. And for one way that we were looking at it is to have the testing as the responsibility of the team itself, so not to split, so that within the team it's much easier for people to check the code and say, hey, this test is broken, why it is broken after this commit, and then fix it pretty much with the same approach as with unit testing. But thank you very much for your presentation. It was very insightful, and I'm pretty sure that everybody who is still having doubts whether the testing is worthy, or some people who believe that end-to-end testing is a very difficult task that requires some specialized training, lots of time and difficult setups like it was in the old days, right? You should really check out this presentation with a bit more details and see that it's actually very easy to start. So thank you very much for your presentation.
Thanks for the invite. And in case someone wants to get the dev repo with the rest of the script to do the test and the reporting, so I just passed in the comment section.
I think you pasted in the... So I will republish it in the public chat. So right now everyone should have the link available. Thank you very much. And then I will invite our next speaker. Hello, Natalia. How are you doing today?
Sorry, I was on mute. I am good. How are you?
Good as well. I was also actually twice during this whole presentation section on mute, starting to talk with the audience, so it's total trend of the day. And today we are going to talk about functional programming, and especially it's interesting with Node.js and JavaScript being a dual paradigm language where you can build the code with object-oriented style as well as with functional style. It's a matter of choice for each individual developer how to go with it, right? And these days, the functional programming concept is pretty popular in different areas of front-end as well as back-end developer. And we will learn about the libraries that will help to leverage this programming paradigm and also learn the basic concepts of functional programming. So, before we start with the actual content, right? So when I was in university, when I started my programming journey, my first university years, we were learning like Gang of Four patterns of programming, object-oriented principles, and the object-oriented approach was pretty much so much stuck in my mind as the right way, the enterprise and correct way to do software, that for me it was a little bit difficult then to make a switch to functional programming when it started to arrive. But then I was amazed of like how much you can achieve. What was your journey? How did you arrive to functional programming? Have you started your career with it, or it was some kind of a switch that you made during that career?
Yeah, I think like same like you, or lots of people, I started with object-oriented, and Java, it was the big thing, object-oriented Java in college. And I remember like we had a module that it was kind of different in college, where the teacher gave us a little bit of hint about functional programming, and it was in a language, I don't remember the name. It was so difficult, and he made us do an exercise. And I remember I found it so fascinating, but at the same time it was so difficult because you didn't have loops, you didn't have variables. It was just functions and functions. And just to make like a small coding, it was very, very complicated. So, but it always does stick in my mind. And then over the years, when I moved to front end, during my career, I landed in Angular. right? And Angular uses Next.js. And then I realized that at this point, the functional programming was coming in. You will find articles here and there and so on. So I put in the task to study because I wanted to use Next.js in the proper way.
Mm-hmm.
And then I just found it fascinating. So I just, until the day, because, now it's like very approach, especially now with React and functional components and Redux and so on and so on. Even Java, I have seen, from colleagues that also they use functional paradigm. So it's like everywhere. So I just think that is very practical.
It definitely is, and it is interesting to see because functional programming historically it was used a lot, and it was the paradigm that appeared, I think, before object-oriented programming. So historically it was the first one, but now with the UI frameworks like React being a bit like a big, big motivation to learn functional programming properly, as well as Next.js and other libraries. Lots of people are looking again at this paradigm and finding it oftentimes more effective than object-oriented. So glad to hear your presentation about the functional programming. Now I'm getting off the stage and the stage is all yours. And please start the sharing. And if you need any support, let me know. I'll be here in the chat.
Okay, thank you. I'm just gonna start sharing.
And right now we should be able to see your screen. Thank you very much. Okay. And the stage is all yours.
Thank you. Well, good morning, good afternoon, and good evening, everybody. So like we were talking, this presentation is about functional programming in Node.js. And I hope after this presentation, like if you have some idea about what functional programming is, maybe you're gonna have a clear scenario how it is, how to apply it. And not even in Node.js, but also if you're doing front end or if you're moving to another languages. So I hope that you can get a better understanding of how to use it. So just to give you a little bit of background about myself, I am a senior software engineer at Workday at the moment. I'm doing front end in React and TypeScript. Over my career, I work with Angular. Also, I work a little bit on Node for a while, and I started my career many years ago doing Flash developer. So I have been jumping like for different kind of projects over the years, and also as a side job, if we want to say it some way, I am an into learning instructor for the Spanish catalog, where I have JavaScript, TypeScript, and Vue.js courses, and also some code challenges. So in this presentation, I'm just going to give you a quick overview in general of functional programming. First, I'm going to do like an introduction, and then we're going to talk about the main principles of it. What are the advantages of using it? Functional programming in JavaScript, and then we're going to see some quick examples of libraries. And then we're just going to do the conclusion of the presentation. So introduction. I feel like for you to really understand how to use functional paradigm, you really need to go back to the basics, especially if you're used to use, object-oriented or not paradigm. So basically a paradigm, when we go to the definition, is just a way to look into something and a way to do something. So in programming, we basically use this as a method to solve a problem, how we approach a problem. So in programming, we have two big groups of paradigms. We have imperative and we have declarative. Imperative is the one that we use the most, that we are used to it. This paradigm focus on the way how we solve a problem. So within this paradigm, we have Java, even JavaScript, Python, Ruby, etc. All the language that we are used to use are usually imperative. Sorry. Then at the other side, we have declarative. So declarative, the approach is different because this paradigm focus on what needs to be solved, not in the how. So in the languages or scripts that we have, we can see HTML, CSS, and SQL. So here we have two examples. And one side, I have a little bit of code in JavaScript, which, I think this is something that many people have seen before. It's just basically, a for loop that is updating some variables based on the elements inside of an array. At the other side, we have a SQL query. So the approach here is different. In the JavaScript code, we are doing instructions to change the state of the program or change the values in the variables. So this is, I would say, imperative. But in the other side, with declarative, here we're just declaring what we want from the database. We're just saying, I want to select a gender and a sum based on this and this. I don't care about how the database or the system is going to do it. I just care about what I need from it. So this is a good example of how we see different approaches or the different paradigms. So what about functional programming? So functional programming is basically a subset of declarative programming where the desired computation is specified by composing functions. So composing functions are just basically functions that the result of one function or the return value is passed as parameter as another function. Of course, there are some languages that are more focused to the functional paradigm, and these languages don't have for loops, they don't have variable declarations, they don't have conditions. Everything is done through functions. And I put some names there in case that you're curious, but of course, because we are focusing JavaScript, we're not going to deep dive because JavaScript is multi-paradigm language. So to understand a little bit what is the approach of functional programming, we can see actually like a mathematical notation. This is very simple. We only have two mathematical functions. So one takes a parameter and adds an addition of 2, and the other one takes the parameters and multiply by 3. So here to update the result, I'm just basically calling the first function g, where I pass a value of 5, and then the result of this function is going to pass to us. So this, you can see here in more like extent of the mathematical expression. Basically, when we want to approach something, we divide that in like steps, and we encapsulate those steps in functions. When those functions called in certain way, we're going to end in a result. So principles about functional programming, same as like an object-oriented. Functional programming also have their own principles and terminologies. Sorry, I'm just going to... Okay, so one of the most important concepts about functional programming are the pure functions. Pure functions are functions that meet 4 conditions. The first one is that the same input would always return the same output. Then they don't do any reference to values outside of their scope. They don't mutate any state, that means that they don't change the values of objects or variables, and they will always return a value. So here I have like 2 examples of one pure function and one that is not pure. The first function that is pure, you can see that I'm passing a value of x and then multiply this value by itself and just returning the value. You can see that the function is not doing any change to the x value. It's just returning the result of the operation. In the second function, even though this one kind of looks pure, but it is not, because you can see here in the for loop, the array of items is being modified here. So that means that there is a change of a state here. So even though the array is returned, this function is not pure. So talking about change of the state, this is another concept about functional programming, that is immutability. So mutability is just basically that something that has already been declared or created cannot be changed. So that means that we never modify an already existing object or value. So what happens when we need something new? So what we do is that we create a new object based on the object that we already have or variable value, but this object has to be completely new. No override the one that we had before. So here there are like two small examples. We have two variables declared with let, and you can see here that I'm doing a change of a state here by changing the value of my age. And of course, I could cause an issue here because this value at the end, they don't have the same value. Here, I have an example of mutability where I'm using constants. So let's say I declare a constant with my first name, and then I want to attach my last name to my first name. So of course, I cannot override this constant. So what I do is that I create a new constant where I use the first constant as a base, and then I attach my last name. So you can see here, when we execute this code, at the end, I'm going to have access to the new constant with the full name, but I also am going to have my first constant. So that means I'm going to have historical information, how the information changes in the application. Then related to immutability, there is another concept called disciplined state. So this concept, basically what it says is that we try to avoid the direct mutation of the state as much as we can, and we rely on pure functions and immutability to generate new values and control the flow of information in the application. So for example, here I have the same functions that I showed you before. I have the impure function that changes the values inside of the items, but also I have a pure function that is the same as this one. The difference that you can see here, I'm creating a new array, and then I change the new, I storage the results into the new array, and I return the new array. So that means that this is the same function, but this one is pure. So imagine that you have an application where you're handling some form of a state. So if you use the first function, if you pass the array items, after the execution of this function, this array is going to be changed. But in the case of the pure function, after the execution of this function, this array is not going to be changed. Instead, you're going to receive a new array. So that means that with this new array, you can make the decision, okay, I'm going to send it to the front end for rendering, or maybe I'm going to use it for another execution, or maybe to update the state. But in this way, you will do it in a disciplined way or in a controlled way. Another concept, it is the referential transparency. So referential transparency just says that expression in a program can be replaced by the value without changing the result of the program. That sounds a bit complicated, but actually is very easy to understand. It's the same kind of mathematical functions that we saw before. We have a function that has addition of two numbers, and then we have another one that just take the value multiplied by 3. So if I call, let's say, first A, and then I pass the result to B with these parameters, I'm going to go 30. So referential transparency says that I can remove the call of A and just pass the result value of calling this function, and then I'm going to get the same result. So this is something that when we do functional programming, we have to keep in mind. Like, functions can be changed by their value, and then the program always going to return the same result. And then another concept that we have that is actually something that we use a lot in JavaScript is high-order functions. This is basically functions that receive as parameters other functions. And the most classical example that we have is the array, the functions to manipulate arrays. Like, for example, filter, map, or reduce. These functions receive another functions that is going to be executing every element in the arrays. So after talking, about all the principles and terminology of functional programming, so we can see what are the advantages of this paradigm. And that's the reasons why nowadays is so popular. It's because due to the immutability and the control of the state, the applications usually have fewer bugs. And also by experience, I have seen that when you have a bug, it's very easy to track down where the bug is being or is happening. Like if you have, for example, an unexpected change of the state of the application, you can very easily track back where the issue is happening and fix it. Another nice thing about functional programming is that pure functions are very easy to test. So when you have to do unit tests, it's very fast, it's very practical. You only need to call your functions, pass the parameters, and have the return value. And so you don't have to, put like maybe states or create any kind of hard coding preparation for the test. It's very easy. Also, they enhance the code readability because you're dividing the logic of the application of the process in different functions. So you can really track down and understand what is the flow of the information inside of the application. And then also related to the same thing, the function signatures in functional programming are very trusted, are very easy to understand, since you know what is the value expected and what is the value that the function needs to return. And also related to the same thing, concurrency. Concurrency means that when several processes try to access the same state, the concurrency is very easy to keep safe because we basically protecting the state of the application. So functional programming in JavaScript. Like we were mentioning before, JavaScript is a very special language because it's a multi-paradigm language. We can create classes. We can use prototypal inheritance. We can apply procedural or imperative paradigms, and also we can use functional. So that means that in your same application, you can do a mix of all of them, depending on what you try to achieve or what it makes more sense in code readability and code structure and so on. So one of the main advantages that JavaScript has is that functions in JavaScript are objects. So this means, or this terminology is called like first-class citizens or first-class objects. So this just basically means that we can assign a function to a variable, and also we can pass a function as parameter to another function. So this is like kind of a definition from the MDN web docs. So this is one of the things that we are kind of familiar when we're working with prototypal inheritance with functions, that also functions, they have properties and so on. So basically functions can be called, but functions also can have parameters and so on. So let's say in the update of ES6, there are lots of functional programming new features added into JavaScript. And one of those is the arrow functions. So we know that arrow functions, they don't depend on their scope, but also arrow functions allow us to write a function like an expression. So instead of using this notation, we can just use arrow functions and then even remove the parentheses and just have a simple notation of a function. You can notice that this function by nature usually is pure, because usually arrow functions, when you have this notation, it is always return a value. Then we have expression statements. So expression statement is when you have conditionals, but instead of using ifs, you will use the question mark operator, and then you can attach that to the expression of the arrow function and have some sort of a function expression, like a pure function in this way. Then we have, of course, the array manipulation functions. like we said before, those are high order functions that receive other function parameters. Some of these functions, usually they don't modify the original array. For example, when you call filter over an array, the result of this function is going to be a new array. So something that very particular to keep in mind, for example, reduce or map, you're always going to get a new array. So that means that these functions are pure, and also you can chain them, or you can, call one after another if you need a result. So for example, here I have an array of objects, and here I want to figure out what is the total price of all the objects that have the name drink. So for this, I simply call the array manipulation function filter. And first here you can see I have a very small arrow function, pure function, where I simply take the object and then I just do the evaluation that if the name is equivalent to drink. So this is going to generate a new complete array. And over this completely new array, I'm going to do a map. In the map, basically, I just going to transform. At this moment, I have an array of objects. So with this map, I'm going to transform this array of objects to an array of numbers. And I indicate this transformation by taking the object instance and just subtracting the price value. So after that, I'm going to have my array of numbers, and then I'm going to apply a reduce where the function is going to do an addition of every price in the array, and I'm going to end with a number. This is what the reduce function does in an array. And then I'm going to use some, this is a function over number objects that is just to express how I want the notation of the number. So you can see here that from an array of objects, I just apply one function after another, and so on, that at the end, price total drink is going to be a number that's going to be the total price of the addition of the objects that are drinks. So now we're going to see a little bit of JavaScript examples and libraries. So if you Google JavaScript functional programming, you're going to get loads of libraries. I just put some here that actually they're quite popular, and it seems that have like quite a number of downloads in GitHub. So you can, if you're curious, you can go and see them. For example, Node.js is very used, and Node.js has some like a very specific methods to compose function. That means that basically the same thing that we saw before, that you can call the function and then you can, pass which functions you need to call in a certain order. Some of these, I have never used them, but actually I'm just curious after doing this presentation, maybe to jump in. For example, this one, that is functional programming in TypeScript. And Bacon.js, I have heard about it. Usually I use Rx.js, but I have heard that also Bacon is like a simple, smaller way of Rx.js. And then to show you some functional programming in Node, I have some examples here. So I created like 2 examples. First example is just to show you how to do an API call, usually using the functional paradigm without any library. So you can see here, if I call this script, this script basically calls a free API that returns some like Star Wars information. So here I'm just subtracting the name of characters in the Star Wars. So to create this API call, I create a function. This function is a high order function that receives an URL, a function to parse the information after the API call has finished, and then another function that's going to handle the error in case that an error happens. And here, using the new fetch method in Node, I'm just calling the URL, and then using the then notation of the promise of fetch, I'm just taking the response and then transforming this response to JSON. And then after that JSON has been transformed, I take the data. At this moment, I have a JSON object, and I use the parse function that receives a parameter, and I pass the data. So you can see the composition of function here when there is one function called after another, and even there are functions calls inside of other functions. The same thing happens with catch. Catch is going to be executed if there is an error in the API call. And then same here, I just call the error function. So now how to use this function? Basically, I just pass the URL of the API, and then I pass the functions. The first function, the parse function, you can see here, is a very small arrow function. And also you can notice it's a pure function. This function basically takes the JSON object and applies a mapping and to transform or to subtract the name of the item. So basically goes through all the JSON and access the results object, which is an array. And then using the method map, I create a new array based on that JSON, and then I just subtract the name. So with this, I basically end, instead of having a JSON object, I just end with an array of names. And then in case that there is an error, there is the other function, which is also as well an arrow function. And then here, I just call a console log, basically to display the error in the console. Of course, because here I'm using fetch, so fetch always going to return a promise. This is asynchronous code. I need to use the then notation to then wait for the result. And then after this has finished the execution, I can show the result in the console. So some things that we can notice here. All the functions are pure. There are no direct change of the state. You can see there are no assignment of value to any variables. Even I don't have variables here. If you notice, I only have functions and functions and functions. And at the moment, I ending with a piece of information, but this piece of information is not being saved in any variable. So let's say from now on here, I can make the decision, of course, to take the value and assign it to another process, or send it to the front end, an API call, or so on. But you can see here that it's very straightforward. There are no change of state. There are no interruptions in any way in the transformation of the data. And I can see very clearly what are the steps that happen from the call of the API to end with an array of strings. So now this is only using pure JavaScript. Then I'm going to show you an example using InfluxDB. So I'm a big fan of InfluxDB because I use it quite a lot in Angular, because InfluxDB combines functional programming with reactive programming, which is another paradigm. And this InfluxDB helps you to handle streams of information. So you just don't see information as instances, you see them like a, let's say, like a flow or like a river or the streams of data that you need to control using functions. So this code is exactly the same that we saw before. So you can see the result is exactly the same, but this one used as InfluxDB. So in this example, I have Same, an API call function. There's also a high order function where I'm going to use, of course, operators and observables from RxJS. So from here, I'm just executing the fetch call, the same thing, passing the URL. But here, well, in RxJS, there is a concept of pipe. Pipe is basically a way for you to organize how the functions are going to be called in a certain sequence. So here, those are RxJS operators. So operators in RxJS are just basically functions that they do something with the data. They can, for example, filter the data, they can transform the data, or they can also do other kind of decisions in the flow of the data. So these operators here are just functions. And the pipe, basically what it does is that first call the switch map, where I take the response and I pass the response to JSON. And then I transform this data using a map operator. And you can see here, I'm using the parse function that I had before. And then I have a catch error in case then an error happens. So I'm gonna, handle the error in case that something happens. And so to use this function, because we're using RxJS, the syntax is a bit different. You need to use, the functions and all the concepts of observables, but it's very similar as we had before. I call the function, I pass the URL, I pass my pure functions to manipulate the data. And then instead of using the then function, I use a subscribe to subscribe to this observable. And then here, I just pass other functions to receive the result and show them in the console log. So those are like a very small examples, but you can see in both of them the same thing. We don't have a state. We don't have variable assignation. We don't have change of information unexpected. And everything is very tight and controlled. And if you read the order of the code, it's very easy to understand. And to test these functions, let's say, for example, you need to test your function to do the API call. You need only thing that you have to do is call the function, pass your parameters, and then test the results. So it's also very easy to test. So this is the end of the presentation. I hope that you learned something new, and I hope that you get inspiration for your next project if to use functional program.
Thank you very much. Great presentation indeed. And yeah, functional programming is getting more and more popular. So how would you say, does it make sense always to start your project as a functional programming project, or you have some sort of a rule of thumb to choose which paradigm to go for your next project? Let's say that the framework that you're using is not dictating explicitly whether it should be an object-oriented or a functional approach that you use. How do you choose?
Well, actually, that's a bit tricky question. I think for the same thing, because JavaScript is multi-paradigm, what I do personally do is try to use functional as much as I can, especially for this kind of asynchronous operations when you need to control the flow of the information. I find it's always the right call, right? Mm-hmm. But I feel like at some point you cannot use functional anymore. Like, for example, if you have like a state, at some point you need to modify the state. And maybe that state is an object, is a class. So in that point, then you can switch to object-oriented. Yeah, so basically that.
I see. Thank you very much for your presentation and for insightful details about how to structure and how to organize the functional code in your projects.
Thank you.
So, having said that, this is the end of this block, but not the end of the conference in any way. Thank you very much for having me, and soon the new speakers and new moderators are going to come to this stage and continue with another amazing subjects. Thank you.
Yeah, thank you so much for being with us, for your amazing moderation, for great questions, and to keep everything on the floor.
Have a great remaining of the day. See you in the next
Thank
conference.
you.
Bye.
See you. So I joined this time just to make quick announcement. From the beginning, we mentioned that we had quite limited offer for Node.js Summit, Global Node.js Summit. So now we have also the same kind of offer for Angular event. So if you want to buy and want to visit Angular Global Summit 2023 and spend 10 days with us, please follow the link, check the Juior Track, of course, is for free, and Pro Track is just $99, not 219. So please use promo code NODE99, and again, limited option, only 5 tickets. First 5 tickets we can give for this price. Another short announcement regarding another event that we have is React Global Online Summit 2023. This is actual price $99. I just want to make the announcement that we're working very hard to get really good use cases for you, great information, and the best speakers that we can involve. So please, first of all, if you have the idea what you want to share, or maybe you have some use case that you want to share, please submit the CFP form. You also can find it on the website, or you can join us like an attendee and visit Junior Track, Senior Track, and be with us and other our events. Thank you so much, and have a short break, coffee, tea, sandwiches, and see you very soon.
All right, what a great time together, and thank you all the speakers for the presentations, and thank you everyone who decided to attend the summit. And we wanted to say thank you also to our sponsors from Influx Data. So basically what they do, they have an awesome database, and definitely give it a try if you're working with some kind of time series data. If you worked with legacy databases, you know, it's just a nightmare when developers have to spend their time managing the infrastructure instead of shipping the code. So InfluxDB, they have a leading time series platform built from ground up to work and handle with the big massive volumes of timestamp data from sensors, applications, and infrastructure. And what's really cool about them is that empowers the developers to build real-time IoT analytics and applications, and you can do it with ease. It's easy to scale, and it gives developers the time to focus on those things that are actually matter, on those features that ship they need to deliver, and not managing the infrastructure. So definitely give it a try. You can check it out today for free, and you need to visit influxdata.com/cloud. Thank you, InfluxData, for joining us. Thank you, InfluxData, for providing your tool.
And good evening, good afternoon, good morning, everyone. I hope you all are enjoying the event so far. And please give a big round of applause for all the past speakers. So we are now coming into the third block of the event today. So I hope you all are enjoying. So next speaker we have got is Adenekan Wonderful. We have got the recording for him. He's from Nigeria, and the topic he's going to cover is senior front end and the topic we are going to cover is future trends and advancement in the JavaScript ecosystem. He's working as a senior front end engineer at Magic Labs. So let's start the recording for him.
Everyone, I'm Adenekan Wonderful. I'm a senior software engineer at Magic Labs. Today, the topic I'll be talking about is the future trends and advancement in the JavaScript ecosystem. Now, I've been writing JavaScript for 6+ years, and in those years, I've sort of learned some things the hard way and some things the easy way. And some of those things are the things I'm sort of going to talk about today. Which is how the trends in the ecosystem are actually working at the moment, or how some of these trends can pretty much help and enhance our output as engineers and the way we sort of see programming going forward. So before I continue, I'll be sharing a couple of things with you. Which is what we'll be talking about, the topics we'll be touching, the sections we'll be touching, and I will dig deeper into them. So we'll be talking about the overview, which is what really are this advancement, or what are these trends. We'll talk about serverless architecture in JavaScript. We'll talk about the rise of TypeScript. I think that one is the one I'm anticipating. We'll talk about the adoption of functional programming, and how we sort of did the migration from OOP or traditional imperatives down to functional programming. We'd also talk about the increased adoption of GraphQL in the JavaScript ecosystem and emphasis on performance and scalability. Now, all of these particular trends are trends that I have been into and also tapped out of, and I pretty much just want to give you a sense of what you should expect going forward with how JavaScript is placed, or how JavaScript will pretty much enhance in the future. Now, why should I care about these trends? You ask yourself, because in the early years of my development, I used to follow a very popular engineer called Traversy Media. I'm very sure most of you in this call will know Traversy, and I learned one really big thing, which is learning to be a late follower. Why that sort of has its own merits. He also has a couple of his demerits. Now, I learned the hard way that as much as you don't want to be an early follower to these new trends, you also want to pay attention to them to see how they sort of can help your work at the end of the day. As much as we have multiple frameworks releasing every day. People are creating use hooks for React. People are creating different component states or UI libraries for different parts of JavaScript. As much as you want to turn deaf ears to these trends, you also want to sort of make sure you understand how they can really enhance your work, and then you can make the decision not to follow these trends or follow them. Now, above all, these trends are trends that pretty much shape your future as an engineer. It doesn't make you a one-sided engineer. It gives you a very hyper focus to seeing different things, which is you don't have one way of doing things. You have multiple knowledge base to be able to feed into your entire engineering strengths and premise. Now, JavaScript is a very popular programming language that's widely used in modern web development. It has large and active community of developers who are constantly exploring new ways to use and improve the language. Now, as a developer, it's important to stay up to date on this latest trend, as I've said before, and advancements in the JavaScript ecosystem. Staying informed about JavaScript trends is also important for any developer who wants to stay productive, because as much as you want to stick out to your old ways, you don't want to commit to a framework that would get decommissioned in the next couple of 1-2 years because the maintainer probably got a big job at Google or Meta. You also want to make sure that, you pay attention to these trends and you know how they can sort of like, make your work productive. Now, it also makes you like, stay competitive and also relevant in the industry overall. By keeping up with this latest trend, you can improve your skills, write better code, and stay ahead of the curve in the constant changing world of the web development and even of its community. Now, one of the trends we're talking about is, as I said before, is number one, the serverless architecture in JavaScript. Now, this is a very beautiful topic for me because I learned about serverless a lot later in my career, which was something that would have really helped my career in the long run. Now, what's so special about serverless? Why is everybody talking about serverless computing, serverless architecture? Now, serverless architecture it's a cloud computing model that allows developers to build and run application or services without the need to manage infrastructure. Now, if you're very big on infrastructure, if you understood how infras were being created in the very old days, you realize that at the end of the day, architectures like the serverless architecture helps us to optimize microservices, micro front ends. It sort of allows us to stay in the loop of what's really going on. It allows us to manage the applications in bits rather than taking the entire application holistically. Now, in JavaScript ecosystem, there has been there's been a trend towards using serverless technologies as it can reduce cost and also improve scalability. Now, you don't get to think about your application as a full application. You get to think about them as micro applications because at this point, this architecture sort of makes you go fast. They make you really optimize speed for your entire team. And services like AWS Lambda, Google Cloud Functions have become so popular for building serverless applications with JavaScript. Now, what are the benefits, or what can I expect if I adopt this serverless architecture now for my team? Now, there's no need to manage servers for one, which is a very, very big advantage. With serverless architectures, you don't need to worry about provisioning, about configuring, about maintaining servers. They save you time and effort and allow you to focus on building your application itself. So now, with serverless architecture, you get to see that one person takes away the entire headache from you, and you just get to optimize for proper user experience and user growth. Now, there's also another advantage, which is also the pay-as-you-go pricing. I know this is pretty much not important for the quote unquote rich companies out there, but for startups, these are really important advantages or benefits for optimizing to architectures like this. With serverless architectures, you only pay for the resources you use. AWS Lambda is a very good example. Rather than having to pay for idle capacity, this can save you money and make it easier for you to scale your application in the long run. Most especially a very huge focus on startups or companies that sort of just emerging, or you have a very small team trying to try new stuff or new technologies. Now, another advantage is improved scalability. Now, serverless architectures are really designed to sort of help you scale automatically. They help you make it easy to add on sudden spikes in traffic. This can also help you avoid downtime and improve the performance of your application. Now, if you've probably hosted your server in-house before, you understand how much headache, how huge the headache of sort of trying to manage your server one by one is. You have to do so many testing. You have to do pen tests. You have to do load tests. You have to make sure that your server is capable of handling a couple of requests, maybe 5 million requests, 6,000 requests. But with services AWS, Google Cloud Functions, you already have a very huge established server helping to sort of do all those heavy lifting, and all you just need to do is focus on scaling your business or focus on scaling the growth of your company, if that makes sense. Now, this is so good. How can I go wrong? Now, aside from the fact that serverless is really good and it's so beautiful, we have a couple of challenges of serverless architecture in the long run, just like any trend in JavaScript. Now, debugging and monitoring. Debugging and monitoring can be a lot more challenging as you don't have direct access to the underlying infrastructure. I think above all, these things sort of have trade-offs. There are a couple of debugging technologies and monitoring you can actually put in your application itself rather than the server. So you can always catch and make sure that whatever downtimes you have is a lot more dependent on your architecture rather than your application itself. There's a couple of trade-offs that this really encourages, but there's also the cold start time, especially in the areas of Heroku. where we had like, this very idle time for like, every server to get up and running. Serverless architecture can have longer code start time as like, underlying infrastructure need to spin up new instances to handle requests. There's also like, dependency management. And there's also like, managing dependencies in serverless environments can be more challenging, as you need to ensure that your code is self-contained. I do not rely heavily on external resources. Now, should I still care about serverless architecture at the end of the day? You ask yourself. I think one thing that you need to pretty much understand about trends like this is serverless architecture is a promising trend in the JavaScript ecosystem, and it offers like, several benefits, as much as like, there's a couple of underlying challenges it might have, which is not something that a couple of people really would find as a very huge impediment. Serverless architecture is also a very like, huge promising trend in JavaScript ecosystem. It offers like, several benefits, including reduced cost, improved scalability, as I mentioned before, and reduced maintenance overhead, especially for teams that, don't want to hire multiple SRE engineers. You just really want to optimize on focusing on growth and the application, and you want like, a particular system or a particular architecture to help you handle the headache. I think serverless architecture is the way to go. And as much as anything in life, there's like, they have like their multiple trade-offs. Now, it also comes with like its own set of challenges, including difficulty with debugging and monitoring, as I said before, longer code start time and dependency management. But serverless architecture might not be suitable for all applications. But it's worth considering if you want to take advantage of its benefits and willing to overcome the challenges in the long run. Now, I don't expect like, large code bases to use this type of architecture. I expect like, really smaller businesses to adopt this architecture, as, it's really encouraging and will really help to overturn the server headaches that people always face, like, at the fundamental start of their businesses. Now, that brings me to my next stage, which is a very controversial one, and which sort of like, also took me a couple of while before I got into this trend, which was the rise of TypeScript. Yeah, I see the GIF. So now TypeScript is a very like, it's a very marvelous technology. Now, as much as anything, I was a bit like, reluctant about this trend, mainly because of so many reasons. Now, number one, I felt like, it was a trend that was going to like, get plummeted. It was, really funded it was really backed by the big Microsoft. So a lot of things could really like, go wrong, as much as like, the technology behind the system is really sound, which is like, having its own compiler, sort of like, this own thing, but still spit out JavaScript. I was just a bit like, adamant to the technology, and it's because I was ignorant. I really did not want to check like, what it had to offer, that JavaScript had to offer. And like everybody that's really like, adopted TypeScript to tell you, I don't think I would want to write a new language or want to join a new company without having TypeScript as their underlying technology. It's such a marvelous, like, it's such a marvelous technology, and I'm going to be talking more about it now. TypeScript, as I said, is as I said before, like, is a static type for JavaScript. Now, JavaScript is a very low level language, and like high level languages like C#, you have like, you have a standard way of writing these languages, because then again, like, you could define types, you could like, create static types, not create like, this dynamic low type, like, environment for a very heavy, like, application like JavaScript. Now, TypeScript came into the picture and helped to sort of like, mitigate this particular headache. Now, not again, why are you talking about TypeScript? I know you've heard it like, multiple times on Twitter, like, a couple of like, tech influencers advocating for it. I'm not here to sort of like, ring the bell. I'm just here to give you a very sound approach to exactly why you need to adopt this trend in your code, or you've not adopted it, you can slowly sort of like, ease into the adoption of TypeScript in the long run. Now, TypeScript, yeah, I know, TypeScript again. TypeScript is a programming language that builds on top of JavaScript. It adds support for static typing and other features that improve code quality and maintainability. Now, this just sound like, two very like, small words, but if you're handling like, large code base, if your application is going from like, 100 users to like, 100,000 million users, you are scaling applications to different product offerings, code quality and maintainability will become a very, very huge, add of your engineering team, because then again, like a code that you can maintain, you would always want to write like, over all of that same code base. So you enter like, companies that maybe were starting up like years and years ago. In the next 2-3 years, they will say they want to sort of like, rewrite the code base because it's not maintainable or the quality of code has depleted. With TypeScript, especially for large companies, oh my God, this is so important, because you even see like, some new engineers like being very reluctant about joining companies that don't adopt TypeScript yet, mainly because it's just really, it makes your life really easy. I know it sounds like, pretty small and simple, but it makes your life so easy. Like you can catch codes on time. It makes you a very smart engineer rather than an engineer that also like, that writes based on like, traditional imperatives that I already used to. TypeScript keeps your head up the curve, allows you to understand like, what to look out for even before like, they happen. I'm not making it sound like a magical framework, but it's just really, really good overall. TypeScript is a really amazing language. It's very good. And in the recent years, TypeScript has become increasingly popular in the JavaScript ecosystem. And it has like, its own, like it has a few benefits. Now, why TypeScript, you ask yourself? Benefits of TypeScript usually includes among its many benefits, there are a few ones, which is TypeScript can help you reduce errors and also improve code reliability. Now, it provides type check at compile time. Now, if you know the ways, the entire like, JavaScript line of rendering really works, that it's really important that whenever you're writing code, especially for engineers, you understand where the error is coming from at compile time. So, and the speed is really insane. So because, JavaScript has its own like, compiler, you don't have to like, wait for hours before you get a type check error. Now, type checking is really important for like companies that, are trying to adopt new standards, especially if you're very early and, you're trying to build an application that, like deep down is going to extend into multiple product offerings. That means you have your schemas in check, you have your types in check. Why not do the same for like, your backend and also your front end? That will pretty much like, help you mitigate the headache in a very, very long run. Now, it helps you like, also improve code reliability. You just know like deep in your mind that yes, this code is always going to work given any circumstances, because you tried it in like in different scenarios and it came out really strong. Now, it can also improve code readability and maintainability. Like I said before, it makes it easy to understand the intended behavior of a code. Now, I want to be able to enter a code base and I have to do like multiple comments about like about how a function works. I just want to go into the code base and see and understand, oh yeah, this is exactly what this function is supposed to do. This function is supposed to get in the generic type of an object or a type of a number, and it's supposed to spit out a Boolean. So, and these things are pretty much, it's like you're reading a novel. So it just makes it a lot more like, interesting for you to understand, and you don't try to rack your head out, oh, what is this particular argument supposed to be expecting, or what is this particular artist supposed to be expecting? I think TypeScript does gives you that proper like, understanding of intended code behaviors even before reading the code at all. So now, TypeScript can also help you improve the developer experience by providing like, features like autocomplete and type preferences, which is a lot more important, especially if you're doing like, large object types. You can always declare interfaces. You don't have to like, guess if your user interface probably has like, an image type. With TypeScript, you already sort of like, know from the interface itself that, oh yeah, this particular object is not supposed to have this particular property, or this particular property is not supposed to have this particular value. And TypeScript pretty much like, gives you that abundant separation of content that a lot of people really yearn for. Now, adoption of TypeScript, are people already using this? I know some of you might be sort of like, naive enough to ask like if it's just a very huge trend and people are really not using it. They are just going back to write their JavaScript and forgetting about TypeScript. Many developers and companies that have adopted TypeScript in their projects because it can improve significant benefits in terms of code quality and productivity, like I've said before. TypeScript is also supported by popular frameworks and libraries like Angular, React, Vue.js, Svelte, like a couple of like, really, really big languages that you you sort of like, or libraries that you sort of like, depend on. TypeScript actually powers your core technologies. Now it's also widely used by industries with in the industry, like with companies like Asana, Airbnb, Microsoft. Most of these people are actually also using TypeScript actively, like, in their code bases, which is like, something really amazing. That's something you're looking for. Now, as much as like, it's really good. Yeah, that's right. Yeah, it can't be all that good, right? Because pretty much like, talk TypeScript up. Yeah, that's very correct. It can't be all that good. Yeah, it also has its own challenges, just like the same way serverless architecture pretty much has like, its own challenges in the long run. Now, performance overhead. Now, TypeScript introduces some performance overhead due to the additional type checking that occurs at compile time. Now, I don't think this is something you really should bother about, but it's something that, worth mentioning, because the compiler has really like, improved over the years. The speed is really insane. And I sort of like, even see more and more like, contributions happening to the compiler in the long run. So this can also make it slightly slower than using plain JavaScript. Again, I don't think this is something that, it's a lot more important, because these are really unnoticeable, like, performance differences. However, in most cases, the benefit of using TypeScript in terms of code quality and maintainability outweighs the performance cost, as I said before. That's really true, because, at the end of the day, all of this only happens in compile time. They don't happen to users, because users still get the code as doesn't spit out like by the TypeScript compiler. So they don't get to experience all this performance overhead. It's just we as engineers that need to carry that cross, or that we need to bear that cross. And if I should bear a cross of a very unnoticeable, like, performance overhead that happens at compile time over code readability and maintainability, trust me, I will go for the code readability and maintainability in the long run. Now, there's also the learning curve, which I think is really, really an important challenge for a couple of people. One challenge of using TypeScript is that, we can have it has a very steep learning curve for developers who are not familiar with static typing, especially developers that, are coming from not a very like, high level language background, like developers have not written Java or C# or C++, like, they're just coming from a very like, low level language with like less static typing. It also requires a different way of thinking about types, and it can take time to understand the syntax and best practice, which I think like any other language, if you really understand its benefits, I think all of this, the learning curve outweighs the benefit that, the language really actually has to offer. Now, this can be especially challenging for developers who have a background in dynamically typed languages like JavaScript over statically typed. As I said before, I think the benefit would outweigh the challenges for you as an engineer or as a stakeholder in your company. And yeah, I think I advocate for TypeScript a lot. It's a really, really amazing technology. And if you're really up for it, you can also try it with like, smaller projects. If you don't want to like, push it in your very large, like, 5,000 lines of JavaScript code in your company, you can also start it gradually, if that makes sense. Now, in conclusion, yes, I love TypeScript. And yeah, the rise of TypeScript has reflected a trend towards using static typing and other features that improve code quality and maintainability in the JavaScript ecosystem. It's an increasingly popular choice among developers and companies, and it's supported by a wide range of frameworks and libraries. Yeah, if you're considering using TypeScript in your project, is worth exploring the benefits can provide in terms of code readability and reliability and the developer experience. Now, because my time is pretty much like, really like climbing down so fast, I'm going to breeze through the other like, trends that we have. Now, for trend 3, we have adoption of functional programming principles. This is really, really good. And some of you might say, but I love my OOP. I love my like, object-oriented programming styles. I'm pretty OG at it. I love writing my classes. Nobody can tell me otherwise. I think at the end of the day, I feel like I would dislike this trend, change my mind. So like, I'm really not here to change your mind. I'm just here to sort of like, explain the entire like, premise of the benefit of this particular like, of FP over like, OOP. Now, functional programming is a programming paradigm that, emphasizes on the use of pure functions and immutable data, as most of you already on this call already know. Now, in the JavaScript ecosystem, there's been a trend towards using like, functional programming techniques as they help improve code readability and maintainability. Libraries like Lambda, Lodash have become popular, providing like, functional utility functions. We also have like, benefits of programming language. We have pure functions that are easier to reason about. they don't have any side effect. Immutable data help to prevent unintended consequences. So you don't sort of like, have a particular data that's coming in and like, messing up the entire data tree or data journey. These data are pretty much like, immutable functional programming. And it can also make it easier to write code that's more predictable and easier to test. Now, okay, I'm sold. How do I begin? Tools and libraries for starting in functional programming slowly. There are several tools, something like Ramda, something like Lodash, something like Functional Redux, and many other tools. They provide utility functions for common tasks such as mapping, filtering, and also reducing arrays. In the long run, there's also like, the challenges of functional programming. I know it can't be all that great. We have debugging and testing, compatibility with existing code base. If you're working with like an existing code base, it's not written in the function style. It can be challenging to introduce functional programming concepts without refactoring large amounts of code. Same thing happened with like, the migration of React 14 to 16, where, we brought in like, the functional, the React functional components as opposed to like, class components. I think it's a bit like, harder to introduce these changes because it would require you to refactor the code base itself, if that makes sense. Now, in conclusion, the trend towards functional programming in JavaScript ecosystem is driven by like, benefits of pure functions and immutable data and so on and so forth. I'm going to be providing like, this slide at the end of the call, so you can also sort of like, follow through if you want or if you need it. Now, that also said, I will also be talking about the increasing adoption of GraphQL in the JavaScript ecosystem. This is so beautiful to me because as like the TypeScript, I also was pretty much like, adamant about like, adopting GraphQL or trying to like, advocate for GraphQL in my company. And yes, I know, like first TypeScript and now GraphQL is a trend. I know, yeah. I really didn't believe it, but yeah, it's a very huge trend. And I've seen like, a couple of engineers really like speak about the merits after they've sort of like, gone into this particular like, paradigms in the long run. Now, yeah, don't be angry. What's so special about GraphQL? GraphQL is also a query language for API that allows clients to request only data as they need. It has become increasingly popular in the JavaScript ecosystem as it can improve performance and flexibility of API. I'm very sure one way or the other, one of us, like, pretty much like, heard about TypeScript. Is such a marvelous tool. GraphQL is such a marvelous tool. And I've also spoken about like, the benefits of GraphQL. Yeah, why should I care about it so much? GraphQL offers several benefits over traditional REST APIs. It allows clients to request exactly the data they need rather than receiving a fixed set of data from an endpoint. I think for data optimization, especially companies that really care so much about data, I think GraphQL is really the way to go. I'm going to breeze through it because I see I have one more trend and a couple of like, other like, paradigms to talk about. Why is it so popular and when should I use it? Now, popularity and the use cases of GraphQL. GraphQL has sort of like, gain its widespread adoption in the JavaScript ecosystem. Many developers are using GraphQL in their projects as it can improve the developer experience and make it easier to build modern applications. Now, the use cases usually might be like mobile web development, web application development, microservices and architecture. God, this is so important. It's going to help you, like, save you a lot of like, headache, especially microservices, also in serverless computing. Data visualization and analytics. These are like, pretty much good use cases for GraphQL in the long run. So yeah, if this is part of your use case, I think it's something you should also really check. Now, challenges of GraphQL, the debugging and testing, and like any other language, performance and scalability. I think I would pretty much love to breeze through this. And yeah, I'm sold. The increased adoption of GraphQL is a significant trend in the JavaScript ecosystem. Its ability to improve the performance and flexibility of APIs has made it popular among developers and companies by staying informed about GraphQL and its use cases. Now, I think the final trend is emphasis on performance and scalability. Oh yeah, I know. I am no adios many, but I just pretty much like, want to touch on it. Yeah, I know. I feel like I've heard about performance 1,000 times already. Yeah, I agree actually. Like, I just think it's pretty much important I touch on it. I think one overview is performance sounds so cliche. A lot of people actually talk about it, but in the ecosystem, there's an increasing focus on performance and scalability. This is driven by like, growing demand for fast and reliable web applications that can handle large amount of traffic and data. Now, We'll talk about some trends and technologies that helping developers build high performance and scalable applications. Number one is server-side rendering. It has been popularized by Next.js. It's a technique for rendering pages on the server rather than the client, which has pretty much like, changed the way we looked at like, marketing pages, or even looked at like, building web applications. At the end of the day, now SSR can improve performance of web application by reducing the amount of work that the client has to do. Libraries like Next.js and Nox has become popular for building SSR applications with JavaScript. There's also code splitting and lazy loading. It's a related technique for loading only only the resources you need and when they are needed. Very, very similar to the way GraphQL actually handles API. And you can also call it like, the lazy loading for API handling. Both of these techniques can improve the performance and scalability of web applications by reducing the amount of code and resources that needs to be uploaded upfront. There's a performance monitoring monitoring tool like Lighthouse, SpeedCurve, and even also New Relic. And I think in conclusion, the focus on performance and scalability is an important trend in the JavaScript ecosystem. Developers have a variety of tools and techniques at their disposal to help them build high performance and scalable applications. By staying informed about these trends and technologies, developers can ensure that the applications are fast, reliable, and able to handle a very huge amount of traffic. Now, in conclusion, the future is really, really bright for JavaScript. The JavaScript ecosystem is constantly evolving, and there are many, many exciting trends and advancements on the horizon. Serverless architecture, GraphQL, all of this TypeScript, even WebAssembly are just a few of the technologies that are poised to shape the future of web development. Now, as these technologies mature and become more widely adopted, we can expect to even see more innovations and progress in the JavaScript world. It is important to stay up to date with these trends in order to take advantage of the latest advancements and practices. And thank you very much for your attention. I'm Adenekan Wonderful. Thank you very much for listening. You can follow me on Twitter, on LinkedIn, and even on my website. And yeah, let me know if you have any questions. I'll be in the QA section ready to answer any questions. I know they are very opinionated topics, and just give me throw your questions at me. I would definitely give you an answer from a pretty much experienced standpoint. So let me know if you have any questions, and I will see you in the next one. Yeah, bye everyone.
Hey, and Nekan, it was a wonderful and insightful talk. I hope everyone enjoy it. So if anyone has any questions, please type it in the chat box. So he's going to around for a couple of more minutes. So and he will look at the questions as well. So he will answer in the Q&A session. So I hope everyone enjoyed, and I think it was a wonderful time Anderson has taken in the explaining the topics and the innovations and the scenarios he explained. So the next speaker we have got is Adina Gaciu from Romania. She is a software engineer at Microsoft. So the topic she's going to cover is why use TypeScript with Node.js. So let me introduce Adina on the stage. Hey, hello Adina, how are you doing?
Hi, thank you, Sahil. Very well, and I'm here to convince everybody to try TypeScript, and not as a publicity for Microsoft, as a publicity of what I've tried and liked very much.
Okay, so are you super excited for the talk?
Yes, this is a great event. I've attended since this morning, and I've heard all the talks before me, and I'm going to moderate as well, so I'm very excited.
Okay, no worries. So could you please up your presentation?
Yes. I will share my screen in a...
Sorry, I forgot myself to introduce. I'm Sahil Choksi. I'm CEO of Weird Technology. It's a software testing company in Ahmedabad, India. So that's a little about me. So let me introduce the presentation on the board. So Adina, the time and stage both are yours. Thank you very much.
Thank you again, Sahil. So some unnecessary info about me. What I did before, I worked in the banking sector for about 8 years. If you are going to check my LinkedIn page, you will see that I have multiple jobs and tried different ways to earn a living. But what I do now and what I love the most was software development. And I started my journey, like so many of you before, in web development. I started with PHP, migrated to JS, and now I'm working with TypeScript. Before I will start my presentation to why use TypeScript with Node.js, I have to tell you a small joke about it. In my circle of friends, I have so many JavaScript followers, so I can say. So I had few discussions before I started to learn and do TypeScript. Why would I choose that? Why is that necessary? Why would someone choose static types? JavaScript is better. Okay, but have you tried it? Now, because I have tried it and I started learning and doing, I can honestly say it is amazing, and this is why you should use it with your Node.js applications. Okay, so let's just follow up. I have a small agenda. I hope everyone will be entertained and will leave me some questions in the chat. If you don't leave me some questions in the chat, we can chat on LinkedIn or anywhere else. So I will be starting with some history about TypeScript, when it was invented and why. Why is it used in the front end and in the back end, and some final thoughts about TypeScript in the Node.js world. So let's get going. As a history, and because it's cocktail hour, let's just say that on Wikipedia, if you search, you will find that it is a programming language. It was developed and maintained by Microsoft, no pun intended. And it was a strict syntactical superset of JavaScript. Okay, but how about we dive deeper and deeper about in that history? I will tell you the unofficial explanation. Write once, run everywhere and anywhere. What is this about this kind of syntax? This was introduced in the mid-1990s by the designers of Java language, because they envisioned this world of languages, this concept of write once and run anywhere, the WORA. This lives in all the modern web browsers, and all popular ones have today support for JavaScript and TypeScript. Why is that? You can answer that in the chat. Because of TypeScript, because it is a superset of JavaScript language, employs static types, checks, and allows consistent use of variables and reduce a potential source of programming errors. This is what I liked the most at first, because I did not have the undefined function or basic errors that could be interpreted by the browser. Question and question. Is TypeScript used in the front end or in the back end? As a definition, TypeScript is a programming language. Node.js is an open source, cross-platform, backend JavaScript runtime environment. It can execute the code outside of a web browser, and it is a perfect tool. Why am I putting these two notes here? Because if it's true that Node.js was used mostly with JavaScript in the past, but TypeScript has become increasingly faster, and it's better for scalable application to use. It has some awesome features, and it can be used both in front end and in the back end. I've added here an image about popular programming languages. This is from 2022. It's on the site CSS Tricks. while I'm searching how to center a div, I came across this kind of statistics. So TypeScript is compiled to JavaScript. So TypeScript can be used also in the front end, like my fellow speaker told you before, with popular frameworks like React, like Angular, like Vue. But it can also be used in the backend, in Node.js. It's very easy to write syntax from JavaScript to TypeScript. And in the backend, it's more powerful than JavaScript. Okay. What improvements have been added with the TypeScript? The static types, the classes and interfaces, the namespaces, the decorators, better IDE support. I'm not sure what you all have been using, but I really love Visual Studio Code and WebStorm as well. They provide better support for TypeScript, and you have better code completion, better error checking than any other programming language. Okay. The JSX support for frontend. TypeScript also supports the JSX, which follows developers to write components and the syntax that looks like HTML. So it's easier to understand. My faves from these parts are this, that TypeScript introduced some great features from object-oriented programming. As I told you in the first part, I started learning programming languages and I started with PHP. While back in the days, in my high school days, I learned Turbo Pascal. I kind of forgot every principle about it. So in PHP, I liked the most the classes, the interfaces, the object-oriented parts. I was not very keen on functional programming, while it is better in JavaScript to use more functional programming and I don't know, treat everything like an object. When you have a class, it's easier to understand. When you have generics, it's easier to work with. Why would you use generics, you might say? Because a generic type in TypeScript allows you to work with multiple types rather than being limited to a single type. Okay, I've added this class as a generic type because it was one of my easiest and to understand and to maintain. You have this variable t, which is used to indicate that the class can work with any type. This is awesome, my friends. Really, it's awesome. And actually, a study showed that 15% of all JavaScript bugs can be detected by TypeScript. Now, there are some reasons for adding static types to JavaScript. These are the easiest one that you can avoid masterfully hidden ninja errors like the classic undefined is not a function, or it's easier to refactor code, or it's easier to read complex code. But the official ones are that you can catch errors very early in the phase. Okay, you have better documentation because adding types to your code can serve as a form of documentation, making it easier for other developers to understand how your code works. How many of us have worked with legacy applications and pieces of code? I think most of us. We do not get to work with newer application and code as much as we like. So If we had better documentation, we could understand easy the code that was written before. We have a better scalability. The static types can help ensure that the code remains scalable and maintainable as the code base grows and evolves. It's easier in JavaScript to forget what a type of a variable has been or what it is used for, and easier to have those undefined in your console log. Another reason is that you have improved code quality and testing. Why testing? Because they can help ensure that the code base is testable and that tests are more focused and effective. While you can have unit test in JavaScript and check if a type is a string or check if a variable is a number, in TypeScript you can eliminate that. So you can be more focused on the actual results of a function or a piece of code would do. You will have better performance. I think my previous and fellow speaker said that you might have a low performance with TypeScript. Studies have shown that TypeScript static types can help to ensure that the code base runs at optimal performance due to the catching errors early in the development process. So it reduces the need for runtime type checking. Okay? The past few years, TypeScript has been downloaded more and more. So this is a graph. You can check it out at Microsoft's TypeScript, and you can see the usages and the commits and every code improvement that is actually added to that repo. Is TypeScript worth incorporating into my Node.js project? I think this is the answer that we all are seeking. Absolutely. Why? Because if you are searching, and don't trust me, this is just a presentation, this is only my findings, and when I work with TypeScript, this is what I saw that it improves. You can search on the internet, you can Google it, and you can see many answers like this. Yes, absolutely, it is worth incorporating into your Node.js project. Why? Because you can scale, your projects grow. You can have it all. You have to make abstractions. A static type system will help you and catch your errors. You will refactor. Not now, because maybe your application or your code, it's small, it's still maintainable, it's easy, many understand, you have colleagues that are older than you in that project. But as we all learned from the trends that are evolving each year, each day something new is invented. So refactoring your code might be a very good idea. So with type checking, it will be easier to find and correct the propagation of breaking changes. You will not need to follow every lead and every file. You will have, from building your project, the errors that you might find. And because it's not that difficult, if you switch to TypeScript, the best part is that the syntax is very similar to JavaScript. And in JavaScript, everything is an object. So now you know how to treat an object in TypeScript. What I wanted to add more in the Node.js world is that there are many, many companies and open source projects that use TypeScript already. So I've added some notable open source project that you can check out. I think from Next.js, we already saw someone adding some code today, but it's a robust, fully featured framework. It will create scalable and well-architected systems. Type ORM. If you want it or not, if you are an adept of an ORM or not, you can check it out there. Prisma. I think in the chat that there was another person that mentioned Prisma, another next generation object relational mapping field data model, some other Node.js frameworks. If that did not convince you, get ahead of yourselves that Ryan Dahl, it's one of the original Node.js founders, and he is now promoting and working on Dino. That is a TypeScript first Node.js alternative. I've already added in the links at the final of the presentation a video of him presenting at the JavaScript conference why he would choose JavaScript. Why she would choose TypeScript over JavaScript. I'm sorry. I'm so excited. I can add something more at this point. Some final thoughts that will make TypeScript even better. I would like to mention at least 4 areas that TypeScript covers. Predictability. With JavaScript, the main issue will be the legacy project that you can't be sure how a variable will transform during code execution. In TypeScript, the variables included some changes and types that you can always know what to expect. In JavaScript, sometimes an object key will get lost somewhere by the time another method that needs it receives the variables as an argument. And then what happens? You have a bug. Object.key is undefined. But static types will make it easy to detect such bugs early on. Sometimes, I don't know, maybe a field that has always been an array magically transforms into an integer. Yes, there are solutions in JavaScript. I don't know, you can check it out. It has own property or something like that. I think there are many methods. But is it worth your time to check that or to have a unit test especially for that every time you want to use it? I don't know. You can answer yourselves. Another area is about maintainability. TypeScript ensures that you know what to expect from variables you work with. Setting up the interface for objects takes a lot of time in the beginning, but it saves so much more during debugging. What would you say when you have to delete an object field and you need to use a destructor? TypeScript forces you to think about what you're doing. As a result, TypeScript does its best to prevent you from shooting yourself in the knee every time you change your code. The third area, I think I've mentioned it during my presentation and I will mention it again. It's scalability. You don't know when your project will grow bigger and bigger and bigger each time. JavaScript is very unpredictable sometimes and makes it harder to add new features to your project. If you already feel uncertain about a certain method in JavaScript, then it is time for you to use TypeScript. What is it's amazing also is the testing part and the fourth area that I'm already advocating. There will be no more unit tests affected by the lack of static typing in JavaScript. TypeScript, as I said, will require less testing code, and you will achieve in the same amount of time and certainty the requirements for your application. Writing tests are easier because TypeScript helps you set up correct mocks by implementing defined interfaces. Please don't forget to check out the YouTube video. Even Ryan Dahl, as I said, is switching to TypeScript. TypeScript at this moment has more popularity each year. It grows and grows and grows. Don't trust me, trust others and search for yourself. It's easier to start your own small project with TypeScript and see how the performance and the static types will be involved. There's official documentation here. There we have some benchmarks. Everyone tested it out. So yes, absolutely migrate to TypeScript in your own Node.js application. Thank you again. I think I kind of made it with the time.
Hello, Adina. Thank you very much for your wonderful talk. I think everyone enjoyed. If
Yes.
anyone has any questions, so please type it in the chat box. So we are having the Q&A. We have a couple of questions. So we are having Q&A after the next speaker. So thank you very much, Adina. I think you did the marvelous job, and I hope everyone enjoyed.
We have Q&A session now. We have
Sure.
Q&A session now.
Okay. Okay.
I can also
So
add the links in the chat.
yeah. So the first question, Adina. Yes, but you can catch errors with try catch. So what's the difference with the TS TypeScript?
Yes, you are very right that you can catch errors with try catch, but what if you typed already, I don't know, that variable and that object has a strict type, and you would not have to use that try catch. You would eliminate, like, I don't know, a few lines of code.
Okay.
More readability, it's easier with that. Maybe I'm going to tell you another story. I've encountered in my starting years some colleagues that would not understand the try catch thing in programming languages. So senior programmers would explain how try catch works, but they would have understand better if they would have known, okay, this is an object, this is a string, this is a number.
Okay. So the next one is for objects. Why don't you use the optional chaining to avoid the undefined and nulls?
Good question. I don't know. Let me think about it. Did not got to think about this one. Is it better? at performance.
Okay. If you know more about, I think you can surely chat in the
I
chat
can,
box
yeah.
about the more topics. You can think about it. So that's fine. So these two question is part one and part two. So there is a several years exist protocol type annotations on TC39 for JS, and it's the most popular request from developer static type by the last years on the statics of JS. So I'll read another one so you can make a judgment based on that. So why just don't finish it and get rid of TypeScript?
Yeah, funny. If I'm understanding correctly, so the person that is asking or saying this is a truly fan of JavaScript and would like to someone to enhance the abilities of JavaScript. Yeah. Okay. So why did TypeScript appear? Because, like I said previously, the creator, Anders, who also worked on the development in C# and the Turbo Pascal and Delphi, saw that JavaScript will not advance to this kind of type hinting. So he introduced like the object-oriented programming features into TypeScript to make it easier. Also, with every release of JavaScript, I think that they have given us some improvements because of the ECMAScript, but these features are not yet included. If we can ask those the persons from ECMAScript why I have not included static types yet, they can answer it. But for now, TypeScript is becoming more and more popular. And of course, because it's maintained by Microsoft, we have awesome engineers that provide newer and newer features.
Okay. I hope everyone got the answer. So the next one is, isn't TypeScript mostly the interface definition between components?
Okay. Let me see if I can understand this better. This is, you are talking mostly about front end at this point. Yes and no. Interfaces, you can use it in many ways.
Okay. Okay. So the one asking from the audience, Marco is asking, when you need to promote a language against the better one.
We don't need to promote a language against a better one. As I told you as a disclaimer, I'm not here promoting it. I started using it. I was hired by Microsoft like 6 months ago, so it's not about promoting anything. It's just about something that I really enjoyed doing. I learned some new features and I liked it very much. In JavaScript, I kind of missed those static types and using some object-oriented features. Like I told in the presentation, I liked very much the functional programming. I liked that everything in JavaScript was an object, but I kind of missed from C++ and C# and everything that I've worked with the features from object-oriented programming. So I liked very much the generic type. This was, I don't know, a game changer for me. And for the unit tests, I don't know about the others, but for me, writing unit tests was very hard and I did not like it. I like coding, but testing it was not my main.
Testing is my main area.
Okay. So because of TypeScript, it helped me create more focused unit tests. So I kind of like that. I did unit tests in PHP, and I always compare it with that. It was easier.
Okay. I hope Marco got the answer. So I think that's the end of the questions. Let me check, is any other questions left? I think there are no questions left. So audience, if anyone has any more questions, please type it in the chat box. I think Adina will answer them on the go, or connect with Adina on the social media so you can get more coverage as well. So thank you, Adina, for your wonderful time, and I think everyone enjoyed it, and you did the marvelous job in explaining the topic. Thank you very much.
Thank you. Thank you very
Thank you
much.
very
Nice
much.
event.
Same to you. So the next one we have got is the next speaker from California. He is Devon Anderson. He is a staff software engineer at LinkedIn. So the topic he's going to cover is the stuff that streams are made of. So let me introduce Devon on the stage. So just a second. Hello, Devon. How are you doing?
Good. How are you?
I'm very well, thank you. So are you excited for the talk?
Yeah, definitely excited. This will be my first time speaking at a Geekle conference, so definitely
Okay.
excited to get going.
Okay, let me share your presentation on the board. So the Devon, the time and stage, I think both are yours. Thank you very much.
All right. Thank you very much. Good morning, I guess, afternoon or evening, depending on where you are right now. So like I said, this is actually my first time speaking at a Geekle conference. So I'd just like to kind of start by saying thank you to our gracious host for giving me the opportunity. And to everyone watching, thank you for spending the time with me. Really excited to be here and to talk today about something new that was added in Node 18, and that is the Web Streams API. So first, though, a little bit about myself. My name is Devon Anderson, and I'm a staff software engineer in UI at LinkedIn. I've been using Node for a long time now on various projects, most recently when integrating end-to-end testing into some of our products. Other than work, though, I live in Oakland, California, with my wife and 4-year-old son. Plus, our little family is actually growing again, so I'll be welcoming another son in June. But that's enough about me. Let's see what we're going to learn about today. So the first thing we're going to do is we're going to have a little bit of a history lesson on data streaming. Next, we will learn what streams are and how to use them. Then we will learn about the the Node Web Streams API specifically. And finally, we're going to tie it all together with a live coding demo. It's a lot of stuff, and we don't really have a lot of time, so let's just jump right in. All right, we're going to start off with a quick, and I mean very quick, history of data streaming. So data streaming has been around since the early 90s. In the context of the web, though, it has been in web browsers since basically the beginning. Assets like HTML and images are streamed to the client. So if you joined us via desktop for this conference, then you've already been introduced to streaming today. In 1995, video streaming was introduced to the world through the application called Real Player, which I am old enough to remember. And next, if we fast forward to 2015, streaming is introduced into the JavaScript public API for the first time with the Fetch API, which basically replaces the XML HTTP request for fetching resources. And finally, in April of last year, streams are made publicly available in Node through the Web Streams API. All right, so the streams have actually been with us the whole time in Node.js. Each of these libraries uses streaming for different purposes and has basically since the beginning. All right, now that we know a little bit more about the history of web streams, let's talk a little bit about how they work and how we can use them. All right, since like so many people, I'm a big fan of coffee. Let's use coffee as an analogy to explain how web streams actually work. Now, without streams, you need to do things one step at a time. So, if you're dealing with a really, really large file, you would need to download the entire thing, then convert and process it in its entirety. Now, Node.js can only really store about 2 gigabytes in memory at a time by default. So if it is a really, really big file, then it would kind of be like trying to grind an entire bag of coffee at the same time in a small grinder. Now with streams, you instead break up a resource piece by piece and process each chunk on its own. So it'd be like, grinding a little bit of coffee at a time, so you can put it in the filter and pour the water over it 1 cup at a time. Now, this certainly works really well when you need to make a lot of coffee. All right, so let's get some of the terminology down here. A chunk is like the coffee you're going to grind. You don't grind it 1 bean at a time. You grind enough to make a cup of coffee, right? So in terms of data, you usually don't stream 1 byte at a time. You make a logical choice on what each chunk should contain. Now, before we can even get scoops of coffee to grind, we first need to have a source of coffee. This is where a readable stream comes in. A readable stream takes an underlying data source, or in our case, a coffee source, and provides the mechanism in which to scoop out the coffee in perfectly cut portion chunks. So readable streams can take 2 types of sources. One that pushes data out constantly, which would be more like one of those coffee bean dispensers you see at the grocery store. The ones that you use kind of like a lever to open the door, the beans start to pour out. Things like WebSockets and live stream video are push sources. Now, a pull source is more like the coffee bag in the picture, where the coffee stays static, waiting for you to scoop it out. Things like HTTP requests, those are pull sources. Okay, now that we have our coffee, we need to have somewhere to store it when it's ready. This is where a writable stream comes in. Now, a writable stream streams data into what is known as an underlying sink. Now, a sink could be any writable destination, like a file, a database, or in our case, a cup of coffee. So we kind of skipped over one really important part in the process of making coffee. So, we have the readable stream that lets us scoop out coffee. We have a writable stream, which lets us pour our finished coffee into a cup. But we can't just drink coffee beans, right? What about the part in between, where we actually make the coffee? Well, that's where the transform stream comes in. So transform streams take in data from a readable stream, transform the data, and pipe it into a writable stream. This would be just like pouring hot water over the freshly ground coffee beans to fill up the carafe. All right, so I mentioned the word piping in my transform stream example. So streams are generally piped into other streams, like a read stream being piped into a write stream to form a chain that reads data from a source and writes it to a sink. So in our coffee example, the scoop and the carafe can be thought of as the mechanisms for piping. We take coffee from the source, pipe it into the filter. After the coffee is brewed, we use the carafe to pipe the coffee into the cup. So when we pipe several streams together, we form what is known as a pipe chain. Now, when we have a pipe chain, there may come a time when there is a slowdown at one point in the stream. That can result in a backup of data further up the stream. This would be like, us continuing to grind coffee when we run out of water to pour and ending up with more coffee than available space for it. So streams actually have a built-in mechanism for handling this situation called back pressure. The stream will actually propagate a signal back up the chain to constrain the flow of data until things are moving smoothly again. So just like turning off the grinder while we boil a little more water in the kettle. All right, lastly, we can split a single readable stream into 2 streams through the process of teeing. Which creates 2 new branches and can be used independently. This would be like having, having 2 people scooping coffee from a single bag with one person scooping into the pour over carafe and the other person scooping into like drip coffee machine. Now, when we put it all together, we get something like this. The coffee is scooped from the bag in individual cup-sized chunks. The readable stream, the coffee is then ground, put into the filter and the carafe, and the water is poured over it to make the coffee, which is the transform stream. Sometimes we might run out of water and we need to slow down our grinding while we wait for more water to boil. That's called back pressure. And then we pour the finished coffee into our cup, the writable stream. Then finally, we get to enjoy a nice cup of coffee, which after all this work, we definitely kind of earned, right? All right, so now we've had our fun little analogy. It's time for me to absolutely bore you to death with an analogy-less overview of the WebStreams API itself. Now, I promise I won't spend too much time here, since this is all readily available online. We just need to have it fresh in our mind for when we start coding. Okay, so the readable stream accepts an underlying source object that lets you define 3 methods. The start and cancel methods are each called once at the beginning and end of the stream, respectively. And the pull method is called whenever a new chunk is requested from the underlying source. Both start and pull methods get access to the stream controller, which controls the state of the stream itself. So this allows you to queue up the next data chunk, close the stream, or set the stream to an error state if something goes wrong. Now, the readable stream has a few instance methods. The getReader method returns a stream reader instance that allows you to manually request data from the stream. The T method, as I discussed earlier in our analogy, this splits the stream into 2 new independent streams. Now, the pipe2 method allows you to pipe a read stream into a write stream directly, and the pipe-through method is for piping directly into a transform stream. The pipe-through method returns the stream so you can continue to pipe to a write stream afterwards or get reader and continue to use the stream as you want. Now, the readable stream has a locked property, which can tell you if the stream is currently locked. Using getReader or T will lock the stream, making the other methods inaccessible. Okay, now for the writable stream, as you can see, it's very similar. The writable stream also accepts an object, but this one has 4 methods. The start and close methods are used for setup and teardown of the underlying sink, respectively. And the write method is used to write a single chunk to the sink. All 3 have access to the controller, which is essentially just for throwing errors. The abort method is called when an error actually occurs. All right, like the readable stream, we can manually access the writer using getWriter and write chunks to the underlying sink. And once again, the lock property can actually tell us if the stream is currently locked to a writer. Then lastly, we have the transform stream, which also takes a single object as an argument with 3 methods. Start is called before the first transform, and flush is called after all transforms are complete. These are good places to add, prefixes or suffixes to the transform data, and the transform method is where you will do all the transforms on the data itself. Each method provides access to the controller, and the controller is basically the same as the read stream controller, allowing you to close, error, and queue up chunks for the stream. All right, see, that wasn't so bad. Now, with the WebStream API fresh in your mind, let's go ahead and build something. All right, now this is probably not what you were expecting, but bear with me on this one. We're going to build a little service that works with a large data set containing artist and song data. Now, the file in reality, the one I'm going to be using is only about 22 megabytes, but we're going to pretend it is really, really big. In reality, working with a sufficiently large file on the laptop I'm on right now would most definitely, we'd still be waiting for the entire thing to stream well into the next talk. But I digress. We are going to use a data set containing artist and song data, like I said, and we're going to stream it, transform it, and make it a little more cat-friendly, and I'll elaborate on that in a bit. Then we're going to write it to a new file. Now, the data currently looks like lines of this, and we would like to get this into something a little more web-friendly. So we can pretend to use this data later for an API. So we are going to convert it into JSON as we go. And so then we're going to actually take the song and we're going to replace a random word in the song with cat. And that's kind of what I mean by a little more cat friendly. So it looks like this. Now, additionally, I have a small server running that generates a URL that points to an image of a random cat. We're going to add a URL to each chunk of our transformed data by first fetching it from our server. This will help to sort of illustrate how promises can actually be used in streaming. Okay, now let's really start building something. I'm going to switch over to VS Code. All right. Okay, we should get that. All right. Okay, so I'm basically just going to be working with 2 files here for the entirety of this demo. So this is our input text here. As I said, it's just a bunch of song data, right? And we've got it in the format that I had previously talked about. So we got a track ID here, we got the artist, and we've got the actual song. So this is what we're going to be working with. So it is about, I think, 20,000 lines of song data, which we will be processing. So now, usually, when you want to work with files, Node actually has some built-in ways to do so. Using the create read stream and create write stream from the file system module, you can actually, create streams directly from files right off the bat. So we don't actually need to use the Web Streams API specifically. But this is of course a talk about the Web Streams API. So for the purposes of this demo, I'm going to do something that's a little unorthodox, and we're actually not going to use this. So instead, I just I want to kind of illustrate and show you exactly how to sort of use readable and writable streams and kind of the inner mechanics of them. So we're going to do something that we wouldn't normally do in an actual application. I do have a library here that is going to basically the nReadLines library provides a class here that essentially just creates a file line reader, and it reads in a file line by line into a buffer. And so we'll use that as our underlying source. Yeah. So we can start off here. We're going to create our read stream first using a new readable stream. First, I guess we should probably import those. So we will import from our Node module, from the stream module itself, and from web streams specifically. And what we want to get in this is we want to get our readable stream here, our writable stream, and our transform stream. And we're going to create a new readable stream here, pass in our configuration object. Well, and we're going to be making use of the start and the pull methods from that. That's our controller. Now, in the start method, we are going to set up our line reader here. This is going to be essentially our underlying source. So we can create a new line by line, pass in our input file that we have set up already. Right, and with this, so essentially, the line by line class provides a method next that allows us to basically just continuously get the next line until we run out of lines. So we will do this to continue to pull lines from our file, and essentially all we want to really do is just use the enqueue method to queue up a new chunk. Now, like I said, it reads lines into a buffer. So each chunk will be in an array buffer. We want to convert that to a string. And Now, streams can actually work with strings, or they can work with buffers. If you wanted to make this work with a buffer, you can actually set this the type to bytes, and that will actually create us a byte stream that can work with buffers directly. But for the sake of simplicity in this demo, we are going to work with strings to make things a little more readable, easy to work with. And now you always want to make sure to close your stream when you're done. That way it can actually finish running. All right, so if we actually if we can actually log this, if we can log our chunk we're getting. We run this, and we can actually see so we're starting to get all of our data being streamed out of our actual file. All right. Okay, so for the next one, we have two things we want to accomplish here, right? We first want to sort of catify our lyrics, and then we also want to transform everything into JSON to make it more, API friendly. So we're going to create actually two transform streams. So the first one we'll push the data through and we'll catify it, and then the second one will actually transform it into JSON. So we'll do our catify transform here. We have a new transform stream. And so for this, we are going to just make use of the transform method, which gives us a chunk of data and the controller. And what we're going to do, as we saw the data before, we have our track ID, our artist, and our song. So what we want to do is we want to sort of extract. We want to extract the song. We just want to extract the artist and the song from this data. And we'll just split at the separator here. We don't really need the track ID for any of our purposes, so we'll just get the artist and the song. So then we'll just take the song and we'll split it at each space so that we can replace a random word with the word cat. We'll get a random index just by, this basically will just select a random number and we will constrain it to the length of our actual array. So then we'll take our song words with our random index. We'll just replace the word Derek with cat. And we'll take our catified song. And that's just basically our song words again. We'll join them with a space. Okay, so we have our catified song. And that basically, has made our song a little bit more cat friendly. Now, the next thing we wanted to do, of course, is we wanted to actually add a profile URL. So I actually have a little server running right now. Very, very simple. Just curl. We get we get a URL right here. So what we're going to do, this basically, what we want to do is we want to fetch a randomly generated URL from our server. And add it as a profile URL to our piece of data. And so this is going to help us to illustrate sort of how to use promises. Each method from a stream can actually return a promise, and the promise it'll wait for it to resolve before continuing on. So we'll actually use another feature that was added in Node 18, which is the native fetch API to do that. Makes life a lot easier. So we can we can use async await here. Just fetch from our server. It's just returning text. And now it gives us the profile URL. Now we just want to queue this again. So we'll just put it back into the same format we had before. Artist, using the separators. Our catified song. We'll make sure we get that in there. And our new profile URL. Right. Now, the second one we want is we want to do a JSON transform. Okay, and we are going to make use of the start, the transform again, and the flush, which is the finish method, which also gets a controller. Okay, so we are, so since the data that we're dealing with, is kind of a list of records, each containing an artist and a song. When we want to kind of transform this into something a little more API friendly, what we're going to get here is sort of an array of object literals. So if we're creating an array, then of course we want to have our opening and closing brackets. So we are going to simply just queue up, our opening and closing square brackets for our array. And the bulk of the work that we're going to do, of course, is always in our transform. So the first thing we're going to do is we'll just get our data again. We want our artist, song, and we want our profile URL. Get that from our chunk, again, splitting at our separator. Okay. Just want to create a record here with all that data. And then all we're really going to do is just queue this up. Now, of course, we are dealing with, and we have to stringify this. Oops. All right, and because we are creating an array, we need to have our comma separators for our array entries. And so the best place to usually do this would be at the start, seeing as we know we have our first entry, and we don't know where it's going to end necessarily. We don't have a good way of figuring that out. But of course, we're going to have a little problem if we do just blindly add commas. We need to sort of make sure that we don't add a comma for the first record. So we'll just add a little flag here. And basically just do a quick ternary. Don't add, if it is the first chunk, we don't add one. Otherwise, we add one. And then just set our flag to false. And that should give us not as pretty, but well-formed JSON. And then finally, we have our write stream, the last piece of this. So we get a new writable stream. We're simply going to make use of our write method, which gives us our chunk. And all we're really going to do, the only thing we really want to do is we want to write this into a file, basically a new file. And so we will make use of a module. We will make use of our file system module. Just want to append. We just want to just append to a file. We'll use the synchronous method just to make things simple. This will actually create the file if it doesn't exist. And so we just want to output this into a JSON file. All right, so we have everything set up now. We have our read stream, our transform stream, and our writable stream. So all we really need to do now is we need to take our read stream and we need to chain them all together. So we need to pipe this through our catify transform first, then pipe through our JSON transform, and finally pipe to our write stream. All right, now if we run this, make sure there's no error. Oh, we got, of course. What did I do wrong? Oh, of course. Didn't append the actual file. So we want to append our chunk, and we strip out the line reader strips out the new lines basically when you go to string from the chunk, so or from the line. So we'll add in our new line again just to make things readable. Hopefully that will. All right, yeah, that seems to have fixed things there, of course. Okay, so this is going to take a little bit to run. Like I said, about 20,000 lines, which is not really that much, but for this little laptop, it will be. Now, let's go back up and kind of take a look over what we've done here. So, like I said, this is not kind of the approach you would be taking if you were just reading from a file. There are perfectly good methods right here to work with files. And like I said, so there's a bunch of libraries in Node that already have streams available that you can use from the library. You would want to create a readable stream. Maybe if you were working with a database that didn't have a streaming option. Some databases in with their with the Node connectors actually have streamable options. But if you didn't, this would be that would be a good reason to create a readable stream. So with our transform, we split our transforms into two different transforms just because we want to make sure we're, separating our concerns effectively and only making, each transform do what it is intended to do. There are some default transforms that come with Node. So the one I know about, at least, is there's a text encoder and decoder stream. And that basically does the same thing as text encode and decode, but just in streaming form. So if you want to encode or decode from different formats, you can do that. But transform streams are a very powerful feature. You can use them for all sorts of things. Of course, there's you could do video, you could do live stream video conversion. You could do some video effects in a live way with a stream like this. We could do that with images. There's all manner of things you can do to transform data. And yeah, everything kind of comes together in our writable stream. Now we're just outputting to a file. You can stream in many different ways. So we can actually see right now our output JSON is actually being filled up as we go. So I guess, basically it'll read a bunch of chunks to begin with until it fills up sort of it fills up the queue. You can actually set the size that you want. Oh, we got a bad flush control. Oh, look at that. I made a mistake right here. Anyways, for the most part, we got everything here, but we have, you can see now we have our transform data in our JSON form, right? So we've got our artist, our song, with our catified lyrics, the cat of Aspens, of course. Cold beer cat. That's awesome. So then we have our profile URL added and everything's in, well-formed JSON. And yeah, so that kind of shows us, a little bit about the power of streaming. Oh, look, I was not taking a look at, someone actually commented that I did misspell controller in there. Well, luckily things mostly worked out. Gives you a good idea of, gives you a good idea kind of what's there. So I'm going to just come back to our presentation quickly. All right. So, as you can see, from my example, I mean, it's not, it's more like just a toy example. But you can definitely see, a lot of power that we can have in streams. And so, what can we do with streams in a real sense? Well, there's the obvious one, of course. There's streaming video, big data processing, logging is definitely, there's a lot of logging libraries that use streaming for logs. Definitely helps when managing large systems. you can make perf improvements. So, streaming can actually be used, to stream certain portions of your web page, so that you can, maybe improve your first contentful paint, stuff like that. And then there's your imagination, right? We can use streams for whatever you want. I think that's kind of the point of this, is to take this and go ahead and experiment, get creative, and figure out what we can do with streams. All right. Well, that is my presentation. Definitely want to say thank you for spending the time with me again. And yeah, I guess that's it. And time to open it up for Q&A.
Hello, Devon. Thank you very much for your wonderful and insightful talk. I hope everyone enjoyed it. So if anyone has any questions, so please type it in the chat box right now. So we have Devon on live at the moment, so you can answer the questions. So I think we will wait for 1 minute, Devon, if you don't mind.
Sure.
So we will let people to type the questions. Okay, I think there is no sign for the questions.
No worries.
So in the meantime, if anyone has any questions, please feel free to type it in the chat box. Devon will answer the questions on the go, or connect with Devon on the social media like LinkedIn or Twitter or whatever the Devon has on the line. So thank you very much, Devon. I think you did a wonderful job and explained marvelously with this detailed and insightful talks. And I hope everyone enjoyed. Thank you very much, Devon.
Thank you very much. Had a fun time being here. Take care.
Same to you. Same to you. Bye. So the next one, we have got the little break, and that's the end of my moderation block. And we have got the new moderator coming, Adina and Gaciu from Microsoft, and the new blocks of speakers. So I hope you enjoy your break. Thank you very much.
All right, what a great time together, and thank you all the speakers for the presentations, and thank you everyone who decided to attend the summit. And we wanted to say thank you also to our sponsors from InfluxData. So basically what they do, they have an awesome database, and definitely give it a try if you're working with some kind of time series data. If you worked with legacy databases, it's just a nightmare when developers have to spend their time managing the infrastructure instead of shipping the code. So InfluxDB, they have a leading time series platform built from ground up to work and handle with the big massive volumes of timestamp data from sensors, applications, and infrastructure. And what's really cool about them is that empowers the developers to build real-time IoT analytics and applications, and you can do it with ease. It's easy to scale, and it gives developers the time to focus on those things that are actually matter, on those features that ship they need to deliver, and not managing the infrastructure. So definitely give it a try. You can check it out today for free, and you need to visit influxdata.com/cloud. Thank you, InfluxData, for joining us. Thank you, InfluxData, for providing your tool.
Hello, everybody. Hello again. My name is Adina. You have seen my presentation before. Sometimes I'm a bit nervous, so feel free to ask me later. How was this day? Today I will broadcast from Craiova, Romania. You can Google it and see that it is a wonderful city. And you can see some great pictures from the Christmas market. Please make yourself comfortable because I have some great speakers lined up. I don't know if you have seen the info, but I'm pretty sure that you have heard of Deepa Subramanian. She works at Adobe. She will have a great presentation about the power of Node.js and progressive web applications, which this is another subject that I love. So I will be inviting Deepa to join the stream here. Hi, Deepa.
Hi, Adina. Good morning, good afternoon, good evening from whichever part of the world you're from. I'm excited. I'm all set, ready to go. And I'll also be moderating tomorrow. So don't be nervous. We are all in this together. So yeah, I have to, can I go ahead and share my screen? Is that okay?
Of course. Is everybody ready? If not,
if I get a thumbs up, I can start. It's 7:30 in the morning for me. So
good morning. I hope you drank your coffee, but you are really in a good positive vibe now.
No, not yet. So I do have it. I would have it definitely after this though.
Yeah.
Okay.
Make sure all of you that you will prepare some Q&A after the presentation. So
can you see my screen?
Preparing it now. Go ahead.
Cool. Hello. Today I would be talking about the power of two technologies, Node.js and progressive web app, like Adina said. And if I can click this. Okay. So my name is Deepa. I am a web enthusiast. I'm a speaker, content creator, blogger. Time to time, I write blogs. So I'm also the organizer for Google Developer Group San Jose and Women Tech Makers at Ambassador at Women Tech Makers. And here is a Linktree QR code that you can scan to get my handles. And every slide would have my LinkedIn at the top right. Okay, fun fact about me is I'm a avid coffee drinker too. So
today I have some assumptions to make because this is a junior talk and it's not a beginner level talk. So I expect you to know the following. So you should know how web works and how browser APIs interact, how to use Chrome Dev Tools. You should know JavaScript, basic and foundational JavaScript variables such as promises, async wait, and anything related to ES6. And also, if you have some knowledge on Node and Express, if you have built around it, it'll be very easy for you too. So that's something that I wanted to set the ground before. So today we'll start off with Node.js, and then we'll slowly move on to Progressive Web App. We'll talk a lot about Progressive Web App, and we will wrap it up with a couple of demos. Okay. So first off, what is Node.js, right? Node.js is, according to the Node official document, it's a JavaScript runtime built on Google's V8 engine. What does it mean, right? So just to make you understand, JavaScript, now you can use HTML, CSS, and JavaScript for the front end, so that you can place all your DOM elements, right? But can you do the same thing with the backend? Yes, you could. This is where V8 comes into play, and you can use JavaScript for both front end and backend when you use Node.js. So here is just to give you an overview of Node architecture. Node uses something called as a single thread event loop architecture, where it could handle multiple concurrent requests, right? So it is a processing model where it's based on JavaScript event-based model and callback mechanism. So here, as you can see, the events are going. Understand that the next slide would be much better if I show this. So first, there are multiple users accessing your website. The request goes through, and it goes through something called as an event queue, where all the requests are stacked. So it's stacked based on when the user wants to access what. So it's stacked based on one by one, and then it goes through one single thread inside the event loop. And there are two kind of operations that goes through inside of Node.js server. So one is the non-blocking IO polling, where it looks for the request, and if it's a simple one, it could return right away. But if it's a complex one, it goes through something called as a blocking operation, right? And it goes through something called as thread pool, where it has to go get the information either from an external database. These days, it's all in cloud. So it could be on the cloud, or you can get data from the database, file systems, or anything. It could be anything. So once it comes back, the requests are sent back to the user. Okay. So we talked about the architecture. This is the flow. How do we access this? First off, you have to install Node. And if you have done it before, you can go to the documentation. There's a lot of information about it as how to install. Once you install, you can open up in your terminal saying just typing in Node, right? And then here, if I type in global, as opposed to the browser, if you go to the browser and type global, you will get the window object. Here, you would get a global object, but if you see, it's very condensed than the one that you go and see it in the browser. So it also supports ES6. For example, if I do here, it supports const. So you can also use it completely supports ES6. So here I'm just using a variable name with const variable name Geekle, and then it outputs the event name. So now just just to give you overall features about Node, as I said, it's single-threaded, it's non-blocking, which means it's asynchronous and it's event-driven. And you can use JavaScript both on front end and back end. So also the NPM library, I think Node has over I think 2 million packages, and this has been Node.js has been there for over 10 years in the market. So this is the most common one that is used in the industry, and it's got a huge community support. So also understand that it's because it runs on V8 in Chrome's V8. There's a lot of iteration that they make, and it's faster in performance and it's scalable. When I also gave a talk about how to build fast and scalable websites using Node.js last time. If you want, you can go ahead and check that particular video. I presented it in Geekle as well. So when to use Node? So if you have an application that requires you to have a lot of queued IO inputs, and then you have real-time streaming. Netflix uses this. So you can also use it for chat box. If you are creating a complex single-page applications, then Node could be the right choice for you. However, when not to use Node.js, right? So when I say unstable API, it is something that because it changes frequently. Because of that, there's a lack of library support. So the people who create packages, they don't maintain it, or they don't upkeep with the current APIs. And there's the documentation may not be up to current. So that could also be an issue, right? And the best part is if you are a Node.js developer, you know how to use it. It is also expensive to hire people with such a high experience, right? And any heavy computational task, for example, image processing, these things would take time. So Node is not the right choice in that case. And because it follows asynchronous programming model, you have to understand that it comes with callback issues too, right? Okay. So here are some of the competitors for Node: .NET, Go, Ruby, Python, and I found this new thing called Bun. It's a new company that is also creating something very similar to Node. It runs on it's a runtime JavaScript environment too, but that's something that I found on the internet. So these are other companies that also are some of the competitors for Node. So in an ideal project, right? So how do you have it? So you would have a backend, a front end, and then you would have Node modules on each of them. And if you are a person, if you are using, this is also ideal for microservices. So where you can abstract at that level too. So you would have Node packages inside each of these. So just to give you a visual of that. So now we talked about Node.js. Let's move on to progressive web app. So before I start talking about progressive web app, I just wanted you to understand what does mobile development today look like, right? You have two platforms. One is Android, one is iOS, and each of them would have if you want to develop an app, you either need to know Java or Kotlin, and you also need to know Swift or Objective-C to create apps in iOS. So, and then you have frameworks such as React Native, Xamarin, Flutter. These could also be used for developing mobile application. You have so many devices around there in Android and in iOS. And this is one of the, if a mobile developer, they want to work, they can only work in one platform, and they have to make sure that it is available or it looks and feels the same exactly in different fragmented devices too. And last but not the least, if you are a mobile developer, you have to be submitting your apps in any one of these stores. So you have to pay for your developer account as well. So this is the state of mobile app development today, right? But what is progressive web app then, right? According to MDN, web apps developed using specific technologies and standard patterns to allow them to take advantage of both web and native app features. So this is what progressive web app is capable of. So in simpler words, you can build websites that deliver an experience as a native app. So what does that mean for us, right, as web developers? So now you do not have to pay for the stores. You're not at the mercy of getting certified from them. And imagine you do not have to pay for the developer account, for being for placing your apps in the store, and you have to also update them every frequently, right? That is not required here. And also, because you are doing this, imagine if you have a hot fix, you have to place another submission to one of these stores. But this is not needed when you are making your application as progressive web app. So now, who uses progressive web app? So as you can see, Starbucks, Twitter, Pinterest, Alibaba, these are the companies that but there are a lot more companies who uses PWA. So this is just a visual to give you what is the difference between a native and progressive web app. So on the first one, if you see, there's an address bar, where you can go to tinder.com. But then in the middle one is a native app where you do not see the address bar. And also, if you see the third one, it says, hey, you want to add Tinder to your home screen. It's basically creating a shortcut for you, right? Once you do this, okay, you can say this is exactly looking the same, right? But then once you add it to your screen, it is going to behave like your native app. So in this case, how do you structure you are already a web developer. You know how to create websites. So in that case, you have JavaScript files, and you have your HTML your index.html. There are a couple of files that you need to add to your project so that you can make them as a progressive web app. One is the app manifest, web app manifest, and the second one is the service worker. So let's see what are those, right? So at the heart of progressive web apps, these are the main four things that you need to have for any progressive web app. The heart of the progressive web app is service worker. And then you have the app manifest. And if you say that you are building a progressive web app, it should follow the secure protocol, and it should be responsive in design. For the sake of this talk, I am going to be discussing only about service workers and app manifest, because responsive design is in itself a huge topic, which is not the scope of the session. And also, if you have developed something with web already, you should be able to know how to create secure protocol as well. So just to begin with, app manifest, what is it? It's nothing but a simple JSON file. It would tell you how your browser should behave when it's installed. It exactly looks like very similar to package.json. On the right, if you see the picture, that tells a lot about this. So you can add what is your theme color, your background, what images should be placed, and how it should be placed as well. This is what your app manifest would contain. And now moving on to service workers, right? Before we start understanding service worker, let's start to understand this is the basic thing in web development. So whenever you're trying to build, you have HTML and CSS for where it interacts with DOM elements, and then you have your JavaScript running in a single thread. That's how the elements are rendered. This is how, in general, your websites work, right? So here what we do is we add a separate file. like I showed you before. It's a service worker, acts as a separate thread. It's nothing but a background process that does not have access to your DOM elements. Okay, it runs on the background, and even if your app is closed, it runs. It keeps how does it run? It keeps listening to some events. So it would listen for those event changes, and based on that, that's why I said that if you have to update your application, this particular thing is the service worker keeps running in your background. So that's one of the main reasons that it updates here when the user opens, when the user visits the application. After the update, it immediately, there's a background process already happening and it has already updated, but then when the user opens it, they can see it. So how do you what do you do with this service worker, right? Like I said, it's a hard. First, you need to register them. So there are some life cycle that service workers go through, which I would not be talking in detail in this session. I have a separate video for that, and I can pass that information at the end of the session. So first, you need to register service worker. For example, I'm saving navigator.serviceworker.register. So where it goes and looks for this particular file and then registers it. Once you register, if you go to your developer tools, it says that, hey, we have registered. And note that I also have a demo about this. So if you see here, it says that the state is activated and it is waiting. Actually, this particular app is not installed. That's why it's saying null. So it's but it's activated though. And if you go into developer console again in the applications tab, where you can go and see service worker, and here it says activated and running. So whenever you make changes, this comes up, and there is, like I said, there is a cycle that it goes through where it becomes from registered to install to activated to waiting. All there are different 4 stages of it, which, like I said, I'll share the resources for that. And what are the features of service worker? Because I said that this has to be background, running in the background. It is one of the main things that makes your application progressive web app. So it has background sync. It can load content in offline. You would not see that dinosaur that's showing up, hey, no internet connection, right? So it also allows push notification. Look, you have everything that any native app would have. So why do you use mobile apps? You use it for notification. You have constantly, you need to update it. Of course, you need to go to the store, but here you can have everything in the app does it for you. So that's one of the things. However, having said this, you have to check whether your browser supports it. So if you are building a web app and if you're trying to open it in a Chrome browser, somebody might use a Firefox one, somebody might use Safari. You have to check whether your service worker is compatible, right? So for example, here, for the most part, service worker is supported by almost all the browsers. However, not all APIs, web APIs are supported by are supported. For example, if you have to access file system access, there's only partial support. So not all the APIs are available. So if you're trying to do something, make sure that your browser supports it. There's a lot more APIs. I can share information as where to go, how to go find it at the end of the session. So now you have created your application, you have service worker, you have your app manifest. So how do you know that your website is progressive web app compatible, right? So you have a tool called as Lighthouse. It's a Chrome extension where it runs an audit of your page, and it checks for certain parameters, and then it says, oh yeah, it is your application is a progressive web app. So here, for example, it says here as installable, it's optimized, and it also checks for other stuff. And the good part about it is when you run this audit, it'll exactly tell you what is the error that you're making, and it'll show you, okay, you have to change the icons, or if you have to change the sizing, or this is not it'll exactly show you the error, and it'll take you where you have to it'll give you information where you have to go find the information and fix it. Okay. So now we talked a lot about progressive web app. Let's see what are the checklists that we need to go through, right? Your app should provide offline experience. It should be accessible to everybody. And you have to make sure that you can use the capabilities when and where it's available. So check for the support. The website is called caniuse.com. And then you have to make sure that it's also available through search, and it supports all input type. For example, it supports touch. And note that you don't have to create progressive web app just for mobile alone. You can also create desktop applications too. And if, for example, I can show you something here. If I can. Okay. So if I go to youtube.com, right? If you see here, if I can see, this is also a progressive web app. You can install this. So I can install it on my desktop, and I can make it work too. I don't have to wait for updates, but if it's needed, I can also do that. So most of the applications from Microsoft also does that, Outlook, Teams, etc. And yeah, I can also use input types such as keyboard, mouse, if I have it in my desktop as a desktop application. If it's a mobile application, it supports touch as well. So what are the benefits now? It is single code base, and it's cheaper and faster to build native apps. You do not have to learn a separate language for this, right? And the best part is you do not have to, the mobile storage. It doesn't take as much as mobile storage takes, and you do not have to download or update your application by going to the store and things like that. And now web developers have a choice to create native apps using progressive web app. So here's a small demo that I'm going to be playing. I had to record this because I was trying to show offline content here. So I can go ahead and play it.
Deepa, there is a moment we can't hear you. Everything that you are showing is fine, but we can't hear you at all.
Oh, okay. You cannot hear the. Okay, just give me a moment. Can you hear this video at all or no?
No, only like silence, completely silence.
Oh, okay. Let me then swap it. Just give me a minute. Just give me 1 minute. I'm so sorry. I'm using an external monitor. Let me try this from here. Hopefully this works. And okay, I'm going to be playing this one more time. I'm so sorry. Okay, it's in high quality.
Hey Deepa, do you need any help? I'm sorry, I maybe missed the beginning of your presentation.
I don't think so. I'm so sorry. Can everybody hear this video at all? Or I can just pass the link to it.
Well, yeah, there is an option to share a sound, but it's unfortunately doesn't work on Mac systems.
Oh,
so you need
okay.
to share. But if you, for example, will share a browser tab instead of the
Okay,
entire
I
screen,
will.
it will work then.
Okay, I would. Okay, let's play this. And then I can play this entire thing. Okay, let me play it in YouTube itself. I have it in YouTube. Because I had to record this in offline. So, sorry. Just give me a minute. Okay.
Hey, so do you want probably us to show this video? We can do.
Yes. Oh,
Yeah,
can
just
you do
provide
that?
us the
Is
link.
it
Yeah,
possible?
provide us the link and we'll show the video.
Okay, sure. Sounds good. Let me. Okay, sorry about that. It's. I shared it with you.
Yeah, just give
Yes.
just give us a few seconds. Yeah.
Okay, sounds good. Sorry about that. I had to do this because it requires offline info. So I recorded this. Let's get started with this. Here's an application that I created where you can see HTML index.html. There's a web manifest. There's also a couple of JavaScript files here. One shows whether the user is online or offline. The other one is it registers the service worker. And also inside the service worker, I have what are the things that needs to be cached. And it is when the user installs the application, it would create, it would listen to that event, and then it fetches the information from the cache, and then it also what it does, when it activates, it removes the old cache, and then this is what it listens to all these event listeners. So I also have a server.js where I have information about how to get those cached files, right? So let's go ahead and run this. And if I open this, it says online right now. So let's go and see what is in here, right? So we have a service worker, which is already activated and running. And if I go here and see, it's already registered. I hope we can see it. So it says that activated, and then see, it says activated, and then it shows a bunch of information about it. So also, if we run this audit here, right, it's going to show me, and I'm running this on mobile, so it shows online. And let's see if it passes the audit, and whether it says that, oh yeah, it is progressive web app compatible. So now it shows that yes, it is. It gives me a tick, and it checks for all these, whether it's installable, whether it was optimized, and what other additional stuff that needs to be that it has gone for the check, right? So now that we have this, we can try to simulate this, right? Simulate an offline situation. Let's clear this one off. And I'm going to be closing this and reloading this because we want to see if it has cached. See, it has cached a couple of files, status.js and index.html. So let's go ahead. I think we can do it from here itself. I'm going to go and turn off my Wi-Fi, and I'm going to run this one more time. Now it says offline, and let's go ahead and see if I run this audit, what happens, right? It shows offline here, and also whether if it's going to be passing the yeah, see, now it has passed for both online and offline. So this is how, it's a very small demo. This is how you need to make sure that your your application is progressive web app compatible. I think I'm done with this thing. So can I move to, can somebody give me access to my screen, or can I use it?
It was working before. Just share screen again, and
okay,
you can continue.
Yeah, sorry about that. I'll throw this thing. So I have to go very quickly. Sorry about this whole thing. Okay, cool. So we saw this has how to create these files. I just wanted to, can you see my screen, Nick?
No, you stopped sharing. So can you please start sharing again?
I thought I did. Okay, anyways. Can you see my screen?
Yeah.
Cool. So I did talk about, so okay, you have to create a couple of files, but is there an easy way out? Of course, you always have this, as we are in technology, so there should be an easy way to do this, right? So there's a boilerplate available. If you go to npm, there's a package for this too. So if you go to npm, I know you can go install this package using npm install create PWA. And there's also other ways to do it. There's something called as PWA builder templates, where if you're just getting started, there is something available for you. You can there's a starter package. Then you can see, if you're ready to start with progressive web app. And also note that if you're trying to convert your current website into a progressive web app, you have to do it in a very specific or step-by-step process. So probably before you do anything, I would say that try it out on your own. There are a lot more templates available, but I found this very if you can see my screen, I'm going to run a demo from their particular, this I picked it up from PWA Builder's starter pack. So it gives a template one here. It is a photo app editor. So where you can see I can go add a picture of mine, and note also I can go install this. But having said this, if I run an audit on this page, for example, this is one of the things that I wanted to show you as how it could also feel, right? Let's run. I tried this in a mobile before. So if I run this on a mobile, what happens? And if we run this quickly, okay, it is still going through. Okay, now you see there's a lot of things that it shows that, hey, you're missing something here. If you go here, it'll tell you what exactly to do. And for example, inside of your PWA audit, if you go and see, it says that, hey, you know, this is a progressive web app, but then, you know, this particular icon is not, it's not, you know, it's not good for your appearance. If you click onto this learn more link, it'll tell you exactly what you have to do. So that's something that I wanted to show here. And so far we talked about Node.js. We talked it's a backend with the V8 engine available in your Chrome itself, and then it is also it runs on single threaded, and it's an event-based one. It's fast and scalable. And regarding progressive web app, you have offline support. You can do notification. You can install it, and it's reliable also because you're using the power of web here. It's super easy as well to set it up too. It's not that hard. So if you are curious about what are your next steps, I have created a small project in my GitHub repo, which I will be sharing. This progressive web app supports notification. As you can see in the screenshot, the notifications are coming. However, if you run an audit on this, it'll show you a bunch of errors. So first thing, what you need to do is add the app manifest, right? And then run Lighthouse to see what are the things that you're making wrong. So you can go ahead and fix those. And for also, I have a in-depth video of more. I talked about service worker lifecycle and all in this video. If you go check out one of my videos. And if you're curious about it, I have a lot of information as understand that progressive web app comes under Project Fugu in Google Chrome's team, and it's a cross-company effect. Microsoft, Samsung, Intel, a lot of companies work together on this, and they based on that they support some of the APIs for certain browsers. So if you go ahead and check out, I've talked about few APIs also in this blog and how to get, I've started with what is Chromium, and then slowly I have built a series. So if you are a person who wants to read, that would be the right source as well. So apart from this, okay, I don't want to read all these things. I don't want to watch videos. I want to just learn how to do these things. Then I have code lab links that are provided here. You can go, first off, try to see how to progressively enhance your application, and then see how you can add notification. I gave an example, but there's also similar information in the code labs. You can also see how you can do badging on your application, how files can be handled, and a lot more. So the possibilities of learning this is very, it's limitless. So with that said, my name is Deepa. Here is my QR code for my link tree. You have handles for all the resources that I shared. And thank you so much, Geekle. Thank you, Nick, Anna, and Adina for having me here today. And it was a pleasure to be here. Here are my references. And if you have any questions, please let me know. I'm going to stop sharing my screen. I can't hear you.
Okay.
Oh, now I can. Yeah.
Thank you, Deepa, for your awesome presentation. It was very insightful. Don't think more about those mishaps. We have a saying here in Romania, who does not work does not make mistakes. So we can all see that everyone worked on their presentation. So mishaps and misspelling might happen. Thank you again. Don't forget, we have Q&A in the chat. You can remain and see afterwards.
I can share this. I can share the presentation link, maybe after in the Slack, or if you want it right now, I can also do that.
You can answer what for this one. How hungry are the service workers in terms of mobile resources like battery life?
That's one of the main things. I did not say the cons of it. Like I said, because it does a lot of background sync, and yes, the battery is a concern. One, and there is one more API that is available that's called screen backup as well. That sucks up your battery too. So yes, it happens. It does, because it's constantly syncing. It is looking for events. Yes, your battery life is going to be, but I don't think it's going to, most of the mobile apps also does the background sync if you keep the app open, right? But this one is, yes, that's a concern. That's something that it's not optimized so far, so yet.
Cool.
And I also have a video on the progressive web app that I was talking about, how to have the same thing, how to see which APIs work on your Android device. I have certain information about it in the resources that I shared. So if people want to go look at it, they'll get a better idea about this.
Okay. I don't see other questions. Not
On
in
the
CPU,
CPU, I don't think it is going to, because yes, the battery is a concern. However, the storage is a win for you, right? That's something that you can see it as a pro. And I can share the link here if I may.
Yes, please do. Please share it in the
Yes, I
in the
already
chat.
shared it. So this is there, and please go ahead and revisit that video. I know that we had some technical issues around that, but if you go ahead, it took me some time to get that thing right. So please, that's why I wanted, because if I go offline, I would not be able to show that particular scenario. But you can go ahead and see this in the slides too, and it points out to the link as well.
Okay, I'll add it to the chat. So,
okay.
Thank you again. Please feel free to tune in the chat from our main platform. Everyone, if you have more questions, Deepa will answer them.
Yep. Thank you so much for your time. And you have a great day, a great Wednesday, wherever you are in the world. And thank you, Geekle, for having me here. It's a pleasure. Hey, also next month, I'm talking a very similar topic, Angular and PWA. If you want to come and listen to it, that'll be great too. Thank you. Have a wonderful day. Bye.
Bye. Okay. So we are preparing the stage for another awesome presentation. Please remind it that it is recorded. It is held by Rob Richardson, who is a developer advocate at shoreline.io. It's a topic that I think we all had in mind about testing. So we need to gain some confidence with Cypress tests. So without further ado, here's the presentation from Rob.
Hi, welcome to Geekle Summit for Node. Today we're going to talk about gaining confidence with Cypress tests. We're going to start by building up some tests and level up through Cypress to be able to do some really amazing things. Here's the part where I tell you I am definitely going to post the slides on my site tonight. Have you ever chased a speaker in that way? Let's head over to robrich.org, where we'll see that the slides are online right now. robrich.org, I'll click on presentations here at the top, and here is Gaining Confidence with Cypress Tests The slides and the code are online for this event right now. And that's pretty cool. Here's the code that we're going to take a look at. And so you can clone this and replicate all of the examples that we're going to do today. While we're here on robrich.org, let's click on About Me and we'll see some of the things that I've done recently. I'm a Shoreline developer advocate. Docker and Microsoft have both given me some awards, and I'm also a friend of Redgate. AZ Give Camp is really fun. AZ Give Camp brings volunteer developers together with charities to build free software. We start building software Friday after work. Sunday afternoon, we deliver completed software to charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ Give Camp. Or if you'd like a Give Camp closer to you, hit me up on Google, on Twitter or email, or find me here at the event, and let's get a Give Camp in your neighborhood too. Some of the other things that I've done, I worked on the Gulp project as a core contributor in version 2 and version 3. And one of the things I'm particularly proud of, I replied to a .NET Rocks podcast episode. They read my comments on the air and they sent me a mug. Woo! So there's my claim to fame. So let's talk about Cypress. We talked about this guy. Now, I'm not quite sure if this talk's going to go over okay, so let's fire this up and see if our site is going to work. Yep, we're loading up our tests. Looks like we're doing the TypeScript build, starting to flex our application, and yep, it looks like this is going to work out well. I'm excited. We've got a website that, in this case, we don't control, but we're able to validate that it works exactly the way that we expect. So that was really cool. We got to do some browser-based functional tests, and that's really what Cypress is being able to simulate users and do tests the way users would within a browser. Or using Cypress terminology, we've got end-to-end tests. It's an Electron app together with a browser plugin. It's built on top of Mocha and Chai, so if you've used Mocha and Chai or maybe Jest or Jasmine, you'll feel right at home here in Cypress. Well, like many good stories, we've started in the middle. Let's back up a little bit and start at the beginning. We want to do browser-based testing. Now, what types of tests might we do with a browser app? Well, we probably want to do unit tests. We want to test this particular function and validate that given these inputs, it yields these outputs. We might want to test a component, so we'll need to mount our component. Maybe we need to mock out the child components, or maybe we'll render them. We want to validate that it renders correctly. We might want to test a service. So we'll fire requests, maybe at a JSON service, a REST service, or maybe a GraphQL or a gRPC service, and just validate that we get the responses we want. And the cool part is, in those tests, we don't need a browser. And we might want to test that all of these unit and functional tests work in this particular browser. So let's launch our unit tests, but launch them inside of a browser, not just an artificial DOM inside of Node. And we might want to test end-to-end, so validating that our service works in the way that users expect. Let's click on buttons and do the various things. Now, what tools might we use? Well, with each of these types of tests, we might use different types of tools. With unit tests, we'll probably use Mocha with Chai or Jest. With testing these unit tests in a particular browser, we'll use Karma as our test runner. Karma will inject our unit tests into a browser and validate that they still render correctly. Component tests. We can use test utils, and there's an addition for each of our SPA frameworks where we can mount our components, optionally choose to render or mock the child components, and validate that our components work correctly in isolation. When we're doing API tests, we might use Supertest, maybe Axios, and now we can validate that our API works as expected. We don't need a browser for these types of tests. And then end-to-end tests, we might use Selenium, Cypress, or others. As you grab these slides from robrich.org, you can click on any of these blue links to learn more about that particular package. So let's double click into our end-to-end tests. Selenium is the big dog here, and it definitely defined the space. It's a Java app, and so we can fire requests at it, and it will remote control our browser. It uses WebDriver, which is kind of a de facto standard now in browsers. You won't find it in IE, but you'll find it in pretty much every other browser. So you can use Selenium tests to be able to run applications and click on things, but the downside is they're a bit fragile. It's kind of hands-off. It's just kind of pushing browser events and screen scraping. So if our API takes longer than expected, then, well, we could increase the timeouts in all of our tests. Now our tests are slow. Or we could just try rerunning them and see if the API responds faster this time, in which case our tests are flaky. Not a great solution for our unit tests. Selenium definitely defined this space, and if you're successful with Selenium, then definitely lean in there. But let's explore some other options as well. Cypress is great because it has this browser plugin and Electron IDE that allows us to deeply integrate into the browser. That means that we don't need to wait for things. We just say, wait for the DOM event. And once the DOM event is done, continue on. Our tests run a lot faster. It has a jQuery-like syntax, which is a little bit odd, but it gets it done. But it only is supported for those browsers that have a browser plugin. So no IE support. Safari support is, well, coming. But for WebKit-based browsers, for Firefox, we're right there. Next up, Test Cafe. If you use DevExpress for other things, Test Cafe might be a great fit. Now, unlike the jQuery-like syntax of Cypress, it uses CSS selector syntax, which may make it a little bit more native. The assertion syntax is a little weird, though. You'll end up marshalling things back and forth between the browser context and the test context, and that might get in the way, too. Playwright is made by the people who made Puppeteer, and Playwright makes you feel right at home if you've ever used Puppeteer to automate Chrome or other browsers. You can use Puppeteer with lots of different languages, and so you can use Playwright with lots of languages as well. Now, the assertion syntax is not based on Mocha with Chai or Jasmine, so it does feel a little weird. You also spend a lot of time marshalling content between them. Now, with each of these tools, find the one that makes you happy and definitely lean in there. If you're finding a lot of success with your tool, then you don't need to rewrite all of your tests in a different tool just to be able to get, well, resume-driven development. So ultimately, I invite you to choose the tools that make you happy. I don't have an opinion there. But for this particular talk, we'll lean into Cypress. Cypress is quite popular in the testing community. It's a great way to automate browsers without the lag that you might find with Selenium or other test frameworks. So how do we get started with Cypress? Well, to get started, we'll just npm install Cypress, and then we can say npx cypress open. Now that will open up the Cypress IDE, that Electron app, and it'll also scaffold out a bunch of tests in JavaScript. So now you can get a good start with Cypress. All of the tests go against their kitchen sink website, so you can kind of explore them and understand the various capabilities and features of Cypress. So let's get started with that IDE. I've done npx cypress open, and here's our IDE. We can pick the various browsers that we want to run against. It will detect the browsers on your machine, and in this case, I'll choose Chrome. Here's all of the tests that it scaffolded out for us, and in this case, I'm doing it in TypeScript, so they are TypeScript tests. Now, we won't use those tests. We'll use these tests here. So let's open up a test and launch it. Now, the cool part about it is it runs inside of a real browser, in this case, Chrome. But it's not the Chrome that I have all of my IDE plugins and profiles and saved form data in. It's a new browser that allows us to do interesting things. And we can switch back over to our other browser, and our tests will continue to run. So we don't need a dedicated machine. We don't need to walk away while the tests are running. We can just let them go. Now, with each test, we can dig into the steps that it's going to do. And so you can see the various steps and learn about how it works on that machine. And as well, let's open up the Chrome developer tools. With each step, we can see the various details that Cypress has identified within the web page. So if you're having difficulty with a test, you can dig straight in and take a look at it. Now, let's take a look at this test. We can, well, let's add a to-do. We'll go add a to-do, and then we can take a look at it. So because we're just running inside of Chrome, we could switch over to our sources view, and we could go find that particular test, set a breakpoint, just push F5, and now we can step through our test much like we would inside of Visual Studio, VS Code, or any IDE. So we've got our test, and one of the interesting things that it will do is it will actually show us the button that got clicked. So let's, here's one. We're going to click a new to-do, and we'll complete that to-do. Let me close this. And we can see that there's the active button that it found, and it clicked it. We can see the red dot. That's where it actually did the click. We can see both before and after it did the click and see the content that the task that it accomplished. Here in our IDE as well, we can rerun all the tests. We see how many succeeded and failed, and then we have a nice selector playground. So let's assume that I want to grab this paragraph right here. Here's the sci.get command that I might want to grab to be able to get that. Now we'll talk about naming conventions and why this may not be the best way to select it, but it's great that we have that right there. So we've been able to run our test and take a look at it. Let's next take a look at the details of how we built up the code to make this happen. Now we can definitely write tests in either JavaScript or TypeScript. I've chosen TypeScript just because it's a little bit more intense, so we'll be able to see some interesting details. The code is up on GitHub right now, so you can clone this repository and replicate the results. I've opened this up in VS Code, and let's start with Cypress.json. Cypress.json tells us the plugins file, and that basically gets us started with everything we need to do. Let's flip over to the plugins index, and this is the rest of the configuration for Cypress. Starting in Cypress 10, these two files are combined, but I haven't upgraded yet because they've removed the run all button in Cypress 10. So yeah, we've got our fixtures folder, our integration folder, which is where our tests are, our support file, we'll come back to that one, and also our results, both screenshots and videos. Now it's going to record a video with each test run, and so you can easily debug the test by opening the video and just watching it do what it does. I've chosen to move both of these to the results folder so that I can exclude the results folder from my gitignore file and not accidentally check in these files. Now this is a TypeScript project, so here's my tsconfig for this project, and it specifies all of the details of how I run my application. There's no Cypress content here. But inside my Cypress folder, I also have a tsconfig that specifies the details for this particular Cypress app. Now in this case, I'm extending from the main thing, so I don't need to overwrite anything else, and I'll just add the specific details that Cypress needs to be able to run my app. Now this is perfect. I don't have a completely different tsconfig. I only have the differences from this original tsconfig. Now here in my package.json, I specified various scripts that I run. We could run Cypress open like we did previously, or we could do Cypress run, which is more the DevOps mechanism, the CI/CD command. Now I've chosen to run headless, and I can specify the various browsers. So in this case, I have a Chrome, a Firefox, and an Edge one. And for npm test, I'll just run Chrome tests and Firefox tests and Edge tests. I could choose to run them in parallel if I wanted, just with a single end. And so now in my CI/CD system, I can just say I would like to do a npm install and npm test, and that will run all of my Cypress tests in headless mode, validating that all of my services work in a real browser. Now you may tune these tests, these scripts to be whatever you'd like, but I kind of like that these are headless and I can run each one, and then npm test runs them all. So now let's take a look at some tests that we've got. I chose to put my tests inside the test/Cypress folder, but here in the configuration, you could choose to put them anywhere. But my tests are inside this integration folder, so let's open that up and let's take a look at this to-do MVC test. Now I want to test this to-do MVC site. This to-do MVC site is a little bit dated, but the premise of this is that we'll have various tests, various applications built in various SPA frameworks so that we can validate that they work as expected. Given a standard HTML and CSS file, just build the JavaScript to make the test run in all of the places. So here in my test, we can choose to run it in AngularJS, Backbone, Vue, or anything. In this case, I'll run them in AngularJS. So I'm just going to grab the site name so that my test description is valuable. And then before each, I'm going to go visit that site URL. Now that means by the time the test actually loads, that page is already ready to go, and we don't need to repeat this. But if we wanted to, we could just put this at the top of each test, and that would be just fine as well. Now I have my first test, cy.url should equal site URL. We can see that kind of jQuery syntax. All else being equal, I would rather it be should dot equal open. And that's kind of the way both Mocha and Jest run, but that's not the way that Cypress runs. Yeah, that's a magic string. The jQuery nature of this. But you notice that there's no awaits, there's no timeouts. Once this visit finishes, we know the page is ready to go. So I love this test because it just validates that we're testing the page that we wanted to. When I first built this talk, the sites were HTTP, not HTTPS. And so this test was able to really quickly identify that I wasn't testing what I expected. If you've reformatted your website, rearranged the pages, then it's nice to know that you're testing the page that you actually think you're testing. And thus, this is a great starter test. We can see, though, how we can start to interact with the page using CY to be able to get at the resources. So let's go check some content. Now we're starting to interact with the page. Let's do this jQuery-like selection, and it should not exist. That means that we haven't created any to-do items yet, so our to-do item list is empty. We can see the arrange, act, assert pattern that is great for all kinds of tests, where we set up the conditions that we want to test, then we do the action that we want to do, and then we validate the conditions that match what we expect. So in this case, here's our new to-do that we want to write. We'll write a Cypress test. So let's go get that new to-do box. We'll type in that new to-do, and we'll press enter. Now notice that this one isn't a $sign. It isn't a variable. It's actually the enter key. We use those two curly braces where we can type enter key, shift key, any function keys, anything that is unusual, we can type using this syntax. So let's go find that new to-do box. We'll type it and we'll push enter. Now it's going to do all of the JavaScript events that need to happen there. So we're not awaiting, we're not timing out, and now we can go get that to-do list, and it should contain that text. Now we could definitely dig in more deeply with that to-do item, and we will in a moment, but in this case, we're just validating that that to-do was created correctly. Let's go grab our new to-do box and validate that it is now blank, because as part of creating that to-do, we should also clear out the text box. That's a great starter test. We typed some content and we validated that the site behaved the way we expected. Let's upgrade again. Now let's mark a to-do as completed. So let's type in a relevant to-do just so that we make sure that the to-do that we want to accomplish is the one that we're completing. Let's type another to-do, this finish Cypress test. And then let's go find our view. We'll filter it based on it contains this text. And let's go find the children, the toggle button, and we'll click it. Now that's cool. That's what marks it as complete. So now let's go validate that it should have this class of completed. We've accomplished that task, and we can see that it now has that strike through CSS class on it. Let's level up again and go delete a to-do. We'll create an irrelevant to-do just to make sure that we delete the correct one. Then we'll type our new to-do, and we'll go find that to-do item, filtering to that new to-do text, and we'll go find the destroy button. Now, in this case, the destroy button doesn't show up unless we mouse over it. Now, we're not doing mouse events. We're running JavaScript functions, so we don't get the benefit of those CSS show and hide, hover type of experiences. So in this case, we're saying force is true. We're saying force is true because I want to click a button that is not currently visible. In this case, the button only shows up on hover, so we'll force it to be able to click it. But now let's go find the visible items, and we should only have one. And the one that is visible should be our relevant to-do, not the one that we just completed or just deleted. So now let's filter by show active tasks. Now previously we've been doing this .new to do type something, which is okay, but it kind of obscures the task that we're trying to accomplish. Instead, let's create a new action, sci.toDoAdd. Now I invented that. That's the task that I wanted to call it. If you've ever used page index inside of Selenium, you'll feel right at home here. So let's open up our support and take a look at the commands that we can build. Now I have this toDoAdd command. It takes in a string. It'll type that into that text box. And while we're here, let's just validate that it completes it as well, or that the new to-do box is empty. So now we've invented this command. Now that's perfect. In JavaScript, we would be done. But in TypeScript, we need to tell it what this toDoAdd command is. So let's head over to the Cypress docs and take a look at what we need to do. Well, here's the details of configuring our tsconfig. And now as we build custom commands, we also need to give it this TypeScript declaration file that explains the tasks that we're going to do. Here's our TypeScript declaration file right here. And it says that we've got this toDoAdd command that takes in a string and returns this chainable element in case we wanted to add additional commands to this. So now we can describe the business logic that's happening here. Let's add 3 to-dos. Let's complete a to-do by clicking that complete box. Here's that command that we did there. Oh, not there. Here. So we'll go find that complete button and we'll click it. So now we have tests that are much more descriptive of our business logic. If you've ever used page objects in Selenium, you'll feel right at home here. We can now have a test that focuses less on the technical implementation and more on the business logic that we want to accomplish. We now have documentation of our site within our tests. Let's do that again for showing our completed tasks. We'll create 3 to-dos, we'll complete one. Let's go find the A button that says completed. Now, in this case, we don't have control over that website because, well, it's just an external website created by someone else, but we really want to take more control over our things so that if ever we renamed our CSS classes or if ever we created a different path for this, this is a really fragile path that may not exist in our future site. Instead, let's create a data-cy attribute on that particular element. And now we can do a sci.get data-cy equals completed and click it straight away. That would be a much more durable markup so that we can now know that we're clicking on a specific item within our test. It's also a really nice clue about what types of things are happening behind the scenes. If I'm refactoring a particular portion of my website and I bump into a data-cy attribute in my changes, I know I'll probably need to adjust a unit test too. Now, this begs the question, are we now leaking testing details into production? Well, yes, we are. And I would argue that's a good thing. We could run a subset of our tests in production to validate that our website still works. Let's go to our home page. Let's click on our product catalog. Let's add something to the shopping cart, go to the checkout screen. Now, we won't go all the way through to a payment screen. We don't want to charge ourselves money every time we run a unit test. We could run that test every hour or so, every few minutes, to validate that our shopping experience, those critical paths, still work in production. Yes, we're putting our testing details into production, but we're doing so that we can learn whether our site is running or not before our customers call and complain or just move to our competitor. Next, let's clear a completed task. We're using these great commands that we've built so that we can just create a to-do, complete it. Let's go get that clear completed button and click it. And now we shouldn't have any to-dos that are visible because we cleared the completed task. Perfect. So we started with a basic test and we were able to level up through interacting with our page, typing text in text boxes, clicking on buttons on the screen, and we're able to validate each of the pieces of our website. This is perfect. Next, let's level up to starting to interact with network requests. So the To-Do MVC website was great at being able to experiment with each of these types of SPA frameworks, and a spiritual successor to that is Hacker News PWA, where we create these Hacker News readers. Now, the cool part about this is that similar to To-Do MVC, there's one for various frameworks, Preact, React, Svelte, and Vue, and we can kind of get a feel for how this works in interesting places. Now, I definitely want to be able to render this correctly, so I want to validate that my components work the way I expect, but I don't know what news is happening on Hacker News at any particular moment. So I may want to mock out the web requests so I can take more control over them. So let's pop over to that test. Here's our Hacker News tests. And so we could run them in various scenarios. In this case, I'll run it the modern Angular way. So let's grab that, and we'll do our Hello World test, validating that we're running the correct site. That is excellent. And now I want to validate that my component renders correctly. So as my component renders, I don't know what today's top story is going to be. So I want to intercept this web request. In this case, I'm using regex, but we could definitely run strings as well. I'm going to intercept that. I'll set my CORS headers, and I want to provide a fixture instead. Fixtures are great for both being able to take out the details, maybe here's some user details or a particular profile. I can move that content into a fixture so that I don't need to add this detail into the body of my test. That makes my test much more terse. So in this case, I have a fake Hacker News response. Now I know that the title of this request is going to be this specific value. So now in my test, I can take a look at that and validate that the first element should contain that title, this specific title. Now that's great for being able to validate that my components render exactly the way I expect. Is this data visible? Is it nested in the correct way? Does it have the right CSS classes? These are tests that we can write by mocking out network requests. Now, it would be really easy for us to assume that the network is always going to respond that way, but that isn't necessarily the case. So we don't want to mock out every request. So this next test actually runs the native request and validates that it renders this content. Now, I don't know what the news stories are, but I know that it's going to return 30 news stories. So I'll just validate that I have 30 items in my list. Now, depending on the speed of the API, we could specifically identify this, name it, and then specifically side.wait for that story. You'll notice this is the only wait in the entire code base. But in this case, this API responds fast enough, and so we don't need to. So this was great. Let's go run these tests, our Hacker News PWA tests, and validate that this site works as expected. Now we'll choose to intercept some web requests, but choose to also use the real API for other web requests. So we don't lie to ourselves, presuming that our network will always reply the way we expect. So it looks like this site works as expected as well, and we can still dig into each of the tests to see how that works. And in particular, we can see here that we canceled the actual request in favor of our actual API. So we can see that, yep, here's our stories, and we can validate that that news story is as expected. There's the news story that we wanted, and it contains that title. So we got to see a lot with Cypress and how Cypress can be a great tool for being able to validate the websites, either in development or even in production. We saw how it was really elegant to be able to create specific selectors. Now, when we used the selector tool, it gave us an XPath down to that selector, and that's fragile. If we reorder the items in our site or we embed something in another div, then that XPath will break. It's better to use IDs or classes, or even better still, create a data-cy attribute on our element and then select that thing. That naturally creates the link to documentation, so we can say, hey, if you're going to modify code that includes a data-cy attribute, you may need to adjust the test. But in most cases, because we're specifically selecting that element, then maybe the test will be just fine if we visually alter it, but don't alter the behavior of that element. Another best practice, we want to create commands for frequently used things. In our case, we created a command to create a new to-do and another command to push the done button. Now that's great because now our tests are starting to describe the business logic of this application and not necessarily just focusing on all of the technical implementation. As you grab these slides from robrich.org, head over to the Cypress docs to learn how to do that. Another best practice, don't log in at the beginning of every test. We do want to test our login experience, but we don't need to test it at the beginning of every test. That will make our test slow. Instead, hit a specific API to grab the tokens that we'll use for the rest of the test, or the first test could be to log in so that we can use that token everywhere else. Now that'll allow the rest of the tests to focus on the things that they're starting to evaluate so that we don't need to, for example, run our login flow every time. Another best practice, use fixtures. If we have a bunch of JSON, maybe a username and password, or maybe the title, the story details, let's move those to fixtures so that we can focus less on all of the content within our tests and make our tests more terse and legible. And in particular, we used a fixture to be able to respond to a network request so that we could take more control over that network request and validate that our control rendered correctly. You don't want to mock out every request, but mock out those requests where you're trying to validate specific content renders. And then run another test, maybe just to verify that the shape of the data return from the actual API matches the shape of the data in the fixture. Cypress. Cypress is a great way to do end-to-end tests on your website, much like users would. Now, it's not the only type of test that you'll want in your suite. You'll also want unit tests, component tests, API tests, and perhaps running those tests in a particular browser with Karma. But Cypress can be a great tool to be able to do end-to-end tests to simulate the way users run this experience as well. This has been a lot of fun being able to share with you Cypress at this Geekle event. Find me here at the event, and I'll join you in that spot where the conference is designated for live Q&A. If you're watching this on demand, find me on Twitter at rob_rich, or find the contact page on robrich.
Okay, and that was our recorded presentation from Rob Richardson. I hope you all enjoyed this presentation, and I hope you are excited for our next one. It's the last of the day. It's by Rasmus Bay. He's a freelance consultant that has helped a variety of companies with software development. He has also been present as a speaker at different conferences these past few years. And he's going to show us how to make our really amazing Clyde tool with Node.js. So stay tuned. It's our last. Prepare your Q&As because Rasmus will be here with us to answer it at the end of the presentation. So without further ado, let's give it to Rasmus.
My name is Rasmus and I am the next speaker. I've been looking so much forward to speaking here today and to go into the amazing topic that is tools, command line interface tools. So tools that can make our lives so much easier as developers. If you're completely new to this topic, you've probably seen them in the wild when you're using various technologies. Various technologies have command line tools that makes it easier to do a variety of things. But I've been looking forward to it today, and I hope that you've had an amazing event so far. So, without further ado, let's look at the agenda. So the agenda is that first we'll start off with an introduction. What are CLI tools? Just to get everybody up to speed with what it is, so that everyone from developers to project managers to junior developers to everyone is on the same page of what we're talking about today and what their role is. Next, we'll look into why Node.js and JavaScript is like
a good foundation for building those tools. Of all the things that we could have chosen, why that? Next, we'll go into Commander and Enquirer.js. What are their place in building these CLI tools? Why do we use them? And what are their purposes? Because both Commander.js and Enquirer.js have different purposes when we're building, especially when we're building out the CLI tools have limited UI, but there is some UI, UX in building these. And what are the different things that we can bring in to our application that can either make it like more customized for each say type of user. That'll become clearer in a few minutes. A demonstration of how we use Commander.js and Enquirer.js, as well as also looking at the entire structure. And there are many ways that you can structure an application such as this, but we'll just look at like a little bit of a simple flow. We'll go quickly into publishing, how you publish, NPM packages, and then getting into how you share, how you get feedback, how you get this tool into the user's hands, and how you do that also determines the success of the project. Because if you just throw something out to the users, doesn't mean that it will get adopted, even though it's the most amazing tool in the world. You need to have a great plan or great steps in order to get this to be a huge success. Because the worst thing would be that if you create a tool that at the end of the day, no one but you at the company use it. So get a lot of people to use it on a daily basis. That will make the return on investment so much bigger. Then we'll finish off with a conclusion and then finish the whole talk, and then we'll have a Q&A. So the first thing, introduction. So the theme of CLI tools are that they save you time. There are a lot of workflows in a company that you have that are repetitive. They're not like the ones that you want to spend the most time on. It's not necessarily bringing a whole lot of value going step by step through these tedious processes. So actually building tools that can help you with that process is a net benefit for the company as well as you as the developer. So the tool that we're talking about, given the name, lives in the command line. So you pull up the command line, then you can type, like one-liners commands into the prompt. And these tools, depending on the arguments, depending on what kind of input, you can make it do stuff. And it becomes then super quick to via like a text-based interface, just get a lot of stuff done really quickly. This can make like complex, repetitive tasks really easy to do quickly, so that you can focus on like the more fun, maybe more pressing tasks that that you need to do in your job. So that leaves you to maybe do like the more creative task, because there's not a lot of creativity in doing very mundane, repetitive tasks all the time. So the more you can automate to a reasonable degree, leaves you with more fun at the end of the day in your job. And who doesn't want more fun in their job? So the baseline, as I said, powerful. They like simple input. You can like accomplish a lot with very few steps, with very little input from you as the user. And also important, reducing error, automating repetitive tasks, and so on. Increasing like the overall like also quality as a like parameter of like delivery for the overall organization. You want to deliver quality over quantity, but if that can be speeded up and be also better quantity and quality at the same time, why not take those low-hanging fruits if they are there? That being said, there are many things that don't necessarily need to be automated. Like if you can do a task manually and it doesn't take a lot of time, and you hardly ever do it, and no one in your organization does it either. So if it's those things that like you only come across it like not like every like it can also be that every time you come across it's a big thing, like end of the month report, it just takes a long time to do and it's very tedious. That can also be a good use case, but it's also all about gauging where your time is best spent. And if something that takes like a few minutes and you have to spend hours and hours on automating and testing the code and make sure it works, and like if you deliver that tool to other people, does it work like there too? And it's like making sure that you actually spend your time right is a really important as a developer, because your time is valuable, and things that are valuable also need your time. So if it's a valuable thing that you're about to do, then go do it, but don't just automate for the sake of automating. Sometimes it will send you down a rabbit hole and you spend hours and hours of something that has very low value at the end of the day. So this will be a thing that I'll continue to say a couple of times during the talk, because it's super important. Because time is of the essence in many jobs, in almost all jobs. You get paid to deliver value. So therefore, also making sure that you spend your time on important things is super important. And the reason why I'm also saying is because it's fun to automate things. So you can start off with good intentions and then end up just consuming time. So before we've even written a line of code, we need to actually get into the mindset that we're actually building an app. We have end users for the app, and just as if you were building an app yourself for a market, you would try to gauge the market, like who are my end customers, who are like, how are they, what problems do they have, how would they use the tool, how would like. It's no different than building mobile apps or web apps. Your customers or your consumers, your users in this case, they're different. But just as much as you would think about the other people's concerns, you also need to think about this for a command line tool. Because if the better you know your customers, like who they are, how technical they are, what's their workflow, and what's the issues, the better you can customize a solution that they will actually use. So for example, if they are very technical and they just use it, they just want to have the tool so they can give a one-liner and they don't need much like input from you, then maybe you'll lean more on like giving like flags and stuff like that with Commander.js. But if they're like semi-technical or they want to walk through the process, that calls more for like more advanced input with Inquirer. And these are different user experiences. And it's the same when you're building web apps. Are these technically sophisticated users that I'm working with, or are they not technically sophisticated? And that will change how you do the design. And even though the design, like the boundaries of design that we're working with in the command line are very limited, there's still some there, and how you design them and how you lay it out is very important when you don't have a lot of kind of say space and features to work with. And also thinking about adoption, thinking about, like, just as when you're building an MVP for the product, you're probably looking speaking with the people that are going to have it in the hands when you're done with it. So the people in your organization, talk with them as you're building it, or even before you're building it. So when you actually close and stuff like that, when you're iterating, they're excited for the thing you're building, and that will promote greater adoption than you otherwise would have if you just kept it a secret project. Other things can be done, but we'll talk about, like, we'll go through them later on in the talk. A lot of ideas can be put out when we talk about command line tools. It can be about managing your infrastructure, like typical DevOps tasks. We can be monitoring and restarting and generating reports, which we're also going to do in this talk. But just managing through the command line and doing it very efficiently is kind of like a good place for command line tools. Also scaffolding projects, scaffolding different kinds of things, and doing it to your liking and stuff like that. Next, we have why JavaScript? Why Node? Apart from the obvious that we're like currently at a Node.js conference, Node.js is extremely popular. It's extremely well suited. A lot of people know it. A lot of tech teams already have it in some capacity, like very widespread in backend as well as front end. Probably the other way around, very widespread in front end as well as backend. And that makes making a tool for the command line so much easier, because you don't have to go with Rust or any other thing that will maybe speed up performance or whatever. Like, Node.js is completely sophisticated enough to make these experiences. So adopting that in your team is so much easier when you don't have to just say, in order to build productivity, we actually need to learn a completely different language. And when you have done that, then we can move on. Actually, just going straight in and delivering value from day one is not unimportant. Also, it's extremely versatile. There are just libraries for just about anything in Node.js, which makes it super versatile in order, when you look at the different use cases that you can have as a developer, like what kind of things would you be automating, what kind of libraries would you be integrating, which makes, as I said, versatile, but also these plethora of libraries make it so quick to get something up and running that is production ready very fast. So clear, very good things for Node.js. Then we go into Commander.js. This library is a library that makes it very manageable to get inputs from the user via flags, just as we've seen in many command line tools. Getting user input via flag, providing just a simple flag and then the input, this is kind of the library in order to do that. So that is the role in this. It's if you want like the typical one-liner, you provide the argument, you run it, and then you get done. Then you do what you need to do. You will not be walked through a process. So very simple in order for you as the developer to focus on the thing that you need, which is to focus on the logic instead of like trying to get it in the inputs. Which we also see here. We provide certain inputs, certain flags, like help version, for example here help. We program out the help, and then if option help is there. And this is kind of the structure that we're working with when we're using Commander. Inquirer is a different story, as we've also talked about. Inquirer is the kind of library that you use if you want to kind of make the user go through a journey with you. You want to ask them your name, the user inputs the name, goes through to the next question. Type in this example that we're going to look at later, we're going to see like email. Then you type in the email, stuff like that. That's what Inquirer is used for. And nothing is better than the other, but as we talked about, like it's about using the tools in your tool belt the best that you can do. So as we talked about Inquirer, getting the inputs via like the prompts, and the prompts are going to look something like this. Like you're going to define like what type of prompt it is. Like this is an input prompt. We ask what is your name, and then we return the name. Fairly simple compared to what, like it's fairly straightforward, like no caveats, no nothing. It's a simple, straightforward approach, and we're going to see different types of input that we can use. So now we come to the demonstration, how to handle input and output using Commander and Inquirer.js. So we're going to look at different types, like input, confirm, list. These are the typical ones that you go through. If you've downloaded anything, you typically, like, you've gone through like, do you want to do this? Yes, no, stuff like that. And we're going to look at that. So demo time before we go through over to the publishing. So here I have prepared some code. So we have like just a basic structure, and we have some things that we need to fill out, but I provided like kind of like the structure. We have some functions. There are some functions that we're not going to go into. This is a command line tool for generating like a report, doing some CSV, but we're not going to go into the specific like files for generating PDFs and CSVs and stuff like that. We're just going to go through like the overall structure. So the first thing that we're going to do is it was clear the console, and then we're going to make like the name. This is the CPI manager, because we're going to get CPI data from the internet and then make the report. So the first thing that we're going to do is clear the console and get and display this name. And using Figlet, we can get some, and this is all with the user experience, we can get some pretty good UI using Ficlet and other kinds of things. We're also in the code. We also have spinners and stuff like that, and that just makes it so much more user friendly and good looking, and that makes a difference. So the next thing is that we provide all the the definitions, and not to go through all the manual typing. It's just what we saw before. So here we get all the definitions. So in this program we have path, and we're going to extract the value. So supply the path where you want it, and then also get the author name, email, contact, whether you want contact information style. Here we'll be able to choose the start, like what kind of color we want on the what do you call it, the graph, the chart that we have. And like we also have the version. The guide will be the guided input that we are going to get with Inquirer.js. So this is Commander.js in action. Here we have just a utility function. And now we have here all the steps that we need to go through in order to get the guided input from Inquirer.js. We have a flag here that will here. We've not implemented any of the flags here down in the control flow. We'll just do that in just a minute. But just in order not to forget it, we'll just quickly get all of these in here. So these are the steps that we will go through. So we will first have a welcome message, and then we'll have like an ask author, ask email, ask contact info, ask about which color chart, get the format time, stuff like that. We will not ask about the path. The path will just be the current directory, since if we go through like the step by step, we assume that maybe it's like less technical. It doesn't have to be. It's just annoying to type in a directory, so it will just be outputted into the current directory that the user is in. So now we come down to the control flow. So first we have we'll implement help and version, and that was just the same as before. If option help is used, then output help, and then we exit the process. So if help is there in one of the flags, it will output help, but it will not execute anything. You can change that if you want to, just not exit the process, and then it will just go through doing the rest. Next, we'll just go quickly through version. This looks a bit odd, but it works. Next, we'll go through the guided one. It will just be straightforward, as you probably would expect. Go through the current directory, if guide. So here again, it's if there's guide used, if help and version is not used, then we will just exit. And next we have quite a big code snippet that I'm not going to bore you with, but I'm just gonna put it in for good measure. So the manual one where we provide all the arguments that we need. So if any of the path, author, email, contact, then if any of those are provided, we're just gonna go through and execute the tasks. The reason why we just, if any of them are like selected, then we're going to go through and execute is because we're just going to fill in the different missing parameters in this case. But we could also have it, they need to be there, all of them, if that was what we needed. Yes. The last thing is that if we just have it, just have, like, let's say the name, or just run it with no arguments, then we want to like just the same. We want to as the help, we want to get out the help, and then that's it. And that's kind of the end of this line. So what we need now is all the prompts that we have not done yet. So these are here in this file. We've not, here's the welcome prompt. So here we'll use the sleep in the welcome prompt, and that's because in order to see like all the animations and stuff like that, we're going to use sleep a little bit throughout the application, because otherwise it'll just go way too fast and you will not be able to see the things that are actually being used. So in order to kind of save time, I'll just get all of these in. So here we have the whole welcome message. Then we have the ask author, which is what we saw earlier. What's your name? The next one is email, contact info, and stuff like that. Email will be the same. It will be type input. Here with the contact info, it will not be input, since it's much more since it's much easier to use confirm. The type confirm will just be a yes, no. And the next one will be ask about color. And now that's the list where we can choose between red, green, and blue. With the text-based input, as we saw earlier, if it's not one of the red, green, blue, it will simply not work. So right now we should be all set. So here, if we run npm build, we should be able to run here, and the application starts to run. We can see all the things. Version, let's see. Yes. So now we actually have a kind of a good basis for also generating reports now. So let's give a little bit of a longer input. So if we give this input, we'll output it into this directory, and this will be also just a straight one. Congratulations, you've gotten the PDF chart, blah, blah, blah. And then we, in this one, have the CSV, and we have the report, and we have the chart. And if we just change a little bit, we can have, let's say, we have this one to blue, and we have just this one to false. Then let's see what we get now. Here we go. We get blue and then no contact information down there below. Get this and this. So now we actually have a pretty cool tool. So if you then actually run build it and then use install it so it's on the machine, then actually if we have it then we have it on the system, so we can use it as a normal tool. So then if we then go over and say CPI manager and then help, it will just work normally. And then if we provide the G, we could go through the experience, get the latest report, name, .com, yes, and then we just take red, where we can tap through these ones, and then we fetch, and then it does everything, and then we have it over here. So that was demo time, and we're kind of going over time. So I just want to go through publishing quickly. To quickly go from this to publishing, we kind of have to get some few things in the package.json and then a few commands in the command line. But it's not a huge deal, and it's probably what your organization is used to. So doing that and consuming them like that is probably a really good way to go. So sharing and feedback, we talked about it earlier. So the best practices for doing that is, provide great documentation. This is the window into your kind of environment, kind of like your world. We've all worked on things that had terrible documentation, and if yours has terrible documentation as well, it will not be a great thing for adoption. If it's a groundbreaking tool, providing workshops, training is really good. Workshops can also be through like normal, Friday meetings where people share what they've learned throughout the week, a month, stuff like that. Sharing it through internal communication channels and also internal code repositories for the organization is also hugely important. And as I said, not everything must be automated, but automate all the things that should be. It's great, it's fun, and I can only highly recommend it. So hopefully you've gotten something out of this talk. You've kind of gotten like how to use it, how to what kind of structures you use. You've also seen how to do TypeScript. It's like hopefully this has kickstarted everything so that you will start kind of integrating the development of command line interface tools into your organization, or at least into your private workflow when you're developing things for yourself. And I want to leave you with this. So if the message hasn't sunk through, spend your time on where you like it's valuable. If it's for learning purposes, by all means do it, but don't sink an extraordinary amount of data into work that is non-essential. And this great piece of work is taken from Programming Humor, some Reddit thread. I have to link it in the show notes. But yeah, thanks for watching my talk, and I hope you have had a great event. Thank you.
Okay, so thank you, Rasmus. We invite you to the live stream. Thank you for a great presentation.
Thank you for inviting me.
Yeah. How did you choose this topic?
Like, I think I love automating things that are like, these common annoying tasks, so scaffolding new projects, like doing all of these things that like save me an extra like half an hour, 20 minutes here, 10 minutes there. So, like sharing how to get other people started on kind of that, automating their own work is great. Like,
I really enjoyed it. It's my first time when I saw this kind of topic put into code. So
but like
that's why
a lot of people use command line tools because a lot of installers, a lot of like scaffolding of projects. So a lot of people use them, but like actually doing them themselves is.
This is what I was referring to. Like we do it on a daily basis. We use a CLI, but at the end of the day, I don't know how many of us wonder how it is made or who thought of that. But it was wonderful of you to share this with us.
Thank you. Yeah, I just was sitting here on the backstage, but I couldn't be silent. So hi, Rasmus and Adina again. I just want to say that Rasmus is not first time here. We really love and adore his talks. Every time I'm texting, like, please send me something, it will be, because I know that it will be really something good. Also, he is an amazing moderator as well. This time he kept this proposition, but he's really amazing moderator. Thank you for your speech. I think since it's last topic, might you wait for 1 minute more? We'll see how it is. I want to wish everybody amazing rest of the morning, evening, night, whatever it is, to have some great time, to have some fun. I hope that you received a lot of good information and you could renew something or just to get something useful for yourself. And don't forget that tomorrow we have second day. So yes, tomorrow we have day for senior developers. Please join us. It will be really great. I think that for now we don't have any questions. Adina and Rasmus, thank you so much for joining us, for being with us the last moment. and hope to see you at our next events. Yeah, we have a Flutter event, we have React event. So anyway, I'll contact you as well. Don't worry, we'll be in touch.
I'll sure tune in even for the junior tracks, because your event, it's awesome, and you have organized it so well. So I really
Thank
love
you so
your speakers and the topics that you choose.
Thank you. Thank you so much. It's really, really, really nice. So, okay, see you and have an amazing evening.
See you tomorrow.
See you.
See you.